The digital space is a world of connection and opportunity. But take this moment, for example.
The web has made it possible for you to enroll in this program, where you'll learn from the personal stories of developers at Meta.
By the time you have completed this professional certificate, you can become a creator of digital experiences. Connection is evolving, and so are you.
You might not have a background in tech at all, and that's okay. Even if you have no experience, this program can get you job ready within a single year.
So how can this professional certificate prepare you for a job at an organization like Meta?
The Database Engineer Professional Certificate will help you build job-ready skills for a database engineering role while earning a credential from Meta.
From Meta engineers, you will learn about how they collaborate to create and test high-performance databases.
You'll also discuss interesting topics with other aspiring database engineers.
And complete a range of coding exercises to improve your skills.
It's important to complete all the courses in this certificate in order, as each course will build on your skills.
Although we have a recommended schedule for each course, the program is entirely self-paced, which means your time is your own to manage.
As you make your way through the courses in the certificate,
You'll learn how to model and structure a database according to best practice and create, manage and manipulate data using SQL, one of the most widely used languages for working with databases.
You'll also learn how to use the Django web framework to connect the front end of a web application to your database.
For your final project, you will create a functional relational database designed and developed with best practice architecture
To showcase as part of your portfolio during your job search.
you'll also be ready to collaborate with other developers as you will have learned to use Git and Github for version control.
In the final course, you will prepare for the coding interview. You'll practice your interview skills, refine your resume, and tackle some common coding challenges that typically form part of technical job interviews.
Once you complete the program, you'll get access to the Meta Career Program's job board.
a job search platform that connects you with over 200 employers who've committed to sourcing talent through Meta's certificate programs.
Who knows where you will end up? Whatever the future of connection looks like, you'll be part of its creation. Let's get started.
Hello and welcome to this course on database engineering. Almost everyone has used a database, and more likely, information about us is probably present in many databases all over the world. But who understands what a database is and how important database engineering is to global industry, government, and organizations? A very straightforward description of a database is that it is a form of electronic storage in which data is held. Of course, that explanation does not even come close to explaining the impact of database technology. To give an idea of databases in a real-world context, let's briefly describe some typical use cases. For example, your bank uses a database to store data for customers, bank accounts, and transactions. A hospital stores patient data, staff data, laboratory data, and more. And an online store retains your profile information along with your shopping history and accounting transactions. Many of these services have access to a diverse range of data. They collect and store other items such as your location, how long you spend on their platform, and friends you connected with, alongside many more facts. Such online services and social media platforms generate enormous amounts of data due to their large user base and constant user activity. And with the Internet of Things, or IoT, many extra devices are now connected to the Internet. These continual streams of data have led to a revolution in database technology to accommodate the volume, variety, and complexity of what has become known as big data. Whatever the source of the data, a database will typically carry out the following actions, all of which a database engineer must be familiar with. Store the data, form connections or relationships between segmented areas of the data, filter the data to show relevant records, search data to return matching records, and have functions to allow the data to be updated, changed, and deleted as required. Don't worry if you don't fully understand all these terms. For now, you're just receiving a brief introduction to databases and data. During the course, you'll explore these concepts in more detail, alongside the many other tasks that form the duties of a database engineer. You'll learn about the concepts of data and databases, how data is related in a database, and different database structures and their uses, how to perform, create, read, update, and delete operations, how to use SQL operators to sort and filter data, what database normalization is, and how to normalize a database. You'll get to build a fully operational database, And you'll also install and set up software called XAMPP on your computer to help progress your local and remote database learning. You're not expected to be a database engineer just now. There are many videos in your course that will gradually guide you toward that goal. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then consolidate your knowledge by consulting the course readings, and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. And you're not alone in considering a career as a database engineer, which is why you'll also work with course discussion prompts that enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To be successful in this course, it is helpful to commit to a regular and disciplined approach to learning. You need to be serious about your study, and if possible, map out a study schedule with dates and times that you can devote to attending the course. It's an online, self-paced course, but it does help to think of your study in terms of regular attendance at a learning institute. In summary, this course provides you with a complete introduction to databases, and it's part of a program of courses that lead you toward a career in database engineering.
I really like this idea that in the end, we're all solving human problems through technology. And we're not, as a software engineer, my role is not to simply develop technological solutions. They need to have this human outcome. I'm Daniel Bloomfield-Ramagem. I'm a software engineer for Meta. I joined the company in 2017, and I work out of our Washington, D.C. office. I immediately think of my mother's recipe book, which is a spiral notebook. So she keeps her recipes in a spiral notebook. Every page has a number, and she keeps kind of an index at the beginning of that notebook so she can easily find the recipe. Well, that's a database. So, my mom is a database engineer, perhaps, or not engineer, but certainly she relies and has created her databases. So I like that fun kind of example because it shows the range of things that are possible once you store data in a structured way that can be easily retrieved. And so it's the recipe book, but it's also, the picture I just shared on Facebook that now my friends get to see anywhere they are in the world so quickly. All that is powered by a lot of infrastructure, databases at the core. I think data is at the heart of every application. And so learning to create an effective data layer that can provide the user with quick responses, accurate responses, and results is really critical. And as a database engineer in particular, I think you are involved in such a critical component of building applications, and you have such a large influence on everything else that follows from the data. So that includes the user interface. It includes the clients, the APIs, like all of that gets influenced by how the data layer gets modeled, stored, and all the characteristics of being able to retrieve that data effectively and making it the consumption of that information easy for the rest of the tech stack. So you have a really large influence, and I hope you walk away knowing that you have this very large influence on the development of applications. So technical skills I use on a daily basis. Certainly I code, and when I say code, I mean not only I program using kind of a standard programming languages for web, but I also work in the database space by creating the pipelines that produce, that extract, transform, and load a lot of the data that makes its way into the applications that we develop. The soft skills I use on a daily basis certainly include a lot of communication and organization. It's easy you come out of school and you're so excited about the coding, the technical skills you've learned, and those are obviously very, very important. But I thought code was king. I'm here to program. And, I expect people to understand the output of what I'm making. And I learned that is insufficient. And I saw great examples of people who were doing great technically, but they were excelling furthermore on just being able to explain what they were doing, not only to the team internally, but to the people who are going to maybe use those features in the tool set. The perfect is the enemy of the good. Particularly, I think with database development, it's easy to overcomplicate solutions, and especially when you're doing data modeling and data storage. You want to cover every possible variation of data, every different use case, edge case for using that data. And that can lead you down the path of creating very complex data schemas that become hard to maintain, can be not well performant. So you need to iterate on your work. For databases, I would say, try to focus on the here and now needs of data. Be especially mindful of these perceived needs for massive data scalability, which may, again, lead you to overcomplicate your solution when in fact you might need something much smaller scale, at least to kick off and get better understanding of what the feature and the data requirements truly are. So start small, iterate frequently. Write more often. And I know usually when you think of engineers or database programmers, you think the output of your work is, it's the program, it's the code, it's the SQL queries. And yes, it is, but that alone I think is insufficient. So complement that with writing. Now, what are you going to write about? Well, certainly there's documentation that goes along with your code. I have a good colleague at Meta that always tells me when I said I'm done with something, he looks at me and says, "Are you done?" And I said, the first time he said it, I was like, "Yes, I'm done." And he followed up with, is your documentation ready? Is your code checked in the right places? Is the wiki page updated? Did you write a post about this? And so he emphasized the importance of code is the 80%, 20% is that additional communication that's needed. So I would say write more often. Don't be afraid to write imperfectly. Write something, put something out there, whether it's sharing the status of something that you're doing, whether it's just enhancing documentation for something that you're working on. Get into the habit of writing more often. Try to take what you're learning and connect it to something practical that you can see a use for. Whether it's learning about databases and thinking about a recipe book that your mother or father has in a spiral notebook, or maybe baseball cards that you tracked as a child, or comic books that you tracked as a child. Try to think of ways to apply what you're learning technically to these real life problems. They can be small problems like finding the recipes at the right time, but they can be, of course, bigger, more perhaps interesting problems around just technical and digital communication between people.
We all use data and databases in our daily online lives. For example, uploading photos to our social media feeds, downloading files at work, and playing games online are all examples of database usage. But what exactly is data, and how does it interact with a database? If you're struggling to answer these questions, don't worry. By the end of this video, you'll be able to describe what a database is at a conceptual level, identify real-world examples of the use of databases, and demonstrate an understanding of how data is organized in a database. So, let's return to the first of our questions. What is data? In basic terms, data is facts and figures about, well, anything. For example, if data were collected on a person, then that data might include their name, age, email, and date of birth. Or the data could be facts and figures related to an online purchase. This could be the order number, description, order quantity and date, and even the customer's email. Data is crucial for individuals as well as organizations. But where is all this data stored? In our digital world, data is no longer stored in manual files. Instead, developers use something called databases. A database is a form of electronic storage in which data is organized systematically. It stores and manipulates data electronically to make it more manageable, efficient, and secure. There are many real-world examples of where databases are used. For example, a bank can use a database to store data for its customers, bank accounts, and transactions. And a hospital uses a database to store patient data, staff data, laboratory data, and much more. At this point, you might be asking yourself, but what does a database actually look like? Well, a database looks like data organized systematically, and this organization typically looks like a spreadsheet or a table. What exactly does the term systematic mean? All data contains elements or features and attributes by which they can be identified. For example, a person can be identified by attributes like their age, height, or hair color, and this data is separated and stored in what's known as entities that represent those elements. As you just learned, an entity is like a table. It contains rows and columns that store data relating to a specific element. In other words, these are relational elements. They're related to one another. These entities could be physical representations, like an employee, a customer, or a product, or they could be conceptual, like an order, an invoice, or quotation. Entities then store data in a table-like format against the attributes or features related to the element. For example, an online store could hold customers' data in a customer entity containing specific attributes relating to the customer. These attributes could include first name, last name, date of birth, and email. And they could also have product data stored in a product entity against attributes like product code, description, price, and availability. In the relational database world, these entities are known as relations or tables. The attributes become the columns of the table, and each table row represents an instance of that entity. As an example, let's take the entities from the online store example that you just explored. These two examples could be combined into a list of orders the store received from its customers. Within a database, this data could be rendered as an order table or entity, and the data could be organized into rows that contain a unique order number, the name of the customer who placed the order, the product that they ordered, and the price of that product. There are many ways to organize data in a database. Relational databases aren't the only kind of databases that you'll encounter. As a database engineer, you'll work with many different types of databases. Here's a few common examples of other types of databases. An object-oriented database is where data is stored in the form of objects instead of tables or relations. An example of this kind of database could be an online bookstore. The store's database could render authors, customers, books, and publishers as classes, like sets or categories. The objects, or instances of these classes, would then hold the actual data. Graph databases store data in the form of nodes. In this case, entities like customers, orders, and products are represented as nodes. The relationships between them are represented as edges. And finally, there's document databases where data is stored as JSON, or JavaScript Object Notation objects. The data is organized into collections like tables. Within each collection are documents written in JSON that record data. So in this example, customer documents are held in a customer collection, while order and product documents are stored in the order and product collections. But where are the databases themselves stored? A database can be hosted on a dedicated machine within the premises of an organization, or it could be hosted on the cloud. Cloud databases are currently a more popular choice. This is because they allow you to store, manage, and retrieve data through a cloud platform and access data through the internet. And they all provide a lower cost option for data management than other similar options. You should now understand the concept of a database. You should also be able to identify examples of databases and demonstrate how data is organized within a database. Great start. You'll be storing and managing data in no time. Picture yourself in the following scenario. You're managing the database of a large online store. Your database must be able to retrieve a customer's details from one table and then find the order recorded against another table. So how does the database establish a relationship between these pieces of data? Over the next few minutes, you'll explore this process, and by the end of this video, you'll be able to explain why data in a database should be related and identify an instance of related data in a database. Data stored in a database cannot exist in isolation. It must have a relationship with other data so that it can be processed into meaningful information. So how do you make sure that all the data in your database is related? Let's explore how data is related by using the online store as our example. In the database of your online store, you could have an order table and a customer table. To locate the details of a customer's order, you would check the order number against the customer ID. In other words, the database establishes a link between the data and the tables. Let's look at the customer table in more detail. In this table, the columns are customer ID, first name, last name, and email. In relational database terms, these are fields. Then there are several rows which contain data for each of these fields. In relational databases, they are known as records of the table. So, all these fields and rows work together to store information on the customer, also known as the entity. Every row and record in the customer table is an instance of the customer entity. For example, Sarah Hogan, who has a customer ID of C1, is one customer instance. And Katrina Langley, who has a customer ID of C4, is another customer instance. What's most important is that each of these customer instances, or records, must be uniquely identifiable. But what if two or more customers share similar info, like the same first name or last name? To avoid this confusion within the database, you can use a field that contains only unique values like the customer ID. This is called a primary key field. It contains unique values that cannot be replicated elsewhere in the table. So even if two customers share the same name, they'll still have separate customer IDs. This means that your database can determine which customer is the required one. Let's look at the order table next. Just like the customer table, the order table also has fields and records. And in this table, the primary key field is the order ID. But there's also a field named customer ID with the exact same data as the customer data. So what is the purpose of the customer ID in this table? The customer ID is there to help identify who it is that placed the order. So by adding the customer ID field to the order table, a relationship is established between the customer table and the order table. And because of this relationship, you can pull data in a meaningful way from both tables. The customer ID field in the order table is known as the foreign key field. A foreign key is a field in one table that connects to the primary key field in the original table, which in this case is the customer table. So the customer ID is the primary key of the customer table, but it becomes the foreign key in the order table. This way, the relationship is established and the data in these two tables are related. You should now be able to explain the relationships between data in a database and identify instances of related data. Great work. You've probably heard of terms like big data and cloud databases. Maybe you've even encountered them in this course. But do you know what they mean? In this video, you'll discover more about these terms and you'll be able to identify different types of databases and explain how databases have evolved in response to new trends like big data. Databases have been around for a long time and have been influenced by many different trends, but they've undergone a huge change in recent decades. Thanks to the growth of the internet, they now must be able to store ever-increasing amounts of unstructured data. However, this poses difficulties, as they mostly store structured data. Let's briefly look at some of the different types of databases and how they've been affected by this trend. Relational databases have limitations when it comes to storing data because they mostly store structured data. Yet databases are now required to store more and more unstructured data. So the trend in recent years has been to rely on NoSQL databases instead. NoSQL databases are a type of database that store data in a variety of different formats. Essentially, they provide databases with a flexible structure. This makes scaling easy by facilitating a change to the database structure itself without the need for complex data models. NoSQL databases are used by social media platforms, the Internet of Things, artificial intelligence, and other applications that generate massive amounts of unstructured data. Types of NoSQL databases include document databases, key-value databases, and graph databases. Now that you're familiar with different types of databases, let's take a closer look at big data and cloud databases. Essentially, these terms are used to describe a recent change in our approach to data and databases. Let's start with a look at big data. Big data is complex data that can increase in volume with time. In other words, it's data that can grow exponentially with time. But where does this kind of complex data come from? Social media platforms, online shopping sites, and other services generate massive amounts of data every second of the day as they capture the actions of billions of users around the world. And with the Internet of Things, or IoT, more and more devices are connected to the Internet, generating even more and more data. This is how complex data, or big data, is created. All this data is highly unstructured or semi-structured. Traditional database systems could deal with structured data using tables, records, and relationships. But big data is a whole new challenge. Big data is a combination of structured, semi-structured, and unstructured data collected from many different sources. And it adds more power to data because it can address complex business problems that traditionally structured data can't handle. Finally, big data helps to provide unique insights that can help to improve decision-making, so it's highly valued across many industries. For example, the manufacturing sector processes big data to predict equipment failure by evaluating the current state of machinery, assess production processes by monitoring the production line, respond to customer feedback proactively, and anticipate future demands by monitoring current sales. Retail processes big data to anticipate customer demand, improve customer experience, analyze customer behavior and spending patterns, and identify pricing improvement opportunities. And the telecommunications sector utilizes big data analytics and network usage analytics to plan for infrastructure investments, design new services that meet customer demands, analyze service quality data to predict customer satisfaction, and plan for customer retention mechanisms. Now that you're familiar with big data and how it helps to power businesses, let's move on to another trend in databases: the use of cloud databases. Organizations are moving to the cloud to free themselves from the difficulties of dealing with the infrastructure of physical servers, like maintenance and storage costs. Some examples of cloud storage services include Dropbox and iCloud. With these cloud storage services, it's possible to store documents and other data on the cloud, a much more affordable solution. Another trend in databases is business intelligence, or BI. Traditionally, databases were just a means of storing data, but organizations now utilize their data with business intelligence-related technologies and strategies. With these technologies, organizations can analyze their data and extract valuable information to help them to make informed business decisions. New trends are constantly emerging in database technology, and they'll keep advancing with time. But for now, these are a few of the leading trends that you should be aware of. At this stage in the course, you're probably familiar with the basics of databases and how they store and manage data. But it's also important that you know how to interact with databases in order to work with data. As a data engineer, you can interact with databases using structured query language, or as it's more commonly known, SQL, also pronounced as SQL. Over the next few minutes, you'll learn how to explain what SQL is and outline the role of SQL in databases. So what sort of interactions do database engineers need to establish with databases? Some of the operations you could carry out in the data might require you to create, read, update, and delete data. These operations are also known as CRUD operations. You might already be familiar with some of these operations. If not, don't worry. They'll be covered in depth at later stages in this course. Let's find out more about SQL. SQL is a standard language that can be used with all databases. It's particularly useful when working with relational databases, which require a language that can interact with structured data. Some examples of relational databases that SQL can interact with include MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. The next question this raises is, how does a database interpret or read and execute instructions given using SQL? A database interprets and makes sense of SQL instructions with the use of a database management system, or DBMS. As a web developer, you'll execute all SQL instructions on a database using a DBMS. The DBMS takes responsibility for transforming SQL instructions into a form that's understood by the underlying database. This was just a very quick introduction to SQL. At this early stage, you should be able to explain what SQL is and explain the role of SQL in databases. In the upcoming videos, you'll learn more about SQL and develop a deeper understanding of the language. Imagine that you've just been hired to create a database for a college. First, you'd need to create tables to hold data in all aspects of the college. Then you'd need to insert data into these tables, and then modify this data whenever something changes. That's a lot of work, but it's all possible with the use of SQL and CRUD operations. Not familiar with these operations? No problem. Over the next few minutes, you'll learn how to explain the tasks that SQL syntax is used for when building a database, and demonstrate an understanding of the SQL subsets and sublanguages. So, let's return to our college database scenario. How can you possibly make all these changes in the database? Well, with the help of what web developers call CRUD operations. Performing CRUD operations is the most common task when working with a database. CRUD stands for create, read, update, and delete. Or in operational terms, create, add or insert data, read data, update existing data, and delete data. Alongside these operations, there are many other things that SQL can do. Depending on what SQL is used for, it can be divided into many subsections or sublanguages. These include DDL, or Data Definition Language, DML, also known as Data Manipulation Language, DQL, or Data Query Language, and DCL, also called Data Control Language. Let's take a closer look at these languages and their commands, starting with Data Definition Language, or DDL. DDL, as the name says, helps you define data in your database. But what does it mean to define data? Before you can store data in the database, you need to create the database and related objects like tables in which your data will be stored. For this, the DDL part of SQL has a command named create. Then you might need to modify already created database objects. For example, you might need to modify the structure of a table by adding a new column. You can perform this task with the DDL alter command. You can remove an object like a table from a database using the DDL drop command. Data Manipulation Language, or DML commands, are used to manipulate data in the database, like inserting, updating, or deleting data. Most CRUD operations fall under DML. To add data to a table, you can use the insert command. This command lets you specify the fields to add data to, along with the values to be inserted. If you need to edit data that's already inserted into a table, just deploy the update command. And you can specify data to be removed by using the delete command. So far, you've learned how to add database objects and manage data within them. So how do you read or retrieve that data? To read data stored in a database, you can use Data Query Language. DQL defines the select command to be able to retrieve data. Select lets you retrieve data from one or multiple tables, letting you specify the data fields that you want based on preferred filter criteria. And finally, you can also use DCL, or Data Control Language, to control access to the database. For example, using DCL commands, you control access to data stored in the database. Grant and revoke DDL commands are used to give users access privileges to data and to revert access privileges already given to users. You should now be familiar with how SQL acts as the interface between the database and its users. And you should also be able to identify SQL operations in sublanguages. Great work. By now, you're most likely familiar with the basics of databases, and you might even have come across some simple SQL syntax. But why do developers use SQL to interact with databases? SQL is a popular language choice for databases because of the many advantages that it offers. Now, over the next few minutes, you'll identify the advantages of SQL and demonstrate how the advantages of SQL assist with database tasks. SQL is the interface or bridge between a relational database and its users, and offers web developers a wide range of advantages. Let's look at a few of them. The biggest advantage of SQL is that it requires very little coding skills to use. It's just a set of keywords. There aren't many lines of code required to perform basic CRUD operations, or add, create, update, and delete tasks on the database. So it's a very developer or user-friendly language. SQL's interactivity makes it even more user-friendly because it lets developers write complex queries in a short space of time. So, if you need to work with relational databases for your next project, you just need to know what keywords to use and when. SQL is also a standard language that can be used with all relational databases, like MySQL. This also means that there's a lot of support and information available. So, SQL can run on any computer once you have database software installed. SQL is also a portable language. Once you write your code, it can then be used on any hardware and any operating system or platform, wherever you need. So if you write SQL code in a desktop and then move it to a production server environment, it will run the same in both locations. Also, SQL is a comprehensive language that covers all areas of database management and administration. For example, it allows you to create databases, insert, update, and delete data, retrieve and share data among multiple users, and manage database security. This is made possible through subsets of SQL, like DDL, or Data Definition Language, DML, also known as Data Manipulation Language, DQL, or Data Query Language, and DCL, also known as Data Control Language. And the final advantage of SQL is that it lets database users process large amounts of data quickly and efficiently. You now know that SQL is a simple, standard, portable, comprehensive, and efficient language that can be used to communicate and work with relational databases. You're well on your way to mastering SQL. Well done. As you might already know, you can interact with the database using SQL. But just like with other coding languages, you need experience with SQL syntax and its subsets before you can make use of it. Over the next few minutes, you'll learn how to create a database using the Data Definition Language, or DDL subset of SQL, utilize the Data Manipulation Language, also known as the DML subset, to populate and modify data in a database, and read and query data within databases using the Data Query Language, or DQL subset of SQL. In order to demonstrate SQL's syntax and its subsets, I'm going to show you the SQL commands that can be used to develop a database for a college. However, take note that the demonstration which follows will only briefly show each step in the process. You just need to develop a working familiarity with SQL for now. You'll explore the language and its subsets in much more detail later in this program. The first task is to create the database. To do this, I write a create statement using SQL's DDL subset. So, the syntax to create a database is create database, followed by the name of the database. I then place a semicolon at the end of the statement. Let's create a college database as an example using the syntax create database college. Once you've created a database, the next step is to create the tables. You can create tables using the create table syntax, followed by the table name. Just repeat these same steps for each new table you want to add to your database. I can use this syntax to create a student table in my college database. This table will hold information on each student. To create the table, I just write create table student. Now I need to populate the table with data. This is where I can use the Data Manipulation Language, or DML subset of SQL. To add table data, I use the insert into syntax. This inserts rows of data into a given table. I just type insert into, followed by the table name, and then a list of required columns or fields within a pair of parentheses. Then I add the values keyword and specify in order the values for each of the fields. As an example, let's add data to the student table in our college database. I'll use the student table I created earlier and add student data to it by specifying values for each of the following columns: ID, first name, last name, and date of birth, and then populate the table with the required data. But what if I need to update or modify data? For example, let's say I've input the wrong date of birth for a student. To change this data, I can use the update syntax, which is part of the DML subset of SQL. First, I add the update keyword, followed by the student table name. Then I use the set keyword, followed by columns and values I want to update, written as key value pairings. In this instance, it's the date of birth column and a new date of birth value. Finally, I add the where clause and a condition to filter the records I need. For example, to change the data for the student with the ID of 2, I can type where ID equal to 2. It's also possible to delete data from a table. Let's delete the table record for the student with the ID of 3 using the delete syntax. First, I type delete from, then the table name. This tells MySQL where the data must be deleted from. This is followed by the where clause and a condition such as ID equal to 3, which would remove all data on row 3 of the table. So I could instruct MySQL to remove the data of the student on row 3. Once I run the statement, the student's data is removed from my table. You're now familiar with how to add, update, or delete data in a database. But how would you read data stored in your database tables? That's where SQL's DQL, or Data Query Language, comes in. The main syntax of DQL is select. As its name says, it's used to select data from the database. A select statement is written using the select keyword, followed by the columns that hold the data you required. You then write the from keyword, followed by the name of the table you want to select data from. As an example, you could use the select statement to query the student table to find the name of the student with an ID of 1. You would just need to add the where keyword, followed by the student's ID. This would then return the name of John Murphy. You're now familiar with the basics of SQL syntax and its subsets. Don't worry if you're still trying to figure out these subsets. You'll explore each of them in more depth later in this specialization, and you'll also get an opportunity to try them for yourself. At this stage of the course, you're probably familiar with the basics of how databases store and interact with data. But how do they store all this data and present it in a logical way? In the form of tables. By the end of this video, you'll be able to outline what a database table is at a conceptual level, and explain how data is structured in a database table. As you probably already know, the table is made up of rows and columns which hold data, and a table is stored in a database. In a database that holds multiple tables, these tables are known as relations, as they all relate to one another. In a more conceptual or logical sense, a table is also known as an entity. And in object-oriented databases, or OODB, an entity is an object that has attributes that are like columns or fields in a table. So in essence, a table, entity, and object all refer to the same concept. Within every table are columns, also sometimes called fields or attributes. Each column or field has a unique name and data type. For example, I have a table that contains data on employees in a company. The table organizes the data into columns such as ID and role, and each column can hold different types of data, like numeric or string. A set of columns or fields form a row. In relational database terminology, a row is known as a record. So a record is a combination of columns or fields that contain data. In my employee table, for example, each row is a single employee record. Let's return to columns for a moment. As you now know, every column has a data type. The data type of a column defines what type of value a column can hold, like integer, character, date and time, and so on. It's up to the developer to decide the data type for each column. And it's also a guideline for SQL around what data type to expect in each column and how to interact with the underlying data stored physically. However, data types can vary depending on the database system. For example, you might have different types for MySQL, SQL Server, or Access. Always refer to the documentation of the relevant database system to check what data types it supports. Generally, all database systems support string data types for storing characters in strings of characters, numeric data types to store exact or whole numbers and approximate numbers, date and time data types to store information on date and time, and binary data types to store images, files, and other information. Another important concept related to tables is domains. A domain is the set of legal values that can be assigned to an attribute. Basically, this means making sure that the values a field can hold are well defined. For example, you can only place numbers in a numerical domain, and you can only place characters or strings of characters in a string domain. And each of these domains must include length, values, and other relevant rules that define its function. Each row or record in a table is also uniquely identified by what's known as a primary key. A column in the table that has unique values will become the primary key of the table. In the employee table, for example, the ID column is the primary key as each ID is unique. This is because the other columns could contain repeating values. For example, two employees may share the same name or role. It's also possible for a primary key to be a combination of columns if a single column alone doesn't possess unique values. You should now be familiar with what a database is and be able to explain how it is structured. You should also be able to explain key concepts such as columns, rows, and keys. Great work. At this stage of the course, you're probably familiar with the relational database model. But to fully understand how a relational database model works, you first need to understand how tables within a database are related. Essentially, relationships are established between tables with the use of keys. By the end of this video, you'll be able to identify the main keys used in tables in a relational database and explain the relationship between keys in a table. The relational database model is based on two main concepts: entities, which are defined as tables, and relations that connect to related tables. To realize how this model works, you need to understand the different key attributes that exist in the relational database. To demonstrate, let's use the example of a sports competition that uses three tables to keep track of the league: the league table, the teams table, and the points table. Each table has relevant columns, where each column represents an attribute of the table entity. The league table keeps track of each team's position in the league, their name, and the state they represent. The team's table tracks the team name, the team captain, and the team coach, and the points table records the team's position in the league, the team's name, and how many points the team has this season. Notice that the teams table includes team name, which also belongs to the league table. These attributes could be of a simple attribute type that can hold a single value. For example, in a table of staff members in a college, each staff name attribute has a single value in each row. Or they could also have a multi-value attribute that can have multiple values, like a list of subjects taught. However, multi-value attributes should be avoided in relational database design. You'll learn more about this concept later in the course. Let's use the example of the staff table to explore some examples of attribute keys. Let's begin with the key attribute. This is a value used to uniquely identify an individual record of data in a table. For example, in the staff table, the key attribute is staff ID. This attribute has unique value in each row of the table, so it's the perfect way to uniquely identify each record of data. In a relational database, there are a range of different types of key attributes. There's also the candidate key attribute. This is any attribute that contains a unique value in each row of the table. In the case of the staff table, both the staff ID and contact numbers are examples of candidate keys. Each has a new unique value in each row. The other columns can contain repeated information, so they're designated as non-key attributes. A composite key is a key that is composed of two or more attributes to form a unique value in each new row. In the staff table, an example of a composite key is a combination of the staff name and staff title, assuming that there isn't another instance of the same combination elsewhere in the table. A composite key is usually considered when a single attribute key can't be identified. A relational database must also contain a primary key, which you should already be familiar with. In the staff table, the staff ID is the primary key. An alternate key, also known as the secondary key, is a candidate key that was not selected to be the primary key. Just like a primary key, it's a column that contains a unique value in each field. For the staff table, the contact number is the secondary key on each row. And finally, there's a foreign key. The foreign key is an attribute in a table that references a unique key in another table. Typically, a foreign key references the primary key of another table. For example, the staff ID might also be a foreign key in one or more tables within a college database. The relationship between primary and foreign keys will be discussed in more detail at a later point in this course. You're now familiar with the different types of keys in a relational database. You've reached the end of this module on Introduction to Databases. In this module, you've discovered the basics of databases and data, received an intro to SQL, or structured query language, and explored the basic structure of a database. It's now time to recap the key points and concepts you learned and skills that you gained. You began the module with an introduction to databases and data. Following the completion of this first lesson, you can now provide an overview of what a database is at a conceptual level, outline real-world examples of database usage, and explain how data is organized within a database. You can now also explain the importance of related data within a database, identify an instance of related data within a database, and provide an overview of new trends in database applications. You're also able to identify different types of databases and provide a high-level overview of how databases have evolved. Following your exploration of databases and data, you were then introduced to SQL. This lesson focused on the basics of SQL, or structured query language. During this lesson, you learned how to outline the purposes of SQL and demonstrate an understanding of the role of SQL in databases. You can also identify the advantages of SQL, such as its low entry level, its wide range of applications, and its portability across operating systems. And you can also explain how these advantages will assist you when working with databases. And you're also able to provide a high-level overview of how SQL, DDL, DML, and DQL syntax is used, and identify the main SQL commands used in databases. In the final lesson of this module, you explored basic database structure. Now that you've reached the end of this lesson, you can explain the concept of a database table and outline what it's used for, and identify the key components of a database table, such as columns, rows, data types, and keys. You are now familiar with the basics of databases. You can explain how they store data, identify methods for interacting with databases through SQL, and outline the basic structure of a database. That's a great start to your database journey. Well done. You probably know that database tables store data in the forms of columns and rows. But how do you make sure that every column accepts the correct type of data? For instance, that your cost column stores values in decimal, or your product quantity column accepts positive numbers. This is exactly what data types do. With data types, you can determine what kind of data is accepted by each field in your table. Over the next few minutes, you'll learn how to explain a numeric data type in a database and differentiate between integer and decimal data types. Before you begin exploring numeric data types, let's take a moment to explore the concept of data types. When you create a table in a database, you need to define column names and the data type of the content that will reside in those columns. Data type tells a database management system, such as MySQL, how to interpret the value of the column. Data types maintain data in the right format and make sure the value of each column is as expected. The most used data types are numeric, string, and date and time data types. Let's take the example of a table from the database of an online store. This table collects information on customers in the form of columns called customer name, order date, product quantity, and total price. Each of these columns must store data in the form of a suitable data type. The customer name column can use string data, order date can use a date type, and product quantity and total price columns are best suited to numeric data. The focus of this video is the numeric data type. Numeric data types is the generic term used for all specific data types that let a column store data as numbers in the database. The two most common numeric data types used in databases are the integer data type, used for a whole number value, and the decimal data type, used for a number with a fraction value. To return to our earlier table example, the product quantity column is defined as an integer data type. This is because it holds whole numbers only. Fractional numbers can be inserted, but they'll always be automatically rounded up or down to the nearest whole number in the database. And the total price column is a decimal type. This is because it holds fractional numbers. For example, an item that costs $80.90 is a fractional value. 80 is a whole number, and 90 is a decimal. Whole numbers can also be inserted. The database will add a decimal point along with a fractional value of 0. In most database management systems, you'll find different types of integer and decimal data types. Each type is intended to store a minimum and a maximum number value. For example, in MySQL database management system, tiny integer, or tinyint, is used for a very small integer number value where the maximal possible value that can be inserted is 255. While integer or int can be used to store a very big number, the maximum value that it can store is over 4 billion. These data types can also accept negative and positive values. In some database management systems, you can also force columns to accept positive numbers. This increases the maximum value they can store. You should now be able to explain the numeric data type in a database, and you should also be capable of differentiating between integer and decimal data types. Great work. You probably already know that when you create a table in a database, you must define the column names and the data type of the content that will reside in those columns. You can use a string data type to define a column's data type, particularly in instances when it accepts both numeric and text characters. In this video, you'll explore the string data type, and by the end of the video, you'll be able to explain the string data type in a database and differentiate between char and varchar data types. When you create a table in a database, it is important for data integrity to ensure that only valid values are inserted in your table. For example, you should use string data type when you intend to store data that contains a mix of character types. So if you define a column as a string, then any type of text can be inserted. This includes alphabet characters, numeric characters, and special characters. Let's explore an example to find out more about how string data types work. Let's take the example of a student table from a college database. This table stores student login information for the college's online portal. It stores this information under the following 4 columns: student name, username, password, and email address. The student name column contains only alphabet characters. The username column contains alphanumeric characters, and the password and email column contains a mix of character types. String data type is a generic term used for different string data types in the database. The most used string data types are char, which stands for character, This data type is used to hold characters of a fixed length, and varchar stands for variable character. This holds characters of a variable length. Let's explore these string data types further. Char means that the given length of the characters is predetermined. It can't be changed after declaration. Column attributes are defined as char followed by a character length in parentheses. For example, char 50 means that a column only permits 50 characters of space in each field. Char is the best option if you have a predefined size of character that you want to maintain. In the student table, you can set a maximum length of 50 characters for the username column in SQL with char 50. For example, the table contains the records for a student with the username Mark123, which is a total of 7 characters. However, because the column is defined as char 50, this username occupies a length of 50 characters within a space. The varchar data type works in a similar way to char. However, it is a variable length. This means that the length can be changed, it's not fixed. Varchar is often used when you're not sure how many characters might be inserted in a column field. So you can type varchar 50 in SQL to allow for any input up to a maximum of 50 characters. In the student table example, the student name column would most likely contain names of varying length. So you could define the student name column as varchar 50 in SQL. This means that the name of each student only occupies as much space as there are characters in their name. For example, Mark Simpson occupies far less than 50 characters, but this field could hold a name up to the value of 50 characters if required. Finally, let's briefly explore some more commonly used examples of string data types. Tiny text is used to define columns that require less than 255 characters, like short paragraphs. Text is used to define columns of less than 65,000 characters, like an article. Medium text defines columns of 16.7 million characters, for example, the text of a book. And the long text data type stores up to 4 gigabytes of text data. You should now be able to explain the string data type as used in a database, and you should also be capable of differentiating between string data types, including char and varchar. Great work. To ensure the accuracy and reliability of the data in your database, you must limit the type of data that can go into your database table. In this video, you'll learn how to describe the purpose of constraints in a database and identify default constraints to set default values in a table. Database constraints are used to limit the type of data that can be stored in a table. This ensures that all data inserted into the table is accurate and reliable. If the database detects a violation between the constraint and the data operations, then it aborts these operations. An example of a violation might be an attempt to insert or upload invalid data to a table. The database realizes that the data is invalid and rejects it. Constraints can be column level, where the rule applies to a specific column. They can also be applied at table level. For example, I could use the foreign key constraint to prevent actions that would destroy links between tables. I'll demonstrate this in more detail in a later lesson. Two of the most used database constraints include not null, a method of preventing empty value fields, and default, a method of assigning default values. For now, let's begin our exploration of default values with the not null constraint. The not null SQL constraint is used to ensure that data fields are always completed and never left blank. Let's explore this concept using the example of a table from an online store that records the IDs and names of customers. The table records this data in its customer ID and customer name columns. These columns must always contain data. If there's no data or values inserted into either of these columns, then the creation of a new customer record is aborted. The not null default value is implemented using a SQL statement. A typical not null SQL statement begins with the creation of a basic table in the database. I can write a create table clause followed by customer to define the table name, followed by a pair of parentheses. Within the parentheses, I add 2 columns, customer ID and customer name. I also define each column with relevant data types, int for customer ID as it stores numeric values, and varchar for customer name as it stores string values. Finally, I also declare a not null constraint for each column. This makes sure that neither column will accept null values. Now, any operation that attempts to place a null value in these columns will fail, like inserting or updating data. Next, let's look at how the default constraint works in a table. The default constraint sets a default value for a column if no value is specified. This means that if no data is entered for a specific field within a column, then the table will automatically insert a default value instead. To gain a better understanding of default values, let's look at a table that holds player records for a football club's database. The table is called Player Table and contains two columns. The first is player name and lists the names of each player in the team, and the second column is city and lists which city each player is from. Most of the players in this club are from Barcelona, so I can specify a default value of the city column as Barcelona. This means that I don't have to enter Barcelona repeatedly into the city field for each new player. If no value is entered in the table, then each field is automatically filled with the default value of Barcelona. Let's find out how the default command is incorporated into a SQL statement. First, I use the create table commands to create a table, and then call it player. Then within a pair of parentheses, I input the column names, assign a string data type for each, and assign a default value of not null for the name column. Finally, I add the default keyword statement, followed by the default value Barcelona for the city column. Now when I add data into the table for a new player, I don't need to type in Barcelona for players who are from the city. Instead, it will be inserted automatically. You should now be familiar with the importance of using database constraints. You should also be able to explain database constraints as a method of enforcing rules on a column or table level. Good work. You've just been hired by an online bookstore to build and maintain databases that can store information on millions of books and customers. But how do you even begin to create and alter databases that store constantly expanding information or process millions of orders from all over the world? The answer to these questions lies in SQL create and read commands. In this video, you'll learn how to create a database using SQL syntax, and you'll also discover how to drop or delete a database. However, before you create a database, you first need a clear idea of its purpose. For example, if you're building a database for an online bookshop, then your database needs to record data like book titles, authors, customers, and sales. The data on these topics must be stored and organized in relevant tables in a database. Users can then access, retrieve, and update the data as needed. So how can you create a database using SQL syntax? To create a database, just type the create and database keywords. These keywords are then followed by the name of your database. But what about removing or dropping a database? To drop a database, just type the keywords drop and database. Then follow these keywords with the name of the database you want to remove. Let's look at these keywords in action. To create a database, I need to use SQL syntax. To demonstrate, let's create a second bookstore database using SQL syntax. First, I type the keywords create and database, followed by the name of my new database. In this case, the database is called bookstore2_db. I always use a meaningful and relevant name when creating a new database. This helps to make it easier to document my work. Database names must also be unique and can only have a maximum of 63 characters. If my database name doesn't meet these requirements, then an error message will appear. Finally, I add a semicolon to the end of the statement. Then I run the statement, and the new database bookstore_db2 appears on the left-hand sidebar. So, I've created a second database. I can also remove databases using SQL statements. First, I select the SQL tab. Then I input my query in the code box that appears. I type the keywords drop and database followed by the name of the database I want to delete. In this case, it's bookstore_db. Now I run the query. Then SQL deletes the database. In this video, you learned how to create and delete databases using SQL syntax. Great work. Building a database involves working with substantial amounts of data. But how do you organize your data so that you can find exactly what you need and make sense of it? With SQL, you can create a table within your database to hold and organize your data. In this video, you'll learn how to create tables in a database management system using SQL syntax. Let's begin with a look at the SQL create table statement syntax. I begin the statement with the keywords create table to let SQL know that I want to create a new table. I then add the name of the table I want to create. Finally, I add a pair of parentheses. Within these parentheses, I type the name of each column that must be included within the table, followed by its respective data type. Now that you're familiar with the syntax, let's look at it in action. Be aware that before you can create tables, you must already have a database on the server. In other words, you can't build tables if there's no database to create them in. So let's assume that I already have a database ready to work with. In this example, I'll create a customer table in the bookstore database to store customer data, like names and phone numbers. First, I write a SQL statement that contains the create table commands followed by the name of the table, in this case customers. Then I add an open parenthesis. It's within this parenthesis that I need to create my own columns. So, I write the name of my first column, which is customer name. This is followed by the data type varchar. This data type means that the column can hold data of any type. I then add a numeric value within a pair of parentheses. Then I add a comma and write the name of the second column, which is phone number. I add int as the data type so that only whole numbers can be stored. Then I add a closing parenthesis and a semicolon. Finally, I execute the statement. The customers table is now stored in the database. In this video, you learned how to create tables in a database using SQL syntax. Well done. At this stage, you're probably familiar with creating tables in databases, but no table is ever static. Database developers are always restructuring tables. Sometimes they need to add new columns, delete old ones, or edit the data they contain. You can complete many of these basic restructuring actions using SQL syntax. In this video, you'll learn how to alter a database table by adding and removing columns, and modify the attributes of a database table. Let's start by exploring the SQL alter statement syntax. The first part of an alter statement is the alter and table keywords. These keywords inform the database that there is a table whose contents must be altered. This is followed by the name of the table to be altered. I then include the add keyword. This keyword tells SQL that there's one or more items to be added to the table. There are other keywords I could include here instead, but for the purposes of this example, I'll work with add. Finally, I insert a pair of parentheses. Within these parentheses, I declare the name of a new column to be added to the table, along with this data type. Now that you're familiar with the alter table statement, let's explore an example of this statement in action. However, before you can begin altering tables, you must already have a database on the server. So, as always, make sure that you know how to create databases before proceeding, and ensure that you already have a table in your database with data that you can alter. In my example, I have a students table located within the database called college. My students table holds information on the IDs, names, and emails of each student in a college. I can demonstrate the alter statement by adding, deleting, and modifying columns in this table. My first task is to add 3 new columns to the table: age, nationality, and country. To add these columns using SQL syntax, I first type the alter table command, followed by the name of the table, students. Next, I use the add command to let the database know that I want to add new columns to the table. Then I input a pair of parentheses that contain the columns I want to add, along with the type of data they'll hold. These columns are an age column, which holds data in integer format, a country column with varchar as the data type, and nationality and country columns that hold varchar or string data. I also add a character limit of 50 to the country columns fields and a limit of 255 to the nationality columns fields. Then I execute this statement. I now have 2 new columns in students table in the college database. Country and nationality are very similar columns, and in most cases will probably hold the same type of information. So I can write a SQL statement to remove the nationality column. Just like the last example, I start my statement with alter table students table. Next, I type the drop column command followed by nationality. This command instructs SQL to delete or drop this column from the table. Then I run the statement. A notification message appears requesting confirmation of deletion. I press OK to confirm. The nationality column has now been dropped. Now it's time to alter the structure of the table. The country column has a limit of 50 characters, just as I said it originally. But now I'm going to change it so that it holds 100 characters instead, using the alter table command. I start with the syntax alter table, followed by students table. Then I type the modify command, the country column name, and the varchar data type. And finally, I add a pair of parentheses containing my new value of 100. I then execute the query. My country columns limit has now been updated to 100 characters. In this video, you learned how to alter and modify tables in a database using SQL syntax. Well done. When working with databases, you'll often have to add new rows and columns to existing tables or even create new tables from scratch. For example, if you run a college database, you'll have to add new rows for every new student. With SQL, you can perform these tasks quickly using the insert statement. By the end of this video, you'll be able to identify and understand insert SQL syntax and insert data into tables with the use of the insert into clause. Let's begin with an exploration of the insert into syntax. To write an insert statement, first write an insert into clause. Then specify the table name followed by a list of columns contained within a pair of parentheses and separated by commas. Then use the values keyword and write a list of values within a pair of parentheses. It's important to remember that each value corresponds to a specific column and so should reflect the same data type and order. You can also add multiple rows into a table at the same time. First, write the insert into clause in table, just like before. Then use the values keyword and add multiple rows of values. Just make sure that each new row is separated from a previous one by a comma. Now let's explore some examples of an insert statement. In this example, I'll use a table called players from a sports club database, and I want to insert new player data into this table. First, I write the insert into command, followed by the name of the table. In this case, it's players. Then I add the column names within a pair of parentheses. These columns must contain the basic information that the club requires about each player. So I'll name the columns ID, name, age, and start date. Next, I insert the values keyword and then add the values I want to assign to each column within a pair of parentheses. I start adding the data for a new player named Yuval, age 25, with an ID of 1 and a start date of 2020-10-15. It's important to use the correct format of year, month, and day when entering dates in a table. Otherwise, an error message will appear. I can also use the current date function followed by a pair of empty parentheses next to my values, just like I've done for the new player Yuval. Now that I've scripted all values for Yuval, note that each value relates to a specific column. Number 1 corresponds to the player ID column, Yuval to player name, 25 to player age, and the date to start date. This means that the order in which I type my values within the parentheses is very important. Otherwise, I might accidentally store these values in the wrong columns. It's also important to note that all non-numeric values are placed within quotation marks, just like Yuval and the date value in this statement. Finally, I execute the statement. The output now shows one row of data for Yuval, just as my code instructed. But what if I wanted to insert multiple records of data into the table? Let's say that 2 new players have joined the team. The first player is Mark, age 27, with an ID of 2 and a start date of 2020-10-12. And the second player is Carl, age 26, with an ID of 3 and a start date of 2020-10-7. Both Mark and Carl must be inserted into the database. As you learned earlier, this is a very straightforward task. First, I write the insert into command. Then I write the table name, players. Next, I type the ID, name, age, and start date columns within a pair of parentheses. Then I write the values keyword and insert 2 records of data. These data records are contained within 2 pairs of parentheses separated by a comma, one for Mark and another for Carl. Finally, I run or execute the statement. I then check my output, which shows that all 3 players are now in the table. So far, I've explored how to add data to the table, but it's also possible to show existing data in the player table by executing the following SQL query. First, I type the select clause, followed by an asterisk. This asterisk tells SQL to return all columns within the table. Then I type the from keyword and the name of the table. I execute the statement, and the output shows all data available from the player table. You can now identify and make sense of the insert syntax, as well as insert new data into tables with the insert into clause. Good work. There will often be times that you'll need to query data from a table in your database. For example, you might need to retrieve a list of names from a table, or return a set of results from a math calculation. You can perform these actions using the select statement, and that's what I'll demonstrate now. So over the next few minutes, you'll learn how to utilize the SQL select statement to query data from a table in a database, and perform other SQL select tasks, such as math calculations, date and time queries, and concatenation functions. To get started, let's explore the syntax of a SQL statement. A basic SQL select statement is written as the select keyword, the name of the column that contains the data you need to query, then the from keyword, and finally the name of the table you want to query. For example, if I want to query data about the names of players from a soccer club database, I could use the following syntax: the select keyword, the player name column, and the from keyword, and finally the name of the table, which is player table. And although it's not mandatory, a semicolon is often added to mark the end of a SQL statement. Let's take a closer look at how this statement works. As an example, I'll extract information from a table called players held in a soccer club database. This table records details about players in a soccer club like ID, name, age, and skill level. I can use the SQL select statement on this table to obtain information on the club's players. The expected outcome of this select query is that it will return a result set that displays all player names held in the table. I can write the statement as select name from players. The select command is used to retrieve data. Name is the column that stores the player's name in the database. From is a keyword that identifies the source table, and players is the table name. I then run the statement. The query returns a table column that lists the players' names from the players' table, with each name on its own row. So in the example you just explored, I retrieved data from one column in a table. But what if I wanted to retrieve data from multiple columns? Maybe I need to retrieve the name and skill level of each player. I can obtain this information using a SQL select statement written as select name level from players. I add a comma between name and level so that SQL understands they are two separate columns. I run the query and it returns the data from the name and level columns in the players table. I could also use the select statement to retrieve all data from all columns in the players table. There are two methods I could use to achieve this. The first method is to list all column names in a standard select statement as follows: select ID, name, age, level, from players. Once again, each column is separated by a comma. I then run the query and get all the requested information in table format. The second method is to use an asterisk as shorthand. So instead of typing out all column names, I just type select, asterisk, from players. Then I run the query. It returns all the information available in all table columns, just like in the first method. You're now familiar with how to use the select statement in MySQL. So, next time you need to query data in your database, you've now got different methods to choose from. When working with tables, there might be instances where you need to retrieve information from one or more tables in order to populate columns in another table. You can complete these actions using the insert into select statement. Over the next few minutes, you'll explore the SQL syntax for these actions, and by the end of this video, you'll know how to identify and understand insert into syntax and insert data from a source table into a target table using the insert into clause. First, let's find out more about the insert into select statement. Essentially, the insert into select statement is used to query data from a column within a source table and place the results of that query in the column within a target table. For example, you could use an insert into select statement to query data in column C in the source table and place the results of that query in column B of the target table. So what does the insert into select statement syntax look like? Here's an example. First type an insert into clause, followed by the name of the target table and the name of the column you want to insert data into. Then type the select keyword with the name of the column you want to extract data from, and finally, type a from keyword and the name of the source table that holds that column or source data. To find out more about how this syntax works, let's explore an example of insert into select. To demonstrate the statement, I'll use tables from a soccer club database that contain important data about the club. However, before I begin querying this data, let's quickly review these tables. In this database, I have a table called Players that holds the records of 4 different players in the team. I also have a table called Country that holds information about the countries that these players are from. But right now, the country table is missing the names of the countries. In other words, it has no data. I can perform a SQL query using the insert into select statement to populate this missing data. Do you remember the example of the source and target tables from earlier in this video? In this instance, the player table is a source table that I need to query, and the country table is a target table in which SQL places the results from my query. So, to query data from my source table and populate my target table with it, I write an insert into select statement. Note that for the purposes of this demonstration, I've organized the player data in the player table in the same order in which it must appear within the country table. So to perform this task, I first click on the SQL tab to open the code editor. Then I write an insert into command, followed by the name of my target table, which is country table. I then state the name of the column that the data from my query must be inserted into within a pair of parentheses. In this instance, the column is called country name. Next, I type the select keyword and state what column I want to query within the source table, which is country. Finally, I type the from keyword and state the name of the source table I want to query the data from, which is player table. I add a semicolon to the end of my query, then run it. Now I select country table, my target table from the database, and check that the country name column has been populated with the correct data. You now know how to query tables using the insert select statement. Well done.
I recently created a database table for a college called Student Table. It contains the following pieces of data on each student in the college: ID, first name, last name, home address, college address, contact number, and department. Let's use the update syntax to update the home address and contact number of the student assigned the ID of 3 in the table. So I click the SQL tab in PHP-MyAdmin. Now I use the update clause followed by the name of the table that I want to update, which is student table. Then I add the set clause followed by the names of the columns to be updated, which are home address and contact number. Next to the name of each column, I add an equal to symbol and place the new values to be inserted into the table in single quotation marks. I also make sure to separate these column value pairings with a comma. Finally, I add the where clause to identify the exact record I want to update. This record has a student ID column field that was assigned the value of 3. So I write where ID equals 3. Now that I've completed the syntax, I can select Go. I then receive a message confirming that the change has been made, and when I check the table, it displays the updated values for the assigned columns alongside student 3. So that's how you update the information for one student. However, the update syntax can also be used to update the information for multiple students at once. Let's suppose that the college's engineering department has moved their classes to a new location on campus called the Harper Building, and I need to update the department's address on the table for all engineering students. I can perform this task using the update SQL syntax. The syntax is very similar to the previous example. First, I use the update clause followed by the name of the table. Then I add the set clause and state that I want to update the values within the college address column to Harper Building. So I type this as set college address equals Harper Building. Next, I type the where clause and state that I want this update to occur within the college address column for all students assigned the value of engineering in the department column. I then click Go to run the statement. Now, I just checked that the table has updated the college address of the engineering department to Harper Building. I could also use the update statement to update multiple field values in multiple records. For example, I can return to the original SQL statement and add a new column value pairing to the set clause. If I want to update the home address column, I add a comma and write home address equals the new address information within quotes. Make sure to separate out the column value pairings with a comma. In this example, I'm updating 2 columns with 1 update statement. In this example, I'll demonstrate how to delete a single record from a table in a database. I'm using the student table from a college database and deleting the record of a student with the last name of Miller. I go to the SQL tab in PHPMyAdmin, and I write a delete statement beginning with the keywords delete from. Then I specify the table name as student table. I add a where clause and the condition to delete the data I want. I need the database to scan the list of students and identify the last name or value of Miller, and then delete that record from the table. So I type where, followed by last name, equal to Miller. I then run this statement by pressing the Go button. I get a confirmation that the record Miller has been deleted from the database. I can then access the student table on the left panel to ensure that the record or instance of Miller has been removed. Let's explore another example, this time by deleting multiple records from the student table. Now I want to delete the records for the 2 students within the engineering department. The beginning of the statement is the same as the previous example. I begin with the delete and from keywords, followed by the name of the table I'm working with, which is student table. The where clause is the key difference in this example. I type where, followed by department equal to engineering. This instructs SQL to identify all records that have a value of engineering within the department column and remove those rows from the table. But I need to be careful. If I don't correctly specify the where clause, then all the records in the table will be deleted. So now that I've completed my statement, I select Go to run it. I then check the table by clicking it on the left panel and confirm that the records for the 2 engineering students have been deleted from the table. Finally, let's quickly explore how to delete all records from a table. In this task, the syntax remains largely the same as in the previous examples. The key difference is that I remove the where clause so that now my syntax just states delete from student table. I remove the where clause so that now my syntax just states delete from student table. In other words, I'm instructing the database to remove all records from the student table. Then I click Go and confirm the deletion. Once the deletion has been confirmed, I check the student table, which is now empty. I now know that all records have been deleted.
You've reached the end of this module in CRUD operations. In this module, you've discovered how to create, read, update, and delete data within a database. You've also examined different SQL data types like numeric, string, and default values. It's now time to recap the key topics you learned and skills that you gained. You began the module with an introduction to SQL data types. Following the completion of this first lesson, you can now identify and understand the numeric data type so that you can store data as numbers in a database, utilize numerical data types in a database, and differentiate between integer and decimal data types so that you can store numerical values of different sizes, including positive and negative ones. Following your exploration of numerical data types, you then moved on to investigate string data types. During your investigation, you learned how to identify and understand string data types in a database, demonstrate how to use string data types, and outline the key differences between char and varchar data types. The final concept that you learned about in this lesson was default values. Now that you've completed the lesson on default values, you're able to demonstrate an understanding of the concept of constraints in a database with SQL syntax and identify the default constraint to set default values in a table. As part of this lesson, you also undertook a series of exercises focused on SQL data types. Having successfully completed these exercises, you can now demonstrate your ability to work with numeric data types, string data types, and default values, and outline how to select the correct data type for your data. Once you completed your study of SQL data types, you then moved on to explore the topic of creating and reading data in a database. Now that you've completed this lesson, you're able to create a database and create tables, alter database tables, and drop a database. You can also demonstrate how to create a table in a database with SQL syntax, alter table structure using the SQL alter table statement, and insert or add data into a table with SQL insert statement. In addition to these new skills, you also learned how to retrieve data from tables with the SQL select statement and insert queried data from one or more tables into another target table using the insert into select statement. You also had an opportunity to demonstrate these new skills through a series of exercises. In these exercises, you proved your ability to create a database and a table, and then populate the table with data, and manage data within your tables using the select and insert into select statements. You then moved on to the final lesson, in which you explored how to update and delete data. Having completed this lesson, you can now demonstrate knowledge of the SQL update statement, and utilize the update statement to update both single and multiple field values of a record. Finally, you also proved your abilities with these new skills by completing an exercise in which you deleted records from a table. You're now familiar with the create, read, update, and delete operations. You're also skilled in the use of SQL data types. Great work. You're making good progress on your journey towards becoming a database engineer. Imagine a corporate database with information about hundreds of employees. How can you calculate important things such as salary increases or calculate changes to allowances for all the employees accurately and efficiently? With SQL, you can use arithmetic operators to make these adjustments. By the end of this video, you'll understand and be able to describe SQL arithmetic operators and know how to use these arithmetic operators to perform functions in SQL. But first, what exactly are operators in SQL? Operators are specific words or characters that help you to perform different activities in a database. They're like conjunctions or connection words you would use to compose a sentence, or the operation keys used to perform a sum in a calculator. So, why do you need to know about operators? Well, when handling data in a database, at some point you'll need to query and manipulate data for different purposes. SQL operators allow you to manipulate data as necessary to perform these different activities in the database. For example, you can use an arithmetic operation to calculate how many leave days an employee has left, or you can compare whether employees are meeting company targets. There are various types of operators in SQL, each with different functions. Let's explore a few examples of arithmetic operators. Arithmetic operators are commonly used in computer languages to perform a calculation and return a result. Much like common arithmetic operators in mathematics, you can use arithmetic operators in SQL to carry out mathematical operations in a database. The SQL arithmetic operators and their symbols are plus for addition, minus for subtraction, an asterisk for multiplication, / for division, and percentage for modulus, which provides the remainder value of a division calculation. So how do SQL arithmetic operations work? When performing a calculation, an operator takes two operands and returns a result. For example, an addition operator can take 5 as both of its operands and return 10 as its result. In SQL, you can apply the same concept by using the select command for the various operations. Let's illustrate this concept using the addition operator. You can use the select command, followed by one operand, the addition operator, and a second operand, and just like the previous example, SQL calculates the two operands and produces the result. You can repeat the SQL syntax with the other arithmetic operators. With a subtraction operator, the output result is 0. A multiplication operator returns a result of 25. The division operator calculates the result as 1. And with a modulus operator, the result is 0, as 5 divided by 5 equals 1 with no remainder. Now, let's take a closer look at how to use these arithmetic operators in SQL. I'll demonstrate how to use arithmetic operators in SQL to perform basic mathematical operations. Let's try an addition operation to add two numbers. First, I use the select command and then type the numbers 10 and 15 separated by a plus operator, followed by a semicolon. Although the semicolon is optional in this case, I prefer to still use it as it represents the end of a SQL statement. The select command retrieves the value, which is the sum of 10 plus 15, and displays it on screen. Let's run this query. The query produces the result of the example addition operation, which is 25. Just as I performed this addition operation, I can do the same with subtraction, multiplication, division, and modulus operators. I can use the minus sign for subtraction, an asterisk star for multiplication, / for division, and a percentage sign for modulus. For example, I can type select 100 modulus 10. This divides 100 by 10 and gives me the remainder of the division operation. In this case, the remainder is 0, as 100 divided by 10 equals 10 with no remainder. So, I run the query and the remainder of 0 is displayed. And that's how you can use the operator symbols for different basic operations in SQL. You've learned about SQL arithmetic operators and how to perform basic operations with them in SQL. You're now ready to learn how to apply these arithmetic operators in more practical ways. Awesome work.
So far, you have learned how to use SQL arithmetic operators to perform basic functions. In this video, you'll take one step further by learning how to use these arithmetic operators in practice when working with a database. Let's explore the use of arithmetic operators using the example of a corporate table of employee data. It's populated with the following information about each employee: ID, name, and salary. I'm going to demonstrate how to use each of the arithmetic operators in SQL to perform various functions with this practical data and retrieve the desired results. In this first example, let's say that an employer wants to give each employee on their team a $500 bonus. But first, they'd like to see what each employee's salary looks like after adding the $500. I can type select salary plus 500 from employee to add the $500 bonus to each employee's salary. This select command works by retrieving the salary of each employee from the employee table and then adding $500 to each value. Let's execute the query by clicking the Go button. The result is that each employee's salary has increased by 500. You can create other statements that use the select command in a similar way. For example, let's say the employer wants to deduct $500 from the salary of each employee. To do this, I type the SQL query statement, select salary minus 500 from employee. Again, I'm using the select command to retrieve the salary value of each employee record stored in the employee table. This time, I use the subtraction sign, minus, to subtract $500 from the salary of each employee. Now I click the Go button, and the database returns a table that shows the output result of salaries after the deductions. In the next example, let's imagine a scenario where the employer would like to increase the employees' salaries by doubling their current annual salary. To do this, I use the select command to perform the same function as discussed previously. I then use the multiplication sign, an asterisk symbol, to multiply the salary value of each employee by 2. So the SQL statement now reads, select salary asterisk 2 from employee. I can now click the Go button to generate an output of the results of salaries from multiplying the values by 2. Now let's suppose the employer needs to determine the monthly salary of each employee. I can perform this task using an SQL query statement as I have done in the previous scenarios. However, this time I'll divide the annual salary by 12 months. To determine the monthly salary, my statement reads as follows. Select salary / 12 from employee. The select command retrieves the salary value for each employee stored in the employee table. Then division sign, or the /, divides the annual salary value by 12. So I click the Go button to generate the output result. The employer can now use this output result to determine what each employee's monthly salary is. In our final example, the employer would like to know if the ID of each employee is an even or odd number. I can use the modulus operator to complete this task. I just need to type the following statement. Select ID modulus 2 from employee. I then click Go to execute the statement. This divides each employee ID by 2 and returns the remainder of the division operation. In this case, a remainder of 0 denotes an even ID, as all even numbers are divisible by 2, meaning there will be no remainder. The result shows that there are 3 odd IDs and 2 even IDs. You should now know how to make use of the SQL arithmetic operators in a database. You're making great progress. Keep it up.
Imagine you're running a database for a soccer club. As a database engineer, there's a lot of work required to manage this database. For example, you might need to categorize players into groups according to their ages. How can you complete this kind of task? You can use SQL comparison operators. Over the next few minutes, you'll learn how to explain the concept of SQL comparison operators and utilize SQL comparison operators in a database. So, what are SQL comparison operators? Comparison operators are used to compare two values or expressions where the outcome result can be either true or false. They can be used to filter data and to include and exclude data. So how are these operators used in SQL? SQL uses common mathematical comparison operators by means of the symbols equal to, less than, and greater than. It also uses less than or equal to, greater than or equal to, and not equal to. Now let's explore how to use these comparison operators and relevant symbols in a practical way using a database. To demonstrate the use of SQL comparison operators, I'll use the example of an employee table from a company database. This table includes information on each employee's ID, name, and salary. Now, let's assume the employer wants to extract relevant data from the employee table about the employee's salaries for different purposes. Each instance of data extraction will require a different comparison operator. So in the first example, the employer wants to identify all employees receiving a salary equal to $18,000 per year. I can identify these employees using the equal to operator. First, I click the SQL tab in the main menu. Then I write select, asterisk, from, employee, where, salary equal to symbol, 18,000. Let's break this SQL statement down. The select command is used to retrieve data. The asterisk star denotes that I am selecting data from all columns. The from keyword and the table name specify where the data will come from, and then I define the condition using the where clause. In this case, the condition uses the equal to symbol to check if the salary value in each record of the table is equal to $18,000. If the result is true, then the data is retrieved. So, I run the query and generate an output. The output result of this query is that the employees Carl and John earn $18,000 per year. You can apply the other comparison operators in a similar way to perform different functions. Let's take another example to find out more. In this next example, the employer needs to know which employees are receiving a salary that is less than $24,000 per year. This task requires a different operator. To find this information, I can write select, asterisk, from, employee, where, salary, less than symbol, 24,000. This SQL statement utilizes the less than symbol to check whether the value stored in each field of the salary column is less than $24,000. Once again, I select the Go button to execute the query and generate an output. The output of this query is that the employees Carl and John earn less than $24,000. Let's take another example where the employer needs to determine which employees receive a salary that is less than or equal to $24,000 per year. In this case, I need to write the following query: select from employee where salary less than or equal to symbol 24,000. The only thing in this statement that has changed from the previous example is the operator symbol. This less than or equal to symbol tells the SQL statement to check whether the value stored in each field of the salary column is less than or equal to $24,000. I click the Go button to execute the query. The output results show that there are 4 employees who earn less than or equal to $24,000 per year. What if the employer wants to know which employees receive a salary that is greater than or equal to $24,000 per year? To generate these results, I can use the greater than or equal to operator in my SQL statement. So I write the following SQL query: select from employee where salary greater than or equal to symbol 24,000. This time, the greater than or equal to symbol is used to check whether the value stored in each field of the salary column is greater than or equal to $24,000. I click Go to execute the query, and the output shows that there are 3 employees who earned $24,000 or more per year. The final comparison operator available in SQL is the not equal to operator. In this final example, the employer wants to know which employees receive a salary that is not equal to $24,000 per year. I can determine this using the following SQL code: select from employee where salary. Then I type less than and the greater than symbols to denote the not equal to operation, and then I type 24,000. As with the previous operators, the SQL statement utilizes the operator to check the values stored in each field of the salary column. In this case, it checks for values that do not equate to $24,000. The output results of this query show that there are 3 employees whose salaries are not equal to $24,000 per year. You should now be able to describe comparison operators and use them in a database in SQL. Congratulations on building another important database skill. There are several clauses available in SQL for sorting and filtering data in a table. One of the most useful of these is the order by clause. With this clause, you can reorder the data in a table by 1 or more columns. For example, in a table that holds data on students in a college, you could sort the data by date of birth. The table would then present all students in the order of oldest to youngest. By the end of this video, you'll be able to demonstrate the purpose of the order by clause for sorting data, explain the different forms in which the order by clause can be used to sort data, and describe how the ascending and descending keywords behave when used on sort columns. Let's begin with an exploration of the purpose of the order clause. The order by clause is an optional clause that can be added to a select statement. Its purpose is to help sort data in either ascending or descending order. For example, you can sort a list of student names in an alphabetical order from A to Z or vice versa. To get a better understanding of how the order by clause works, let's explore the syntax. In its most basic form, the syntax of the order by clause is as follows. It begins with a select statement, then a list of the columns to be sorted with each one separated by a comma. Next is a from keyword, followed by the name of the table to be sorted. Finally, the order by clause is added, followed by the name of the column to be sorted. At the end of the column name, state how you want the data to be sorted. You can do this by specifying ASC for ascending order or DESC for descending. But the order by clause doesn't limit you to just the one column. You can also use this syntax to order the data from multiple columns. The syntax for sorting multiple columns is very similar to that used for a single column. The key difference for multiple columns is that you must type the name of each column after the order by clause. Just make sure that you separate each column with a comma, and specify whether you want to sort the columns in ascending or descending order. It's also possible to specify all columns after the select keyword by using an asterisk. This is a much easier method than listing all columns one by one. Finally, it's also important to note that the type of data in your table affects how it is sorted. If the column has a numeric data type, the records will be sorted in the ascending or descending numerical order. And if a column has a text-based or string data type, then it will be sorted in ascending or descending alphabetical order. Next, let's explore some examples of the order by clause in a SQL statement. Let's begin with an example of ordering data by a single column. For this example, I'll use a table that lists details of students in a college. I need to sort or order this data in ascending order of each student's country of nationality. So in this instance, the order by column must be the nationality of each student. Each student's nationality is listed in the table's fifth column. I begin by writing the select statement, followed by the names of the columns that I want in the result: ID, first name, last name, and nationality. Then I write the from keyword, followed by the name of the table, which is student table. Next, I type the order by clause. Then I specify the name of the column by which I want my data to be sorted, which is nationality. Finally, I type ASC so that the data is sorted in ascending order. I then execute the statement. All students in a table have now been sorted according to nationality in ascending order. Note that even if I was to omit ASC from the end of my code, I'd still get the same result. This is because the order by clause sorts all data in ascending order by default. Let's run the same statement, but this time using DESC or descending instead of ASC. All students in a table have now been sorted by nationality for a second time, but in this instance, they've been sorted by descending or reverse alphabetical order. Finally, let's explore an example of sorting data by multiple columns. In this example, I'll sort each student by nationality and date of birth. First, I write the select statement. Then I write the names of the columns I want in my result: ID, first name, last name, date of birth, and nationality. I then write the from keyword and student table, the name of the table. Next, I type the order by clause and specify the names of the columns by which I want my data to be sorted, which are nationality and date of birth. I then add ASC after nationality, so that the data is sorted in ascending order of nationality. And I add DESC after date of birth, so that the data from this column will be sorted in descending order. Then I run the statement. This returns my table with the data for the specified columns organized as instructed, which is alphabetically for nationality and youngest to oldest. This was a short introduction to the SQL order by clause. You can now demonstrate the purpose of the order by clause for sorting data, and you can also explain the different forms in which the order by clause can be used to sort data. Great work. An admin department at a university wants to create different reports for students in the engineering faculty. The department needs to filter out students from the engineering faculty to retrieve their details from the student database. So how can this be done with SQL? Well, the where clause is useful in scenarios like this. In this video, you'll learn how to explain the purpose of the where clause, demonstrate how to filter data using the where clause, and make use of different operators in the where clause condition. So what is the where clause? The where clause is used to filter data. More specifically, it is used to filter and extract records that satisfy a specified condition. To better understand how the where clause is used, it may help to break down its syntax in a SQL select statement. The syntax begins with a standard SQL select statement, followed by the columns you want to query. Next is the from clause, followed by the table name. Then you can bring in the where clause. After the where clause, you can specify a condition. You may be wondering what the purpose of the condition is. Well, the condition makes it possible to filter out and fetch the required records from the table. You can think of the conditions as filter criteria. Only the records that meet the condition will be retrieved. For example, you can use the condition or filter criteria to check if the desired column name is equal to a certain value or operand. In between the column and value, you can place an operator. As you've just discovered, the operand follows the operator. Let's take a quick look at it in more detail. The operand can be either a text value or a numeric value. It all depends on the data type of the table column or field. To demonstrate, let's take an example where student ID equals 01. In this case, the condition is instructed to filter a numeric value, so it functions as a filter criteria. Once you run the SQL select statement, it retrieves the records as instructed. Let's take another example, where first name equals John, a text value. All text values must be enclosed in a pair of single quotes. Once again, you just run the SQL select statement and it filters the required records. To specify your filter condition, you can make use of a wide range of operators. You've just reviewed an example of the equals operator and others you may have encountered in a previous lesson. Let's quickly review these other operators. SQL comparison operators include equal to, less than, and greater than. There's also less than or equal to, greater than or equal to, and not equal to. In addition to these symbols, the where clause can also use the between, like, and in operators. With the between operator, you can filter records within a specific numeric or time and date range. The like operator is used to specify a pattern in the where clause filter criteria. And the in operator is used to specify multiple possible values for a column. Now, let's explore some examples of the where clause in select statements. Recall the scenario of the admin department that wants to create reports for its engineering and science students. I can use the where clause to filter out the details of students who are in the engineering faculty. In this case, I need to retrieve all details, or all columns, from the student table. So I write select, asterisk, from, student table. Next I type where, followed by the filter criteria. The criteria is written as faculty, then an equal operator. Finally, I write engineering enclosed in single quotes, which are required for text values or operands. So I'm instructing MySQL to fetch only the details of the students who are attached to the engineering faculty. Then I run the query. As per the filter condition, it has retrieved the student records of the 3 students in the student table listed in the engineering faculty. Note that I could have used other operators such as greater than or equal to, greater than or equal to, and not equal, in the same way as the equal to operator in this where clause condition. You can use any of these operators with numeric values or operands. Now let's review some examples that use between, like, and in operators in the where clause condition. The college has a financial aid program available to students of a certain age. The funding department would like to notify eligible students only. I can use the between operator in the where clause condition to filter the records in the student table. As before, I type select, asterisk, from, student table, followed by where. After the where keyword, I specify the filter column as DOB or date of birth. Then I insert the between operator. Lastly, I give the date range as 1st of January 2010 and 30th of June 2010. Running this query retrieves the records of 4 students whose date of birth falls in the specified date range. Note that I could use any numeric range here, not just dates. For the next example, let's assume the admin department requires the details of the students who are in the science faculty. I can do this with the like operator, which can be used when you want to specify a pattern in the where clause filter criteria. Within the select statement, and after the where keyword, I type faculty for faculty column, then the like operator, followed by SC %sign within single quotes. The percentage character in the pattern is a wildcard character that represents 0, 1, or multiple characters. The underscore sign can also be used to represent one single character. In this case, my where clause asks MySQL to search for and filter out values within the faculty column that start with SC, followed by any number of characters. So I run the statement and it filters out the 5 student records whose faculty column has a value of science. That is, starting with the pattern SC. In the final example, the admin department needs to know the details of the students who are studying in specific locations. You can use the in operator in the where condition to retrieve the relevant student records. Remember, the in operator is used to specify multiple possible values for a column. Within the select statement and following the where keyword, I type the column name, which is country, the in operator, then an open pair of parentheses. Within these, I place the values USA and UK each in single quotes. My select query will filter out all student records that have a value of USA or UK in the country column. Running this query returns 4 records, 2 students from the USA and 2 students from the UK. So the in operator searches for multiple possible values in the country column and filters out based on them. Note that although the examples in this video looked at the where clause in the select statement, it can also be used in other statements, such as update and delete. You've now learned what the where clause is, and you should now know how to use it to filter data as well as how to use different operators. Great work. Suppose you have a database that contains the records of college students from all over the world. As part of an annual report, a list of all the different countries these students belong to is required. It's very likely many students will come from the same country, so how can you retrieve the results you're looking for without any duplicates? Look no further than a select distinct clause. In the next few minutes, you'll learn how to describe the select distinct statement and explain what it's used for, demonstrate how to use it in a SQL query, and explain how it interacts with a single column, multiple columns, and null values in a few practical examples. Let's start by exploring what the select distinct statement is. In its most basic form, distinct, as its name states, returns only distinct or different values. In other words, it returns the results without any duplicates. Let's take a closer look at duplicate values. As you can imagine, columns in a table can often contain duplicate values. In a college's student records, for example, the country column will likely contain duplicate values as there can be many students who are from the same country. Let's assume you want to find out which countries the students in the college are from, so that you can get an understanding of which nationalities are represented in the college. You can begin by using a SQL select statement. You can write the select keyword, then country, followed by the from keyword and the student table name. Running this select query gives you 7 records as the result, with multiple duplicate records. In this case, there are duplicate records for Australia and the USA. So how can you eliminate these duplicates and retrieve a unique set of results? You can use the select distinct statement. You can write a select statement just like before, but this time add distinct after the word select. The word distinct will return all unique values in the table with no duplicates. You can then write the from keyword followed by the student table name. Once you run this statement, the countries now only appear once in the resulting records. All the duplicates have been removed. This is how the select distinct statement can be used to return distinct values from one column. In this case, you've returned distinct values from the country column. Now, let's take a few moments to explore the select distinct statement in action. The examples that follow focus on the select distinct statement with the use of multiple columns or when applied to a column that has a null value. With the student table in this example, I want to write a query to determine which countries are represented by students in different faculties. I can use a select distinct statement as before, but this time I'll add the word faculty before country. Running this statement produces 6 records. The science faculty has students from 3 different countries, as does the engineering faculty. So, with this statement which uses multiple columns, I've generated each unique faculty and country combination. Now, let's return to the table once more and examine how select distinct deals with null values in columns. In this example, I have a new student named Julia Smith from the USA. She's not yet been assigned a faculty or school address. As a result, both fields within these columns assigned to Julia Smith contain a value of null. So let's see what happens when I run the same select distinct statement as the previous example. How does it handle the null values? In other words, what results does it return for Julia? I select Go and receive the same result as the last time. But now there's also a record for Julia with a null faculty value and USA as the country. This is because the distinct clause considers null to be a unique value. So it outputs null and USA as a unique faculty and country combination. In this video, you learned how to use the select distinct statement to eliminate duplicate values in a select query result. You also observed how it behaves in response to values in a single column and multiple columns, and to null values in columns. Great work. You're at the end of SQL operators in sorting and filtering data. Well done. Having a lot of data stored in a database is great. Making sense of all that data is even better. That's why using SQL to manipulate the data becomes a much sought after skill. you might remember that SQL operators can accomplish tasks such as arithmetic and comparisons. Data can be filtered using the where clause and sorted using the order by clause. Just to finish up, let's recap the key points of this module. Here at the end of this module, you should now be able to demonstrate the SQL arithmetic operators in tables, demonstrate the SQL comparison operators in a database, describe the purpose of an order by clause, and demonstrate ascending and descending sorts by single and multiple columns. In the videos on filtering, the where clause was used with the SQL select statement to filter records. For the where clause, you should now be able to explain the purpose of the where clause, describe how it is used to filter data, and demonstrate using the SQL where clause with comparison operators. Finally, you also explored the select distinct clause. Following this, you should now be able to explain the purpose of select distinct, describe how it is used to eliminate duplicate values, and demonstrate using select distinct with a single column, multiple columns, and null values. After this module, you should now be able to do some SQL operations on the data within your database. That's one of the first steps to giving real value to that data. With your SQL skills, the database is now no longer just a store. It's also something you can investigate and draw conclusions from. Before developing a database or a software application, you first need to plan how you'll organize your data. This plan is referred to as a schema. It's essentially a blueprint of what your data looks like. In this video, you'll learn how to explain the concept of a database schema, identify the different meanings of the term schema across different database systems, and outline the advantages of a database schema. Let's begin focusing on what developers mean when they use the term schema. The general meaning of a schema is that it's an organization or grouping of information and the relationships among them. In the context of a MySQL database, a schema means a collection of data structures or an abstract design of how data is stored in a database. Essentially, schema and database are interchangeable terms within MySQL. A schema is how data is organized in a database and how it's related to other data. But schema is defined in different ways across different database systems. In a SQL Server, a database schema is a collection of different components like tables, fields, data types, and keys. In PostgreSQL, a database schema is a namespace with named database objects like views, indexes, and functions. An Oracle's schema system assigns a single schema to each user. Oracle even names each schema after its respective user. But no matter which type of database you encounter, the two most important concepts you need to understand when working with schemas remain the same: organization of data in the form of tables, and the relationships between the tables. Let's now cover the components of a database. A SQL Server schema is comprised of what are known as schema objects. Many of these objects will probably already be familiar to you from your study of databases. They include tables, columns, relationships, data types, and keys. An example of a SQL database schema is a music database with data on artists, albums, and genres all stored in separate tables. However, these tables can still be related to one another through various keys. In other words, the data within this database is organized in separate tables or entities. Yet the tables are also related to one another. Essentially, a database schema is comprised of all of the important data and their relationships, the unique keys for all entries in databases, and a name and data type for each column in a table. So, now that you're familiar with what a database is, let's move on and explore the advantages of a database schema. Schemas provide logical groupings for database objects. They also make it easier to access and manipulate these database objects than other available methods. Schemas also provide greater database security. You can grant permission to separate and protect database objects based on user access rights. And finally, it's possible to transfer ownership of schemas and their objects between users and other schemas. In this video, you've learned that a database schema is a structure that represents the storage of data in a database. You also now understand how the meaning of schema changes across different database systems. Lastly, you explored the advantages of a database schema.
By the end of this video, you'll know how to create a simple database schema using SQL. You'll do this by building the schema for a shopping cart database consisting of 3 tables. Let's start by creating a new database called Shopping Cart DB. First, I type the create database keyword followed by the name shopping cart DB. Then I run the statement. The shopping cart DB database appears in the left-hand explorer. Now I can create the tables inside this database. First, I need to create the customer table, which stores the following information on each customer: customer ID, name, address, email, and phone number. To create this table, I use the create table keyword, and then I type customer followed by parentheses. In the parentheses, I specify the fields and their data types as follows. The customer ID data type is integer, while the others are varchar. I give the name and email fields a character limit of 100. I assign a character limit of 255 for address, and I assign a limit of 10 characters for phone. Also note that I've used the primary key keyword on the customer ID column. This designates that field as the primary key of the table, a role you'll learn more about soon. Next is the product table, which stores the product ID, name, price, and description. I can specify this table as follows. The product ID has the integer data type. The name is a varchar with a 100 character limit. The price has a numeric type with parameters of 8 and 2. The description is varchar with a 255 character limit. And the product ID is set as the primary key within this table. And finally, there's the cart order table, which holds the order ID, customer ID, product ID, quantity, order date, and status. This table is set up as follows. The order ID, customer ID, product ID, and quantity are all integer types. Order date is date, and status is varchar with a 100 character limit. Order ID is the primary key here. However, this table also introduces something new in the form of two foreign keys. Before moving forward, let's quickly discuss what primary and foreign keys are. You may have noticed that the cart order table contains the customer ID and product ID fields. These same fields are also found in the other two tables. This is because these fields in the cart order table are directly linked to the same fields in the corresponding tables. To establish this relationship, each table must contain a primary key. The referencing table then uses foreign keys that point it to the external source table or the referenced table. You'll learn more about primary and foreign keys in greater detail in a later lesson. But for now, let's return to the shopping cart database example. All primary keys have been set up, so the foreign keys for the cart order table come next. I create the first one by using the foreign key keyword along with the customer ID column name. To link it to the customer ID field in the customer table, I then use the references keyword followed by the source table name customer and then customer ID in parentheses. Creating a foreign key for product ID is similar, but with product and product ID as references. So I use the foreign key keyword and name it product ID. I then reference it in the product source table product and then product ID. Then I execute these statements, and the tables appear nested beneath shopping cart DB in the left-hand explorer. In this video, you learned the steps for creating a simple database schema using SQL. The same process applies for both small and large-scale databases.
When creating your databases, you need to be able to distinguish between different kinds of database schemas. In other words, you need to answer the question of what kind of database best suits my project. Over the next few minutes, you'll explore some different types of database schemas, and by the end of this video, you'll be able to explain the concept of a logical database schema and outline the concept of a physical database schema. Let's begin by exploring a logical database schema. A logical database schema is how the data is organized in terms of tables. In other words, it shows what tables should be in a database and explains how the attributes of different tables are linked together. Creating a logical database schema means illustrating relationships between components of your data. This is also called entity relationship, or ER modeling. It specifies what the relationships between entity types are. Let's take the example of a simple ER model that shows the logical schema of an ordering application. It demonstrates the relationship between an order, the shipment in which it will be shipped, and the courier assigned to it. The ID attribute in each table is the primary key of the respective entities. It provides a unique identifier for each entry, row, or record in the entities. In the order entity, the shipment ID and courier ID are called foreign keys, but in fact, they're also the primary keys of the shipment and courier entities, respectively. This creates a relation between these entities and the order table, which in turn has its own ID as its primary key. The other type of schema is physical schema. Physical schema is how data is stored on disk. In other words, this involves creating the actual structure of your database using code. In MySQL and other relational databases, developers use SQL to create the database, tables, and the other database objects. For example, you can create a physical schema for an online store database by writing SQL statements to create tables for customers, products, and transactions. However, physical schema creation could differ slightly between different database systems. Database schemas are vital when it comes to the creation of databases, and they form the basis of your application. You should also be able to describe how a logical database schema refers to the organization of data in tables, and that you use an ER model to specify relationships between entities. And you should also now know that you can control how data is physically stored on disk by creating a physical schema with SQL statements. At this stage of the course, you spent some time exploring the relational model for databases. However, it's crucial that you have a proper understanding of how the relational model influences the design and structure of a database, and how it helps to build relationships between tables. Once you understand how your database is structured, then you can determine how best to extract information from it. Over the next few minutes, you'll learn how to outline the basics of the relational model, identify the different relationships between tables, and explain the basics of an ER diagram. To understand how the relational model influences our databases, let's take the examples of two tables from a college database. The first table shows a list of students, along with their assigned student and course identification numbers. And the second table lists courses that students can study, along with the ID for each course and its department. So the big question in this example is which student is studying what course? And is each student studying one or multiple courses? These are basic examples of why it's important to structure and connect tables correctly. There are three types of relationships between any two tables in a relational database: one-to-many, one-to-one, and many-to-many. Let's begin with an exploration of the one-to-many relationship. In a one-to-many relationship, a record of data in a row of one table is linked to multiple records in different rows of another. In the student table, a student with the ID of 1 is enrolled in 2 courses on the course table. So a one-to-many relationship can be drawn between these tables. This relationship can also be illustrated in a basic entity relationship diagram, or ERD, as student is enrolled in many courses, using shapes and symbols. The diagram depicts the two entities student and course in rectangle shapes with enrolled to describe the relationship in a diamond shape, and many is depicted using the crow's foot notation symbol. The relationship can also be illustrated using a more complex ER diagram that depicts keys. Course ID in the student table is a foreign key, or FK, and this references the primary key, or PK, course ID column that exists in the course table. Next, let's take a look at one-to-one relationships. In one-to-one relationships, one single record of one table is associated with one single record of another table. To demonstrate this relationship, I'll use two new tables, one that outlines key information about the staff in each college department. The other is the department location table that records key data about the location of each department on campus. In this instance, each department head is in one department building on the college campus, so each staff member from the department staff table is associated with one record from the department table. These relationships can also be depicted in an Eeyore diagram as one department head leads one department. And finally, there's also many-to-many relationships. This type of relationship associates one record of one table with multiple records of another table. And the same relationship also works in the other direction. In this example, the student Morris Doyle is undertaking 2 research projects, and each project is supervised by a different staff member. And likewise, one staff member can supervise or collaborate with multiple students on their research projects. These relationships can also be depicted in an Eeyore diagram as many students are supervised by many staff. You should now be able to outline the different relationships that exist between tables in a relational database model. Good work. By now you're probably familiar with querying values or records within database tables. But how do you query specific records and values if they're duplicated across a table? When you come across obstacles like these, you can use keys as your solution. In this video, you'll learn how to explain the purpose of primary key in a database table and select a simple and composite primary key. You may have encountered several examples of primary keys during this course, and in these examples, you saw that they're used in tables as a unique method to identify a record and prevent duplicates. Let's take an example of a student table with 5 attributes: ID, name, date of birth, email, and grade. How could we identify a specific student to enter their grade? Like the student Mary on row 2. All you need to do is find the unique ID of Mary to identify a record of her data. However, in this example, you can't use the student name column because there are 2 students in a table called Mary, and you can't use the date of birth either because another student in a table called Dan has the same birthday. Neither of these records are unique to Mary, so what's the best approach? The solution is to locate a candidate key. This is an attribute that's unique to each row of the table, and it cannot have a null value. In other words, it cannot be empty. In this example, there are 2 possible candidate keys, the student ID and the student email. Both rows contain a unique value for each student, so either one can be used as a primary key. Let's assign the student ID as the primary key. Whichever column you reject as the primary key becomes the alternate or secondary key. In this instance, the email column is the secondary key. But what happens if you can't locate a unique value within a table? Maybe all rows have duplicated values. In this instance, you can create a composite primary key. This type of key is a combination of 2 or more attributes. Let's take the example of the delivery department of an online store. They have a delivery table that tracks the deliveries placed by their customers. However, there's no single column with unique values in each row. So, no column can be considered as the primary key. In this case, the best approach is to combine the customer ID and product code columns to create a unique value for each specific record of data. With these columns, you can determine which customer ordered what product. So together, these columns become the composite primary key. And this key can be used to track the delivery status for each customer. You're now familiar with one single column primary and composite primary key. You should now also be able to identify the most appropriate situation in which to use each one. Great work. Imagine a scenario where a bookstore has a database that contains 2 tables: customer table to track customer information and an order table to track customers' orders. But how can they determine which customer made which order? The solution is to add a customer ID column into the order table column as a foreign key. Over the next few minutes, you'll learn how to describe the purpose of a foreign key and demonstrate how to use it to connect different tables in a relational database. So what exactly is a foreign key? A foreign key is 1 or more columns used to connect 2 tables in order to create cross-referencing between them. By foreign, developers mean external, so the foreign key in one table will refer to an external or foreign column in another table. Let's find out more about how a foreign key works by exploring the tables from the database of an online store. The Stores Customer table contains information about the customer's name and address, while their Order table contains information about each customer's order date and status. The issue is how to connect these tables to make sure that each order is associated with the right customer. Establishing this connection is important so that you can process and deliver orders to the right customers, update order details, or cancel orders if required. A foreign key is a great method of establishing a relationship between these tables so that these other tasks can be carried out. But before you learn about how to use a foreign key, let's take a few moments to explore the concept in a bit more detail. To find out more about how foreign keys work, let's take the example of the relationship between two generic entity tables. These tables are called Table 1, or T1, and Table 2, or T2. The purpose of connecting these tables is to relate records of data that exist in both tables with each other. The foreign key in T1 should point to a related column in T2. In this case, the foreign key column values in T1 must correspond to existing values in the referenced column in T2, and the referenced column in T2 must contain unique values in each row of data. This will most likely be the primary column in T2. In addition, the reference table T2 is known as the parent table, while the referencing table T1 is the child table. Don't worry if all this seems a bit complicated. Let's simplify things by exploring an entity relationship diagram using the customer and order tables from earlier. In this diagram, the order table relates to the customer table by including the customer ID attribute and defining it as foreign key inside the order table. The relationship between these two tables is one-to-many. You might have encountered this type of relationship in an earlier video. One-to-many means that each customer may have many orders, but each order must refer to one single customer only. This means there must be a customer record available in the customer table before any order can be made. But it is not necessary to have an order once a new customer is created. Therefore, the customer table represents a parent table, and the order table represents a child table. This means that the parent can exist and the child may not exist, but the opposite scenario cannot occur. In this example, the customer ID value existing in the order table can be used to fetch the records of a specific customer to determine who placed the order. For example, to generate an invoice or to deliver an order to the customer address. It is also possible for a table to have more than one foreign key. Each will be used to connect the referencing or child table with other referenced or parent tables. In this case, you'll have multiple parents to the same child. Let's add a new table, product table, into the previous diagram to explain this in more detail. The order table now has two foreign keys. One foreign key links it with the customer table via the customer ID, and the other links it with the product table via the product ID. The relationship between these tables is one-to-one. Each order must be related to a specific product record, and each product might be related to an order record, but doesn't have to be. For example, you can receive a new product in your inventory, but no customer has placed an order on it yet. If an order has not been placed on this product, then it's not related to any order yet. So this then raises the question, who is the parent and who is the child? The customer, the order, or the product? The answer is that there are now two parents, the customer and the product tables, and there's one child, which is the order table. You should now understand the purpose of a foreign key, and you should also be able to demonstrate how it can be used to connect tables in a relational database. Well done. When building a database, there's often a lot of different tables that you'd need to consider including. But how do you determine what to include and what to exclude? The answer is to identify the entities you're interested in maintaining data on. In this video, you'll learn how to explain the meaning of entities in a relational database, differentiate between attribute types, and be able to identify entities and their attributes. So let's begin by exploring what an entity is. An entity can be described as an object that has properties which define its characteristics. An entity can be anything that represents a single object in a database, such as a place or a person. In a relational database system, each interesting object in a project could be considered an entity. For example, a customer or individual. And an entity in a table is comprised of rows and columns created in database management systems such as MySQL. Let's explore this concept in more depth using the example of a table that holds delivery records for the database of an e-commerce store. The table name represents the entity name, deliveries, and each column represents the entity-related attributes. And the system holds customer or entity-relevant attributes such as ID, name, and delivery status details. These attributes hold relevant data about the table entity. So, each instance of the customer entity in this e-commerce system contains a record of data about each customer. But there are also different types of attributes in a relational database system. These include simple attributes, composite attributes, and single-valued attributes. And there are also multi-valued attributes, derived attributes, and key attributes. Let's explore these attributes in more detail using the example of a student table in a relational database system. A simple attribute is an attribute that cannot be classified further. In the example of the student records, the grade values cannot be classified further. A composite attribute is an attribute that can be split into different components. For example, the name value of each student could be split into sub-attributes such as first and last name. A single value attribute can only store one value. In the student table example, the date of birth column can only contain one value per student. So these values could be defined as a single valued attribute. With a multi-valued attribute, the attribute can store multiple values in a field. For example, the student email column could hold more than one email per student, a college email address, and a personal email address. However, this practice should be avoided in a relational database. A derived attribute is where the value of one attribute is derived from another. In the student table, the age of each student can be derived from their respective date of births. And finally, there's the key attribute. This is a field that holds a unique value used to identify a unique entity record. A good example are the values contained in the student ID column. Each ID is a unique value which can be used to obtain data about a specific student. Remember that there's no point in considering entities or attributes that will not be used in your project. You only need to capture data in your database system that helps the users of your system complete certain tasks and activities. You should now understand the concept entities in a relational database and be able to differentiate between attribute types. Good work. At this stage, you might be familiar with the process for creating tables within a database. But there are several issues that you're likely to encounter when working with tables, such as unnecessary data duplication, issues with updating data, and the effort required to query data. Fortunately, these issues can be resolved with the use of database normalization. By the end of this video, you'll be able to explain what database normalization is, and you'll also be able to demonstrate an understanding of insert, update, and deletion anomalies, and be able to list some of the issues associated with them. Normalization is an important process used in database systems. It structures tables in a way that minimizes challenges by reducing data duplication, avoiding data modification implications, and helping to simplify data queries from the database. To gain a better understanding of normalization and the challenges it addresses, let's explore an example of a table that hasn't been normalized. In this example, I'll use a college enrollment table. The table serves multiple purposes by providing a list of the college students, courses, and departments, an outline of relationships or associations between students, courses, and departments, and name and contact details for the head of each department. Creating tables that serve multiple purposes causes serious challenges and problems for database systems. The most common of these challenges include insert anomaly, update anomaly, and deletion anomaly. Let's begin with an overview of insert anomaly. Insert anomaly occurs when new data is inserted into a table, which then requires the insertion of additional data. I'll use the college enrollment table to demonstrate an example. In the college enrollment table, the student ID column serves as the primary key. Each field in a primary key column must contain data before new records can be added to any other column in the table. For example, I can enter a new course name in the table, but I can't add any new records until I enroll new students. And I can't enroll new students without assigning each student an ID. The ID column can't contain empty fields. So I can't insert a new course unless I insert new student data. I've encountered the insert anomaly problem. An update anomaly occurs when you attempt to update a record in a table column only to discover that this results in further updates across the table. Let's return to the college enrollment table once again to understand how an update anomaly occurs. In the enrollment table, the course and department information is repeated or duplicated for each student on that course. This duplication increases database storage and makes it more difficult to maintain data changes. I'll demonstrate this with a scenario in which Dr. Jones, the director of the computing department, leaves his post and is replaced with another director. I now need to update all instances of Dr. Jones in the table with the new director's name. And I also need to update the records of every student enrolled in the department. This poses a major challenge because if I miss any students, then the table will contain inaccurate or inconsistent information. This is a prime example of the update anomaly problem. Updating data in one column requires updates in multiple others. Next, let's review the final challenge, deletion anomaly. A deletion anomaly is when the deletion of a record of data causes the deletion of more than one set of data required in the database. For example, Rose, the student assigned the ID of 4, has decided to leave her course, so I need to delete her data. But deleting Rose's data results in the loss of the records for the design department as they're dependent on Rose and her ID. This is an example of the deletion anomaly problem. Removing one instance of a record of data causes the deletion of other records. So how can you solve these problems? As you learned earlier, the answer lies in database normalization. Normalization optimizes the database design by creating a single purpose for each table. To normalize the college enrollment table, I need to redesign it. As you discovered earlier, the table's current design serves 3 different purposes. So the solution is to split the table in 3, essentially creating a single table for each purpose. This means that I now have a student table with information on each student, a course table that contains the records for each course, and a department table with information for each department. This separation of information helps to fix the anomaly challenges. It also makes it easier to write SQL queries in order to search for, sort, and analyze data. You should now be able to explain what database normalization is, and you should also be able to demonstrate an understanding of anomalies and challenges. Well done. As a database engineer, you'll very often come across columns in a table that are filled with duplicates of data and multiple values. This can make it quite challenging to view, search, and sort your data. But with the correct implementation of normalization, this challenge can be dealt with. By the end of this video, you'll be able to demonstrate how to design a database in first normal form, identify the atomicity rule and how to enforce it, and analyze effective ways to eliminate the repeating group of data problems in data sets. As you might already know from previous videos in this lesson, the normalization process makes it easier and more efficient for engineers to perform basic database tasks. It's an especially useful process for helping to fix the well-known insert, delete, and update anomalies. However, in order to achieve database normalization, you first need to perform the 3 fundamental normalization forms. The database normalization forms include first normal form, or 1NF, second normal form, or 2NF, and third normal form, or 3NF. This video focuses on designing a database to meet the first normal form, or 1NF rules. These rules enforce data atomicity and eliminate unnecessary repeating groups of data in database tables. Data atomicity means that there must only be one single instance value of the column attribute in any field of the table. In other words, your tables should only have one value per field. By eliminating repeating groups of data, you can avoid repeating data unnecessarily in the database. Instances of repeated data can cause data redundancy and inconsistency. To understand this better, let's explore an example. To demonstrate data atomicity, I've built an unnormalized table called course table within a college database. It includes information about the college's computing courses along with the names and contact details of the course tutors. And the course ID column serves as the table's primary key. However, there are multiple values in each row of the contact number column. Each row contains 2 contact details for each tutor, a cell phone number and a landline number. This table isn't in 1NF. It violates the atomicity rule by including multiple values in a single field. I can try and fix this by creating a new row for each number. This solves my data atomicity problem. The table now has just one value in each field, but this solution has also created another problem. The primary key is no longer unique because multiple rows now have the same course ID. Another way that I could solve the problem of atomicity while retaining the primary key is by creating 2 columns for contact numbers. One column for cell phones and a second column for landline numbers. But I still have the issue of unnecessary repeated groups of data. Mary Evans is the assigned tutor for 2 of the courses, so her name appears twice in the table, as do her contact details. These instances of data will continue to reappear if she's assigned more courses to teach, and it's likely that her details will appear in other tables within a database system. This means I could have even more groups of repeated data. This creates another problem. If this tutor changes any of their details, then I'll have to update their details in this table and all others in which it appears. And if I miss any of these tables, then I'll have inconsistency and invalid data within my database system. To solve this issue, I can redesign my table to adhere to 1NF, or first normal form. First, I identify the repeating groups of data. In this case, it's the tutor's name and contact numbers. Next, I identify the entities I'm dealing with, which are course and tutor. Then I split the course table so that I now have one table for each entity. A course table that contains information about the courses, and a tutor table that maintains the name and contact numbers of each tutor. Now I need to assign a primary key to the tutor table, so I select the tutor ID column. I've solved the problem of data atomicity, but I also need to provide a link between the 2 tables. I can connect the 2 tables by using a foreign key. I just add the tutor ID column to the course table. Now both tables are linked. I've now achieved data atomicity and eliminated unnecessary repeating groups of data. You should now be familiar with 1NF and the rules that you should apply to avoid it. Good work. As a database engineer, you'll very often come across columns in a table that are filled with duplicates of data and multiple values. This can make it quite challenging to view, search, and sort your data. But with the correct implementation of normalization, this challenge can be dealt with. By the end of this video, you'll be able to explain how to design a database in a second normal form, outline the functional dependency concept, and define the partial dependency concept. Before you begin, make sure that you've watched the video on first normal form, or 1NF. Database normalization is a progressive process, so you must be familiar with 1NF before you can implement 2NF. So why do database developers require database normalization? If you're going to store content, you should aim to have the best possible database. Best means that it has a proper structure that reduces duplication and ultimately allows for accurate data analysis and data retrieval. To get the best results, engineers build tables in a way that optimizes the database structure. This video focuses on how to design tables in a relational database to meet the second normal form criteria. But before you can learn how to do this, you need to understand what is meant by the terms functional and partial dependency. Functional dependency refers to the relationship between 2 attributes in a table. The unique value of a column in a relation determines the value of another column. To demonstrate this concept, let's take the example of a table known as R. This table contains 2 columns called X and Y respectively. X is a column with a set of unique values, which are not replicated elsewhere in the table, a primary key, for example. Y is a column without a set of unique values, like a non-primary key. R is the table or relation in which the columns X and Y exist. Y, as a non-primary key with duplicated values, is dependent on X. This is because X is the table's primary key, as it only contains unique values. Don't worry if you don't quite understand this concept yet. I'm going to demonstrate functional dependency in more detail. Let's take the example of a table called Student that holds key information on students in a college. The table contains 3 columns, a student ID column, a name column, and a date of birth column. I need to use this table to find the date of birth for a specific student. I can't use the name column because it has duplicated values. There are 2 students named Tony. If I query this column, I'll just receive both instances of Tony. And I can't use the date of birth column either, because there are 2 students who share the same date of birth. But I can complete this task by using the student ID column. All values in this column are unique, so it's designated as the table's primary key. And the values of this primary key column determine the information of the other columns. This means that each column in the table is functionally dependent on the student ID column. It's the only column that can be used to return specific data. Now that you've explored the concept of functional dependency, let's look at partial dependency. Partial dependency refers to tables with a composite primary key. This is a key that consists of a combination of 2 or more columns. To demonstrate, Let's take the example of a table that shows the vaccination status of patients in a hospital database. The table shows the vaccination status of 2 patients, David and Kate. It also displays the patient ID, vaccine ID, and vaccine name. There's no one single column with unique values in each row, so there's no single column that can be used as a primary key. So it's best to combine both the patient ID and vaccine ID columns as a composite primary key to create a unique value in each record. The vaccination table must meet the second normal form, or 2NF. So all non-key attributes, the vaccine name, patient name, and status, must depend on the entire primary key value, which are patient ID and vaccine ID. It can't depend on just part of the value, otherwise this creates partial dependency. Let's apply this rule to find out if it's true for every non-key column. So, how do I check that the patient with the ID of 50 has taken vaccine 1? I check the value of both the patient ID and vaccine ID keys. The combined value is the only way to return the vaccination status value of a specific patient. This means that there's a functional dependency between a status value and the primary key value. But if I just want to find out the vaccine name, then I don't need both combined values. The only information I need to return the vaccine name is the vaccine ID. As you learned earlier, this is called partial dependency. This should be avoided in most instances as it violates the 2NF rule. Similarly, if I want to identify the patient's name, I don't need both combined values. I can just use the patient ID to return the patient's name. Next, let's look at how to upgrade this table to 2NF. First, I need to make all non-key columns dependent on all components of the primary key. So, I identify the entities included in the vaccination table. In this instance, there are 3 entities: vaccination status, as represented by the status column, vaccine, which is the vaccine ID and vaccine name columns, and patient, represented by the patient name and patient ID columns. I then break up the table into 3 separate tables as follows: patient table, vaccine table, and vaccination status. Now in each of these new tables, all non-primary key attributes depend only on the primary key value. I've eliminated all unnecessary replication of the vaccine and patient names within the vaccination table. The 3 tables are now in the second normal form, or 2NF. You should now be familiar with the 2NF rule and how to upgrade a table to 2NF. Good work! When working with tables in a database, you may often encounter tables that contain repetitive data. Perhaps 2 columns contain values that are very similar, so you might split the table in 2 to simplify the data. When building relational databases, you can solve similar issues of repetitive data using what's known as third normal form, or 3NF. By the end of this video, you'll be able to understand how to design a database in third normal form and explain the concept of transitive dependency. Before you begin, make sure that you've watched the videos in first and second normal form. A database must be in first and second normal form before it can be in third normal form. In addition to these rules, databases can't contain any instances of transitive dependency. In the context of third normal form, transitive dependency means that a non-key attribute cannot be functionally dependent on another non-key attribute. In other words, non-key attributes cannot depend upon one another. A key attribute in a database is an attribute that helps to uniquely identify a row of data in a table. To demonstrate this concept, let's take the example of a basic table with 3 columns, A, B, and C. The concept of transitive dependency means that the value of A determines the value of B. Likewise, the value of B determines the value of C. The relation between these table columns is represented by A, B, and C. This means that A determines C through B. This is the type of relation that database engineers call transitive dependency. Let's see how this works using a more complex example. I have a table of best-selling books within Europe from the database of an online bookstore. The table organizes the books according to 5 attributes: book ID and title, author name, author language, and country. In this table, ID is the only key or primary key that exists in the table. All other attributes are non-key attributes. But to determine what these non-key attributes are, I must use the ID of the top-selling books. This means if I want to find any specific information about any attribute, I need to use the ID attribute value to find the targeted attribute value. For example, If I use the ID of 3, then I can locate the author Cormac O'Dwyer, the language Irish, the country Ireland, and so on. However, it's also possible to determine the country based on the language, or to determine the language based on the country. And both country and language are non-key attributes. For example, in the context of Europe, it's always possible to determine the country is France if the language is French, and vice versa. This means that I have a transitive dependency in this relation. A non-key attribute depends on another non-key attribute. This dependency relation can be presented as follows. Language determines country, and country determines language. The rest of the attributes are fine, as they only depend on the ID primary key. So you can't say, for instance, that author name determines book title, or that author name determines language. For example, the author Michel Laurie has written 2 books in 2 different languages, French and Spanish. As I've just pointed out, the only transitive dependency that exists in this example is between language and country. So, how do I solve this transitive dependency within my table and remove any repetition of data? I can split the table into 2 tables while joining them to conform with 3 NF rules. So, I keep the top books table while splitting off the country and language columns into a new table called country. But I also leave the country column inside the top books table as a foreign key that connects the 2 tables. The country table now holds just 4 records with no repetition of data, and there's no need for a language column within the top books table. Stating the country is enough to determine the language, and most importantly, all non-key attributes are determined only by the primary key in each table. This means that my table now meets the requirements of 3NF. You should now know how to design a database in third normal form, and you should also be able to explain the concept of transitive dependency. Well done. Well done. You've reached the end of this module on database design. It's now time to recap the key points and skills. You began this module with a lesson on designing a database schema and learned that a correctly designed database is the basis for all subsequent data storage and analysis. It's crucial to know the principles of good database design because a poorly designed database makes it hard, if not impossible, to produce accurate information. Having completed this module, you should now be able to define the term database schema, describe the schema of different database systems, create a basic database schema using SQL, and list the 2 main types of database schema. You then moved on to explore relational database design. In this lesson, you learned how to design a relational database. Having completed this lesson, you should now be able to describe the relational model, list different types of relations, evaluate an entity relationship diagram, or E or D, and explain the purpose of primary key in a database table. And you should now also be able to demonstrate how to select a single primary key and a composite primary key, describe the purpose of a foreign key, connect tables using a foreign key, and summarize the meaning of entities in a relational database. Furthermore, you should now be able to list different types of attributes, identify entities and their attributes, and create links between entities. The last lesson covered database normalization. Normalization is the process of converting a large table into multiple tables to reduce data redundancy. You should now be able to explain database normalization, recognize insert, update, and deletion anomalies, and explain the atomicity concept and describe the repeating groups of data problem. And you should now know how to design a database in first, second, and third normal form, and explain the concepts of functional, partial, and transitive dependency. You should now be familiar with the essential skills and concepts of database design, and you should also be able to create the structure of a normalized relational database. Well done. That's great progress towards your learning goals. In this course, you covered an introduction to database engineering. Let's take a few moments to briefly recap what you learned. In the opening module, you had an introduction to the course and explored possible career roles that you might want to follow as a database engineer. You also reviewed some tips around how to take this course successfully and discussed what it is that you hope to learn. You then covered an introduction to SQL, or Standard Query Language, the coding syntax used to interact with databases. And finally, you explored the basic structure of databases and learned about the different types of keys they use. You began Module 2 with an exploration of SQL data types and learned how to differentiate between numeric data, string data, and default values. You also completed several exercises in which you learned how to utilize these different data types in your database projects. You then moved on to explore CRUD, or create, read, update, and delete operations. You learned how to create databases and tables and populate them with data. You explored how to update and delete data, and you demonstrated your ability with CRUD operations by completing exercises in creating and managing data. In the third module, you reviewed SQL operators and learned how to sort and filter data. You began the module with a lesson on SQL operators in which you explored the syntax and process steps to deploy SQL arithmetic and comparison operators within a database. Next, you covered how to sort and filter data using clauses. The clauses that you learned about include the order by clause, the where clause, and the select distinct clause. You also covered an overview of how each clause is used to sort and filter data in a database. And you went through demonstrations of these clauses and had an opportunity to try them for yourself. In Module 4, you learned about database design. In the first lesson, you had an overview of how to design a database schema. You explored basic database design concepts like schema and learned about different types of schemas. The next lesson focused on relational database design. In this lesson, you investigated how to establish relationships between tables in a database using keys. You also learned about the different types of keys that are used in relational database design, such as primary, secondary, candidate, and foreign keys. Finally, you covered a lesson on database normalization. In this lesson, you investigated the key concepts around database normalization. You then learned about the concept of normal form and about the first, second, and third normal forms. Well done in completing this recap. Now it's time to try out what you've learned in the graded assessment. Good luck. Congratulations on reaching the end of this Introduction to Databases course in the program Metadatabase Engineer. You've worked hard to get here and developed a lot of new skills during the course. You're off to a great start with your database learning, and you should now have a thorough understanding of databases and data. You were able to demonstrate some of this learning along with your practical database skill set by creating and querying a database in the project lab. Following your completion of this first course in Metadatabase Engineer, you should now be able to demonstrate knowledge of different database schema, explain relational database design and table normalization, perform database operations such as create, read, update, and delete, and demonstrate SQL commands by sorting and filtering data. The key skills measured in the graded assessment revealed your ability to demonstrate knowledge of different database schema, explain relational database design and table normalization, perform database operations such as create, read, update, delete, and demonstrate SQL commands by sorting and filtering data. So, what are the next steps? Well, this is the first course in the Metadatabase Engineer specialization, and it has given you an initial introduction to several key areas. You probably realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for the second course? You'll continue to develop your skill set during each of the Metadatabase Engineer courses. In the final lab, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of database systems. The lab consolidates your abilities with the practical application of your skills, but the lab also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this specialization, you'll receive certification in Metadatabase Engineering. The certification can also be used as a progression to other meta role-based certifications. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. Meta certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.
Have you ever accidentally deleted something on your device and wished you could undo your mistake? Wouldn't it be great if you had a time machine to go back and undo your mistake? While humans can't yet travel back in time, programmers working on projects can do something quite like it. They do this using a system called version control. As a programmer, you'll be working with many files in your project, and it's important to keep track of the changes being made. Version control is a system that records all changes and modifications to files for tracking purposes and is essential to your day-to-day development activities. In this course, you will become familiar with version control and how it relates to development. By the end of your studies, you'll understand what version control is, how it works, and how it is used. There are both centralized and distributed control systems available, and you'll examine the different types of workflows available. Conflict resolution is an important aspect of version control, as it helps users manage file and version conflict issues. You'll get to explore popular methods of version tracking using version control technologies like Git and Github, and you will learn how to create and clone a repository in GitHub. In addition, you will become familiar with Git concepts such as add, commit, push and pull, branching and forking, diff and blame. As well as focusing on version control, the course also explores the use of command line syntax with an emphasis on Unix commands. There are many videos in your course that will gradually guide you toward that goal. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then you'll be able to consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. You're not alone in considering a career as a web developer, and the course discussion prompts enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To help you be successful in the course, it's a great idea to commit to a regular and disciplined approach to your learning regime. You need to be as serious as you can about your study, and if possible, map out a study schedule with dates and times that you can devote to attending the course. Of course, this is an online self-paced program, and you can study at dates, times, and places that suit your lifestyle. However, it may help to think of your study in terms of regular attendance, just as you might have to do at a physical learning institute. You may have encountered new technical words and terminology in this video. Don't worry if you don't fully understand all these terms right now. Everything you need will be covered during your learning. In summary, this course provides you with a complete introduction to version control, and it is part of a program of courses that lead you toward a career in software development.
Communication is the most important skill for collaborating with other developers to ensure that you're on the same page when you're building products, and also so that people are keeping track of each other's timelines and the understanding of what the product requirements are consistent. Hi, I'm Layla Rizvi. I am a backend software engineer at Instagram working on Instagram calling in San Francisco. Effective collaboration is important so that we can move cohesively together on large projects with people that have a wide range of skills. As engineers actually have to collaborate with one another a lot. When we build features together, we have to work in parallel with one another to design the best features for our users. We also have to collaborate with a lot of non-engineers a lot. For example, when we built Instagram Live, we had to work with our product managers to figure out what we should build. We had to work with our user researchers to figure out what areas we should focus on to build the best products for our users. We had to work with our designers to figure out the right look and feel for our product. And we had to work as engineers to figure out what we can actually build in the timeline that we had. Communication is one of the most important skills for working with other developers. Learning how to give developers the right amount of context for what they're working on. Learning how to ruthlessly prioritize your work is also very important as a software engineer. There's always going to be an endless amount of things that you can do to improve your product. Learning which things are most important to unblock other developers or unblock yourself is the most important skill. The last thing that's really important to learn as a software developer is to accurately estimate your products. When you first start out, it'll be a little bit tricky, but over time, learning how to say how long a project's going to take and being able to explain the trade-offs is going to be very critical. The skills you need as a software developer changes from company to company a little bit, When you're at a big company like Meta, engineers are much more specialized, whereas if you're in a startup, you wear many different hats. As an engineer at Meta, we have to learn to be able to give just the right amount of context to people for what we need to get done, because we're working with people with little context on the work we're doing. There's so many engineers there. But if you're in a startup, people generally have a little more context on what you're working on, but they might not be as specialized in that area. So you have to do a little bit more learning potentially, and you have to maybe give less context to them. Some challenges I've encountered while learning to collaborate is that I have to learn how to adjust how I work with different people depending on their work preferences. Some people I work with are visual learners, so I learn to whiteboard when I'm talking to them. Some people I work with like to think before they speak, so I learn to be a little more patient when I'm talking to them, to listen to them. A skill that I'm working on learning to develop my own career is I'm learning how to work on mobile. I'm a back-end engineer and I work with mobile engineers every single day to better build products for them. It's nicer for me to understand how they operate, how their code base works, so that we can build better things together. To learn mobile, I took an Android bootcamp class at Meta that Meta provided for backend engineers interested in learning mobile. And after I finished the course, the Android engineers on my team have been giving me small tasks and small projects for me to drive so that I can learn a little bit more about how they work. Practicing effective version control leads to better collaboration because it helps you understand why certain changes were made if you look at a commit. It also helps you context switch between different features or projects that you're working on. Effective collaboration led to a better outcome on a recent project of mine. I'm a backend engineer and I was driving the backend parts of a key project for my team. I had to unexpectedly take time off, but I had a lot of clear commits for my code changes in Git, and I had a lot of documentation for my team, so they were able to easily pick up where I left off, and the project ended up staying on track. You should keep learning to collaborate with other people because the more people you work with, the better products you build, because you'll get different perspectives on what you're building. It's rewarding because your product that you're working on ends up being better. The more people you work with, the more people you can learn from. And ultimately, it's rewarding because the product that you build is going to be better because it's going to have a lot more different input and a lot more different perspectives for how it should be built.
Have you ever worked on a document, made changes to it, and wished you could have gone back to your first version a few days later? Can you remember that feeling of wishing you could travel back in time? For developers, this time machine exists, and it's called version control. In this video, you'll learn about version control's primary features and benefits. Version control is a system that records all changes and modifications to files for tracking purposes. Developers also use the terms source control or source code management. The primary goal of any version control system is to keep track of changes. It achieves this by allowing developers access to the entire change history with the ability to revert or roll back to a previous state or point in time. There are different types of changes, such as adding new files, modifying or updating files, and deleting files. The version control system is the source of truth across all code, assets, and the team itself. Let me give you an example that we're all familiar with. In word processing applications, version control functionality is available to provide users with a safety net of auto-saving the document. The application creates a restoration point on each autosave to which the user can revert if required. Version control systems for coding projects tend to be a bit more complex, but their underlying functionality follows the same process. Working as a developer, you'll need to become familiar with many different tools, and version control is one of them. For developers, especially those working in a team, there are many benefits associated with version control. These include revision history, identity, collaboration, automation, and efficiency. Let's explore these in some more detail. Revision history provides a record of all changes in a project. It provides developers with the ability to revert to a stable point in time in cases where code edits cause issues or bugs. The ability to roll back to a particular version or time allows teams to work faster and deliver code with more confidence. Keeping a record of changes is great, but it doesn't have as much value if you don't know who is responsible for adding or changing a record. All changes made are always recorded with the identity of the user that made them. Combining this feature with the revision history allows teams to see not only when the changes occurred, but also who made the changes. Teams can also analyze the editing, creation, and the deletion of files on the control system. As a software developer, you will often work with a team to achieve a common goal. This can be adding new features to an existing project or creating a brand new service. In all cases, a version control system allows the team to submit their code and keep track of any changes that need to be made. Another important aspect of a version control system is something called a peer review. Developers working on a task create a peer review once the code is ready for inspection. The peer review aims to get other developers on your team to review the code and provide feedback where necessary. The ability to create and deliver code on a wide scale is complex and time-consuming. Version control helps keep track of all changes. It plays an integral role in the explosion of development operations, or DevOps, as it's commonly called. DevOps is a set of practices, philosophies, and tools that increase an organization's ability to deliver applications or services to a high quality and velocity. Version control is a key tool in this process, and it is used not only to track all changes, but also to aid in software quality, release, and deployments. You, as a developer, will usually work on a project alongside many developers and team members with other skill sets. You and your team need to be efficient to make your project a success. You and your team may work using processes from the Agile methodology. In an Agile process, a team normally plan and execute 2 weeks of work to complete, which is called an iteration. Each iteration has a list of tasks to complete before the 2 weeks ends. These tasks, while complex in some cases, are aided by having version control in place. If you would like to learn more about the Agile methodology, there is a link to an additional reading at the end of this lesson. Testing and having some level of automation on every task introduced allows the team to be more efficient. It also ensures more confidence that any new feature being introduced will not break any existing flows. You now know what version control is all about. Great work! Now that you have a better understanding of the goals and benefits of version control, you are ready to learn how to start using it.
An interesting fact about collaborating on projects at Meta is that engineers drive every project at Meta. They're in charge of coordinating with product, data scientists, researchers on what we're building and the timelines for that, whereas in other companies, product managers or leadership is often in charge of each project. I'm Layla Rizvi. I'm a backend software engineer on Instagram Calling in San Francisco. In this video, I hope you learn that effective collaboration is important for engineer success at Meta, and learning how to use version control at Meta is also very important. As a backend engineer on Instagram Calling, for my role, I collaborate with other mobile engineers in my department on a daily basis so that we build the best products together. I also collaborate with Instagram messaging a lot because calling and messaging are closely tied. I also work with non-engineers like product and data scientists regularly as well. To collaborate effectively with my coworkers, we message each other on chat to unblock one another, but when something warrants a meeting, we'll schedule a meeting. When something warrants a document, we collaborate together on a document with comments and leave notes for one another. Version control for Instagram is interesting because we have one giant monolithic repository for all of our code for backend. That means that whenever I'm making a change, the code that I'm writing in is shared with every other Instagram team. It is risky in some ways, but it's also nice in others, so I can reuse their code. The other thing that's interesting about version control at Meta is that any engineer can approve any change. At Meta, they're big on this saying that nothing at Meta is someone else's problem. So that means that any engineer can actually work on any change that they want to work on. Version control at Meta is a little different than version control at a lot of other places. While Meta has a giant monolithic repository for our code where we continuously release our code, many other companies have smaller repositories called microservices for each team. So each team has their own code base and only they work in it. They use branches so that they can take their code and merge it back with like the master branch for their team or product. This is great for smaller teams in some ways, but it has its cons in that you might run into a lot of merge conflicts. At Meta, because we have so many engineers, there would be too many merge conflicts if we had branches for each team in the company. Some collaboration challenges for version control on my team is that because we use a monolithic repository, merge conflicts happen a lot. So we try to write smaller changes so that we can easily revert them. We also try to add a lot of gatekeepers so that if we ship something to production on Instagram, we can easily turn it off without waiting for any rollback. We also share our code with Messenger calling. So we also have to add a lot of tests so Messenger doesn't break us. Git blame is a way for us to look at the revision history for files. It helps us so that if I'm looking at a line of code and I don't understand it, I can figure out who wrote that code and reach out to them. I can also figure out what they were trying to do in that code. They write a message saying what the change was for. It's also great so that I can figure out what change to revert if I'm trying to revert a change. I use it every single day. When I need to understand what some code is doing, I'll reach out to the point of contact that wrote that code, which is especially helpful at Meta where there's so many engineers. I often don't know the person I need to get a hold of, so seeing their code helps. In this video, I hope you learn that learning how to work together effectively and collaborating well as learning how to use version control effectively is critical for success at Meta. Getting a diverse set of perspectives on what features you should build, who you should build for, what a feature might need or how it can improve is really helpful. And the rewarding part is that your end result, your project, ends up being better.
As a developer working in a team, you are continually writing, changing, or updating existing source code. It may happen that while you are working on a new feature, another developer in the team is busy fixing an unrelated bug. With multiple developers all working in the same code base, keeping track of all of those additional updates can be problematic. Luckily, version control addresses these kinds of problems. In this video, you will discover the different types of version control systems, learn how they operate, and learn about their similarities and differences. There are many different version control systems available. For example, Subversion, Perforce, AWS Code Commit, Mercurial, and Git, to name a few. Version control systems can be split into two types or categories: centralized version control systems and distributed version control systems. Both types are quite similar, but they also have some key differences which set them apart from each other. Let's start with centralized version control systems. Centralized version control systems, or CVCS for short, contain a server and a client. The server contains the main repository that houses the full history of versions of the code base. Developers working on projects using a centralized system need to pull down the code from the server to their local machine. This gives the user their own working copy of the code base. The server holds the full history of changes. The client has the latest code, but every operation needs to have a connection to the server itself. In a centralized version control system, the server is the central copy of the project. After making changes to the code, the developer needs to push the changes to the central server so that other developers can see them. This essentially means that viewing the history of changes requires that you are connected to the server in order to retrieve and view them. Now let's discover how distributed version control systems work. Distributed version control systems, or DVCS for short, are similar to the centralized model. You still need to pull code down from the server to view the latest changes. The key difference is that every user is essentially a server and not a client. This means that every time you pull down code from the distributed model, you have the entire history of changes on your local system. Now that you know a little about CVCS and DVCS, let's explore some of the advantages and disadvantages of each. The advantage of CVCS is that they're considered easier to learn than their distributed counterparts. They also give more access controls to users. The disadvantage is that they can be slower, given that you need to establish a connection to the server to perform any actions. With DVCS, you don't need to be connected to the server to add your changes or view a file's history. It works as if you are actually connected to the server directly, but on your own local machine. You only ever need to connect to the server to pull down the latest changes or to push your own changes. It essentially allows users to work in an offline state. Speed and performance are also better than its CVCS counterpart. DVCS is a key factor in improving developer operations and the software development lifecycle. You will learn more about DVCS later in this course. And there you have it. You can now differentiate between a centralized and a distributed version control system. You also learned how they operate and what their benefits are. As an aspiring developer, I'm sure you can appreciate the importance of version control systems. Well done. I'd like you to think back to a time when you thought you'd lost work because it had been overwritten or deleted. As you have previously learned, version control and version control systems help developers keep track of their code and up to date with any changes. In this video, you'll get a feel for how developers use version control to keep track of changes and resolve coding conflicts. When working with a team of developers, it's essential for the code base to have a source of truth that has all historical changes. Version control systems play an integral part in aiding this process by providing a full history of changes of every single file added to its repository. It makes collaboration across a team easier and also aids in working toward a common goal. Whether it is adding new features and following the flow of how they were implemented, or discovering where a potential issue may have been introduced, being able to accurately pinpoint the who, the when, and the what of those changes is paramount. The revision history will record the essential data points so any developer or team member can walk through the entire project from start to its current state. Every change that has occurred on the project should be easily accessible, either by a simple command or integration into the developer's IDE. It's important for organizations to define standards for how developers communicate changes they make. Developers need to know prior to looking at the code what the lead developer's aims are. The more information, the better, and this creates a stronger team environment that is more transparent and open. Now I will guide you through an example of a typical development team working on an e-commerce application. Suppose you're working in a team with 3 other developers to release a new feature. You've been tasked with creating a new feature to enable experiments on the website. This will allow the marketing department to test user behavior. A daily report is generated that ranks the effectiveness of each experiment. The reports will give insights into how each experiment is doing. They will then provide the results of which experiment is the most successful and overall winner. After all the code changes, the developer will push their changes to the repository and create something called a pull request. Developers will then peer review the pull request to approve, request changes, or decline. When working on a single project, there's usually some level of crossover between the developers. When this does occur, the history of revisions can help aid the developers in seeing the full life cycle of changes that have occurred. It is also essential for merging conflicts where multiple developers have made changes that may need to be resolved prior to the code being approved. The history will show who made the change, for what reason, the code itself and its changes, and the date and time of when they occurred. Typically, on a new project, you will encounter changes in one task that may cause potential issues or conflicts with another. The history of revisions will give the team the ability to manage and merge these changes and deliver the business objectives in a timely manner. Well done! You've now learned about the history of revisions. Remember, it's vital to have a system in place to keep a record of all changes to the code base. This is critical when working with a team of other developers. You should now be able to describe how developers use version control to fix any conflicts that may occur during production. Well done! You've reached the end of this introductory module on software collaboration. It's now time to review what you've learned during these lessons. This module started with a case study about how software engineers collaborate across the globe without wrecking one another's code. You then began to explore the answer to the question, what is version control? You learned to describe how modern software teams collaborate and work on the same code base, list different version control systems, explain different version control methodologies, and explored software development workflows. You learned about the history of version control and that it has been in use before the internet was widely adopted. You explored conflict resolution and discovered the important role of version control in the software development process. You learned about some of the common tools and strategies developers use to implement version control, such as workflow, continuous integration, continuous delivery, and continuous deployment. The differences between staging and production were explored, and you learned that the staging environment should mimic your production environment. You also learned the many areas that benefit from creating a staging environment, including new features, testing, migrations, and configuration changes. You learned that any issues should be caught and fixed in the staging environment before going live in production. You have also explored downtime, vulnerabilities, and reputation regarding production. You should now be familiar with version control. Well done. You're making good progress on your learning journey. One of the first things you learn to do when you use a computer for the first time is to operate the mouse and type on the keyboard. At first, it goes slow, but as you become more competent, you interact with your computer and it responds as you want it to. But what does it really mean to interact with your computer? In the context of using a computer, the term interact simply means to exchange information, or even simpler, send and receive information. So essentially, a computer is sending data to you and you receive it. In turn, you also send some data to your computer and the computer receives it. I've talked about the mouse and the keyboard, but can you think of other ways in which you and your computer interact? Computers have various input and output devices. The input devices include a keyboard, mouse, microphone, camera, touch-sensitive devices, and so on. The output devices are things like speakers, monitors, headsets, and haptic devices, to name just a few. You use all these devices to send data to a computer and receive data from it. But there's something else that supports communication with your devices. These are graphical user interfaces, or GUIs, which facilitate your interactions. GUIs are popular because they require very little training to use. GUIs offer an easy way to interact with devices, but they also somewhat limit the scope of human-computer interaction. As an alternative to GUIs and input devices, such as microphones, you will learn to interact with your computer through the command line. The command line is a very powerful alternative because it allows developers to perform tasks quicker and with enough experience, less potential for errors. To use this powerful tool effectively, you need to have a certain level of knowledge. You might feel that the learning curve for the command line is a bit steep, but take it from me, the payoff is definitely worth it. By learning just a few commands, you can perform various tasks, such as creating new directories, creating new files, combining directories, copying and moving files around different directories, and searching through files using various criteria and keywords. As you become more advanced in using the command line, you will be able to perform tasks such as track software, access and control remote servers, search for files using specific criteria, unzip archives, access software manuals and display them in the command line, install, upgrade, and uninstall software, and mount and unmount computer drives or check disk space, and so on. Pretty advanced stuff, don't you think? But the list goes on. You can write scripts to automate various tasks, control user access to files and programs, stop, start, and restart programs, create aliases of only a few characters long to initiate very long commands, download files from the internet, run various software, and finally, run and control self-contained virtual software, which is also known as containerization. There are many, many ways to use the command line, but for now, I will guide you through some basic commands to get you started. First, the cd command, which stands for change directory. This is used to point our command line to a specific directory, for instance, a certain folder. For example, on Linux, if I type cd:// and desktop, I will point the command line to the desktop of my computer. When you type cd:// you will move out of the current directory and back into the parent directory. Next is the touch command, which makes a new file of whatever type you specify. For example, To build a brand new file, you can run touch followed by the new file's name, for instance, example.txt. Note that the newly created file will be empty. You can also make new folders using the mkdir command. For example, mkdir followed by the title you want to give the new folder. To view a history of the most recently typed commands, you can use the history command. There are many other commands that you can use, but with the ones I just introduced, you can already do quite a lot. I'll take you through a quick scenario as an example. Let's say you want to point the command line to the desktop directory, and then add a new folder there titled MyJS project. Next, you want to point the command line to the MyJS project directory, and make a new file which you will call example.js. And finally, you want to open the example.js file in VS Code. To do all of this, you will need to run the following commands. The first action you'll do is to use the change directory or cd command. Then you want to use the mkdir command to make the new folder. To move into the new folder directory, you use the cd command again. And then you use the touch command to create the file. The final command is the code command, which will open the file in VS Code. If you've run all these commands correctly, you'll end up with a MyJS project directory on the desktop with the example.js file inside of it, and additionally, that example.js file open inside VS Code, ready to be edited. In this video, you discovered that you can interact with computers on a more advanced level through the command line. You now have a better idea of what kind of advanced tasks the command line allows you to do. And you are also ready to try out a few basic commands. I encourage you to start practicing some of these commands. Just like you got better and better at typing and moving the cursor with your mouse, I assure you that with practice, you will soon use command line like a pro. I'm pretty sure you use your phone to perform a number of activities, such as sending messages, shopping online, and watching videos. You simply tap your screen, scroll, and swipe. But have you ever thought of how your phone responds to your tapping, scrolling, and swiping? You interact with your phone and computer through a graphic user interface, or GUI, which is just a layer above underlying commands that tells the device what to do. Developers, however, need to know how to use specific commands to perform various types of tasks. For example, to create a new folder on the desktop, you right-click and choose New Folder. In the command line, you use the specific command mkdir to achieve the same result. Having a grip on Unix commands specifically is a great skill to have in today's software development world. In this video, you will get started with a few basic Unix commands. Did you know that the majority of companies run their platforms on the cloud, and 90% of these systems run on a platform called Linux? You might be wondering why I am discussing Linux while the topic of this video is Unix commands. To answer this, let's explore some history. Unix preceded Linux and was developed by Ken Thompson and Dennis Ritchie and team at AT&T Labs in 1969. Linux came much later on and was originally developed as a hobby by Linus Torvalds, hence the name Linux. The commands that you will explore in this video originated from the Unix platform, but you can use them in most modern environments that run some flavor of Linux. Using the command line could seem a little intimidating at first, but you will quickly learn that Unix commands are simply a layer below the normal actions, such as opening file directories or renaming files. Windows, for example, became the dominant desktop operating system mainly due to its easy-to-use GUI. Windows allowed non-technical users to perform tasks without having to learn a list of commands. But you, as an aspiring developer, will learn to perform tasks using Unix commands. Before I delve into some of the most common commands, it's important to note that each command has a set of helper instructions. These helpers give detailed information about how the commands can be run and how something we call flags can be passed. One of these helpers is the man command. Man is short for manual, and when called against a command, it will display a detailed manual of instructions for that given command. For example, the command man -ls will show you the detailed manual of instructions for the list command ls. You can also use something called flags in conjunction with Unix commands. Flags are used to modify the behavior of a command. Think of them as options that can either change or extend the functionality of the given command. Next, you will learn about some of the most commonly used Unix commands, and in the next video, you will see some of them in action. The cd, or change directory command, is used to move from different directories of the file system. You can learn more about working with relative and absolute paths from the additional reading at the end of this lesson. ls is used to show the contents of the current working directory. The ls command can accept many different types of flags that will change what is returned in the response. For example, ls-l lists the file out in list order and shows the read or write permissions, owners, and groups it belongs to. ls-a, on the other hand, will list all files and directories, including hidden ones. The pwd, or print working directory command, shows the full path of the current working directory. The copy, or cp command, copies files or folders from one destination to another. And the mv, move command, moves files from one directory to another. In this video, you learned about some of the most commonly used Unix commands. Next time you use your device, think about what commands run underneath the GUI to complete the tasks you are performing. Okay, so I've opened up my terminal window. Let's navigate to my home directory. I type the cd command and then a tilde, followed by the enter key. Then I use the ls-la command to return all of the files in a list, including all hidden files. Notice two files, a bashrc file and a bash profile file. For now, I want you to focus on the bashrc file first. I can use the command ls.bashrc to check this file. The bashrc file is mainly for configurations. It is essentially a script file that's executed when you first open the terminal window. What's in there will be configurations for the shell itself. For example, the types of colors that I'm using. I can also add in things around my shell history, like how much history of previous commands I want to store and so on. So any configuration options that I put in here will be executed when the terminal session begins. I press the Q key to exit the less environment. The other file is the bash profile file. So I can run the less command again, this time with .profile. This tends to be used more for environment variables. For example, I can use it for setting environment variables for my Java home directory, or my Python home directory, or whatever is needed during development. Again, I press the Q key to exit. Now I will create a simple shell script. For this example, I will use Vim, which is an editor that I can use which accepts input. So type vim, and then I create a new file by typing the testshell.sh and press the enter key. And then at the top of the file, I put in what type of file I want it to be. In this case, it's going to be a bash file. If I press the I key on my keyboard, it'll set insert mode. Then I put in a hash symbol, followed by an exclamation mark, a /, the word bin, another /, and then the word bash. This lets the operating system know that this is a bash script. The script is very simple. I want to print out some type of text onto the screen. So I use the echo command and type in what I want to print out. In this case, hello world. Press escape to get out of insert mode. Then I type :WQ! To save the file. Press enter. And if I look in the directories now, notice there's now a file named testshell.sh. The other thing to notice is that this file can't be run at the moment. In other words, it's not executable. It's just a read-write file, but I want it to be executable, which requires that I have an X being set on it. In order to do that, I have to use another command, which is called chmod. After using this command, I type in the type of permissions that I want. So I type in 755. And then I want to set the file that I want to add the permissions to, which is testshell.sh. And if I use the ls-la command again, I notice that the file has now been turned into an executable file. This means that I can now run the file from the command line. To run the file, I press /testshell.sh followed by the Enter key. And now you notice the words Hello World are printed out on the screen. This is how you can create simple scripts and make them executable within the Bash shell. I've opened up the command line, and first I want to check what directory I'm currently in. To do that, I run the pwd command. Pwd is short for Print Working Directory. I type pwd and press the Enter key. The command returns a /, which indicates that I'm currently in the root directory. This is the top-level directory within the operating system. If I want to check the contents of the root directory, I run another command called ls, which is short for list. I type ls and press the Enter key, and now notice I get a list of different names of directories within the root level. In order to get more detail of what each of the different directories represents, I can use something called a flag. Flags are used to set options to the commands you run. Use the list command with a flag called L, which means the format should be printed out in a list format. I type ls --l, press Enter, and this returns the results in a list structure. Let's focus on some items in this list. First, you need to know what's the difference between the link file, a directory, and a standard file. The link file is always represented by the L, and it's always going to be at the very start of the output. The temp directory has an arrow beside it, which points to TMP. This means temp is the same link to the actual directory TMP. The next item is the bin directory, and it's represented as a D. That means that's just the standard directory, and that you can use the change directory command to actually open the directory and check its contents. Now, let's focus on the etc directory. To change directory, use the cd command. I type cd etc to change to the etc directory and press Enter. Now, I type ls to check the contents. Notice that the contents are completely different from the root. The command returns what's inside the etc directory. To verify that you're in the etc directory, run the pwd command, and it confirms that you are in etc. Again, if I want to change the output, type ls-l, and it returns a printed list format in list structure. Let's cover a standard file, like a text file or a configuration file. The association or the symbol for it is the hyphen. In this case, it represents the file resolve.conf. Understanding the different symbols and different name conventions is important when you're trying to find specific files. Notice that there is a root, and that these just represent the owner and the group that it's associated to. So if I want to move back from the etc directory, there are two ways to do it. One is by typing in cd ... which means that I go back up to the parent directory. Press Enter, and then I type pwd. Notice I am now back in the root directory. To step back into etc, type cd etc. To confirm that I'm back there, type pwd and Enter. If I want to use the other alternative, you can do an absolute path. Type in cd / and press Enter. Then I type pwd and press Enter. You can verify that I am back at the root again. To step through multiple directories, use the same process. Type cd etc and press Enter. Check the contents of the files by typing ls and pressing Enter. Let's try another directory, for example, the SSH directory. Type cd SSH and press Enter. Then type ls and press Enter. Again, you'll notice the different output from each one. To move back up to the previous directory, I can use the cd ... and I should now be in the etc directory. And then again, back to the root using cd ... which will take you back to the root itself. Finally, I can confirm that I am in the root by typing the pwd command and pressing Enter. You have now learned how to navigate and change directories. So first, I want to check what current directory I'm in by using the pwd command and pressing the Enter key. you can see that I'm in the root directory, which displays as /root. If I type in the ls-l command, notice that I have one directory in here called projects. Now I will create a new directory called submissions. I do this by typing mkdir, which stands for make directory, and then the word submissions. This is the name of the directory I want to create, and then I hit the enter key. I then type in ls-l for list so that I can see the list structure. And now notice that a new directory called submissions has been created. I can then go into this directory using the change directory command. I do this by typing cd submissions and then press the enter key. I type the ls command and notice that there is nothing in there. If I want to add some text files or some content, I can use another command called touch. I type touch test1.txt followed by the enter key. To add another text file, I type in touch test2.txt followed by the enter key again. Now I run the ls-l command and notice that the two text files are listed inside the submissions folder. After this, I want to go back to the root level directory, and I do this by typing in cd ... followed by the enter key. And then I run the ls-l command again, and notice two directories are now listed, projects and submissions. Now I want to create another directory called archive. To do this, type mkdir followed by the word archive, and then hit the enter key. To see all of the directories, enter the ls-l command followed by the enter key again. Once again, notice that three directories are now listed: archive, projects, and submissions. To get back to the top view of my terminal, I can clear my screen by typing clear followed by the enter key. After this, I type in the ls-l command, and now I can see all three directories. Okay, so let's say I want to move the submissions folder into the archive folder. This requires a different command called move, written as mv. In this example, I need to specify the directory I want to move and then where to move it to. So I type in mv submissions followed by the word archive, and then I hit the enter key. Then I can check to see if the move happened by using the ls-l command, and now notice that the submissions directory is gone. So now I want to go to the archive directory by typing cd archive. Again, I use the ls-l command, and now notice that the submissions directory is listed inside of the archive directory. Recall that I created two text files inside the submissions directory? Well, you'll notice that they were also moved to the archive directory. So I go to the submissions directory by typing cd submissions, which changes the directory. I use the ls-l command followed by the enter key. And now you can see the two text files are present and they were moved too. You have now learned how to make directories and files and move directories and files. Okay. So I have launched my terminal and I'm running the ls command. It informs me that I have two folders, archive and projects. Next, I can change directory into archive using the cd command and search inside using ls. This reveals a submissions folder. I can then type the cd submissions command to enter into the submissions folder and check what's inside. The ls command reveals two files, file1.txt and file2.txt. Each of these files have some content in them. I can check the content of a file by running another command called cat. I run the command cat file1.txt. This returns the contents of the file, which is some simple text. Another command is the word count command, which is abbreviated as wc. To use this command, I can just call it against the file by typing wc file1.txt-w. The W flag tells the wc command to return the word count. The output informs me that there are 181 words in the file. Let's run another example with pipes. Pipes allow you to pass the output from one command as the input to another. I can perform an ls command on the current directory. Note that this outputs two file names. Let's type the ls command again. Then I pass in my pipe using the vertical line character. Then I use the wc command with the -w flag. Notice that it returns a result of 2 because there's two files in the system. So, what if I want to find the word count of a file using pipes? I just change the ls command to catfile1.txt pipe wc-w. This returns a word count of 181 for file1.txt. Did you know that you can also combine this command against the directory or multiple files? For example, I can use the command to get a combined word count for file 1 and file 2. To get this data, I just input the command catfile1.txt and then also pass in file2.txt. Then I use a pipe followed by a wc-w. This returns a total word count of 362 for the two files. In this video, you will learn about redirection and the different types of redirection you can use. The basic workflow of any Linux command is that it takes an input and gives an output. The standard input device is the keyboard. The standard output device is the screen. With redirection, you can change the standard input and/or output. There are three types of I/O or input-output redirections: standard input, standard output, and standard error. The shell keeps a reference of standard input, output, and error by a numbering system. The 0 is for standard input, 1 is for standard output, and 2 is for standard error. Now you will learn about each of these redirection types. Let's start with standard input. Taking input normally refers to a user typing information from the keyboard. We use the less than sign for user input. The cat command can be used to record user input and save it to a file. How do we take input and store it in a file such as a .txt file? Let me explain how you can do this by using an example to store user input to a text file. So I have just launched my terminal. But how do we take input and store it in a file such as a .txt file? One of the commands you learn to use frequently in this course is the cat command. This command is actually set up to take in input. On my terminal, I type the cat command followed by a greater than sign, and then follow it by the name of the input file. In this scenario, input.txt. Press enter. Now I can add text to the text file created. At the end of the text, press enter. Next, press Ctrl-D to tell the cat command that's the end of the file. To output the contents of the file, enter cat followed by a less than sign, followed by input.txt. Press enter. Notice that the text that I added from the keyboard displays. Let's discuss standard output now. A lot of the commands we have already used, for example ls, send their output to a special file called the standard output. Output direction is handled with a greater than sign. I/O allows us to use redirection to control where the output goes. Now I will demonstrate how you can send output to a text file. Everything in Unix Linux is a file. This means every time you run a command like ls and press enter, it sends the output of the file to an stdout file. In Linux, if you want to control where the output goes, you can use a redirection. How do we do that? Enter the ls command, enter -l to print it as a list. Instead of pressing enter, add a greater than sign redirection. Now we have to tell it where we want the data to go. In this scenario, I choose an output.txt file. The output.txt file has not been created yet, but it will be created based on the command I've set here with a redirection flag. Press enter, type ls, then press enter again to display the directory. The output file displays. To view the content of that file, use the last command followed by output.txt and press enter. The content that displays using the ls-l directory includes the different files available. Errors occur when things go wrong. When using redirection, you also have to specify that the error should be written to a file. You can do that by explicitly setting the number 2 before the output arrow. And you can also combine it with the standard output of 2 greater than $1 to print both the standard output and error if any occurs. You have already learned that input is represented by 0 according to the shell. Output is represented by 1. The input stream uses the less than sign. The output stream uses the greater than sign. And the error stream uses 2 followed by the greater than sign. It may happen that an error occurs when you are outputting data to a text file. Remember that the error will not correspond with the output stream. It will change to use the error stream, which is represented by 2. Let me now demonstrate how this works. So I've the terminal open, and I'm running a similar example to the standard output. Type the ls command. Follow this by -l to try and print it as a list. Instead of using a directory that we know exists, I'm going to use one that doesn't exist. Enter /bin /usr. Now type a greater than sign followed by the name of the output file. In this scenario, type error.txt. Press enter. Notice that the message cannot access. It states that there is no such file or directory. Normally, you think that it would still print the contents of the file, but because an error occurred, it prints it to the console. There are 2 ways to send the contents to the error.txt file. I type ls-l /bin /usr, then add the number 2, which represents the error output, followed by the greater than sign. Now enter the name of the output file, error.txt. Press enter. To see what we have inside the error file, type less followed by the file name. In this case, error.txt. Press enter. The error message ls cannot access /bin no such file or directory displays. If you want to handle both cases where it may find data or may not find data, you can pass in a different redirection. So it handles each one both for output and for error. To do this, again, enter ls-l /bin /usr. Next, add the greater than sign for output, followed by the file name, error_output.txt. This time, we're going to use another redirection to signify that we also want to get errors. To do this, I enter a 2 followed by a greater than sign. This is followed by an ampersand sign and the number 1 to get the output that is available. Press enter. To have a look inside the error file, type /error_output.txt and press enter. Notice that the errors contained inside the error.output file displays. And that brings us to the end of this video. Now you know what redirection is and how to use the 3 types of input-output redirections. Well done. grep stands for Global Regular Expression Print, and it's used for searching across files and folders as well as the contents of files. On my local machine, I enter the command ls-l and see that there's a file called names.txt. If I access that file using the less command, it displays a list of first names in non-sequential order, as in not arranged alphabetically. So what I'll do first is use grep to find some patterns of names that start with similar matches. Then I'll also show how grep can be passed with different flags to get different results. First, I'll perform a standard search using grep. So what I'm going to do is look for names that begin with Sam by entering the command grep samnames.txt. This then returns a list of names that begin with Sam. Keep in mind that grep is case sensitive, which means if I run the same query with a lowercase s, it returns a completely different set of results. Because this query doesn't match the capital S, it returns partial matches in which Sam appears in the middle or end of a name rather than the beginning. Fortunately, I can pass in a flag to ignore case sensitivity. I can do this with the command grep -i, followed by the keyword Sam, and then the file name names.txt again. This time, I get back both users that begin with Sam and also with Sam as a partial match in the middle or the end of the name. So the result set changes based on the type of query that I passed through with different flags. We could also do an exact match by passing in a different flag, and that's the -w, which means it'll match exactly what I'm looking for. So I'll input grep-w and then pass in the keyword Sam with a capital S, and finally our file name names.txt. In this case, we only get back a single result with the name Sam, as any partial matches are ignored. Lastly, I can use a pipe command to combine different searches for grep itself. For example, let's say I want to search across a list of directories for certain executable files. I can combine that with different commands and search across the file structure to find exactly what I'm looking for. If I check all the executable files inside the bin directory by running ls/bin, it returns a long list of results. In order to filter that down, I can run the same query of ls/bin, but this time I'm going to pipe it. Pass in a grep and then enter the keyword zip. You'll find that in this case, I get a much smaller subset back in the results. And if I need to refine it further, then I can also apply the different flags to look for an exact match, a partial match, or ignore case sensitivity. Great work! You've reached the end of this module on the command line. It's now time to review what you've learned during these lessons. In this module, you learned how to use the command line to execute commands in Linux. You were introduced to some of the most commonly used commands that traverse, create, rename, and delete files on your hard drive. You learned how to use piping and redirection to create powerful workflows that automate your work. Having completed this module, you should be able to describe what the command line is and how it is used, explore your hard drive using the command line, create, rename, and delete files and folders on your hard drive using Unix commands, and use pipes and redirection. This module began with a video exploring the answer to the question, what are Unix commands? You learned how to determine the current working directory using the pwd command. You also explored how to create and change directories and files using the command line. You can now create a working directory, create two different directories, dir1 and dir2. Create files and directories inside dir1 and dir2. You can now also use grep to search for files, folders, and contents of files. You're now familiar with the command line. Well done. You're making good progress on your learning journey. Are you familiar with version control or version control systems? Here's a quick example of where they're useful. Have you ever opened an app on your phone and received a prompt to update to a new version? These prompts most likely direct you towards an app store, where you then download the latest version. As you download the new version, you might notice a new layout, button, or piece of functionality. In software and web development, developers use version control to track the differences between versions. And a popular method of tracking versions is the use of version control technologies like Git and Github. In this video, you'll discover the answer to the question, what is Git and Github? You will learn about the differences between Git and GitHub and how web developers make use of them, and explore the benefits and advantages of both services. Let's start off with Git. Git is a version control system designed to help users keep track of changes to files within their projects. Git was designed to address the challenges that its creator, Linus Torvalds, was having managing the development of the Linux kernel, the operating system for Linux. Linux has thousands of contributors who commit changes and updates daily. Git was designed to help with the challenge of tracking all these changes and updates. As well as helping to keep track of changes, Git was also designed to tackle some of the shortcomings of other version control systems. The benefits that Git offers over similar systems include better speed and performance, reliability, free and open source access, and an accessible syntax. It's also important to note that Git is used predominantly via the command line. Developers tend to find Git syntax and commands easy to learn. The other service commonly used by developers is GitHub. GitHub is a cloud-based hosting service that lets you manage Git repositories from a user interface. A Git repository is used to track all changes to files in a specific folder and keep a history of all those changes. It incorporates Git version control features and extends these by providing its own features on top. Some of the most common of these features include access control, pull requests, and automation. You will learn more about these later in this course. The features are split out into different pricing models to suit different size teams and organizations. It's also important to point out that GitHub is very popular among web developers. It's like a social network. For example, projects can be private or public. Users on GitHub have their own profile, which other users can follow. Public projects can accept code contributions from anyone across the globe. And it also includes multiple features outside of its core development tools, like documentation, ticketing, and project features. You're now familiar with Git and GitHub version control systems, along with the benefits and advantages that they offer. This is just the beginning of your version control journey with Git and GitHub. Great work. Okay, so I have just logged into the GitHub website. Once there, I click on the green button with the text Create Repository. When I click on the button, I am redirected to the Create a New Repository screen, where I'll be prompted for who the owner is. I choose my account as the owner option for this example. Next, I need to input a repository name. So I type a name called my-first-repo. Notice that the input field has a green tick icon beside it. This is just GitHub letting me know that this name is available to create the repository. If it's not, I will see an X icon and be prompted to rename it. Okay, so now I need to type a value for the description input. For this, I type practice account for learning Git. The next option I want you to know about is if you want the repository to be public or private. Public just means that anyone on the internet can see the repository. I still have control over who can make changes to it. It's just available on the viewable aspect of it on the internet. The next option is private, meaning it's not available for anyone to see. I can only allow access by granting people access to the repository. The next few options are about initialization. I can initialize a repository with a README file, a git ignore file, and a license if one is required. For now, I'm just going to choose the README file option and then click the Create Repository button. Okay, so a repo has now been set up, and I can see that I have one single file in the repository called readme.md. MD is just short for Markdown, a popular method for creating documentation because it's shorthand for creating HTML pages. This allows me to do things like creating titles and texts. I can insert images and various other web page elements. Notice that the main branch has also been created, and it's important to know that every repository you create will have a single main branch at the start. This is also known as the main line. Next, I'm presented with additional button options. The first is labeled Go to File. Then there is Add File, which you can use to add a new file from the UI. And finally, a green button labeled Code. Clicking this button provides me with the GitHub UI options for cloning down the repository. First is the option for HTTPS, which contains the HTTPS URL of the repository. And I can use this to pull it down by using the git clone command. Next, there is an option for SSH, but to use that, I have to set up my SSH keys and assign them to the user accounts. And finally, I have the GitHub CLI option. Underneath, notice that there are additional options for GitHub Desktop if I would like to use that. And finally, I can also download a compressed zip file containing all the files and folder structures. For this demo, I will show you how to use HTTPS. To begin, select the HTTPS option and click on the copy button to copy the HTTPS URL for cloning. Now I go to my command line that I will be using to run the commands to clone the repository. I'm currently in my home directory. Okay, so what I usually like to do is create a directory for all repositories that I'm working on at the moment. First, I create a directory using the command make dir. Then I type the name of the directory I want to create, which is projects. Next, I can cd into that. And now I can run the commands to clone the project from the GitHub UI. To do this, I type the command git clone and paste the HTTPS URL I copied earlier. Finally, I press enter on my keyboard. Notice that I receive a message stating that Git is cloning into the My First Repo folder. It then displays messages about all the objects that have been received. It also displays a 100% status message and then finally a statement that simply says done. Now I can list the directory by running the ls-la command, which means list all directories. Notice that I have my repository, which I named My First Repo. This is the name of the repository that we set up on GitHub. Finally, if I enter inside that folder using the cd command, I can see a single file, the readme.md file. If I use the ls-la command, another file is listed, which is just named .git. You will learn more about this later when you explore how to use this for source control. As you now know, GitHub is a cloud-based hosting service that lets you manage Git repositories from a user interface. It's like a social network. You can follow users or accept code contributions from anywhere in the world. In a previous video, you created and cloned a repository to your local device. I am now going to explain to you how to pull the repository to your local device. I will be demonstrating commands that you can use in Git Bash Shell for Windows users and Terminal for Mac users. This refers to the application where the commands are typed in. Let's move to the directory I want by typing cd and the name of the directory, My First Repo. Once inside the directory, run the list all command by typing ls -la. -la is short for list all. There are 4 items in this directory. I will focus on 2 of them, the .git item and the readme.md item. Let's start with the readme.md file. This item was added when I created the repository on GitHub. The other item is a folder called .git, which is a hidden folder used to track all the changes. In Linux, any folder starting with a dot is a hidden folder. This folder is automatically created when you create a repository, and you will learn more about it later in this course. In the command I ran, I added the switch -la so we would list all files and folders, including the hidden ones. The .git folder is initialized by running the git init command. As the repository was created on GitHub, it was not required for us to run it. GitHub handled all of this as part of its create new repo flow. Now let's focus on Git workflow. Git uses workflows which can be broken into 3 states, namely modified, staged, and committed. Now I will go over each state and then provide an example of adding a new file to my Git repository to show it in action. Let's start with the first state. Adding, removing, and updating any file inside the repository is considered a modified state. Git knows the file has changed, but does not track it. This is where the staging state comes in. Let's turn to it now. In order for Git to track a file, it needs to be put in the staged area. Once added, any modifications are tracked, which offers a security blanket prior to committing the changes. Then, the last state is the committed state. Committing a file in Git is like a save point in many ways. Git will save the file and have a snapshot of the current changes. Let me introduce you to an example that summarizes the workflow clearly. Suppose you have a workflow that contains the 3 stages just mentioned, as well as the remote repository. A file is added from the working directory to the staging area. From there, the file is committed and then pushed to the remote repository. From the remote repository, the file can now be fetched and checked out or merged to a working directory. You will learn more about this later. Well done! You've covered some of the Git fundamentals and now know what is inside a Git folder and understand the Git workflow. So I've opened up my terminal window. I'll have a look at what directory I'm currently located in. I can do this by running the pwd command, which is short for print working directory. Notice that I'm in the directory my first repo. Now I can check inside that directory by running the ls-la command. I can see that I have two items, a readme.md file and a hidden folder called .git. Before I add any files or make any changes, it's always good practice to check if any changes or commits are currently there. I can do this by using the git status command. Git status also displays what branch I'm on. In this instance, I'm prompted that I'm on the branch called main, and that my branch is up to date with the origin main. This means that all the latest files on my local machine are exactly the same as what is displayed on the GitHub UI, which represents the server that everyone commits to. Git status also tells me that I have nothing to commit and that my working tree is clean. Now, let me show you how to add a simple text file. I'll add a file called test.txt by using the command touch test.txt. Then I'll run the command git status again. Now Git is telling me that I have an untracked file, which is the test.txt file that I just added. It's also telling me that I have nothing added to the commit, but that untracked files are present, and that I should use git add to track them. The purpose of the git add command is that I'm essentially prompting Git and letting it know that I want to track this file, and that it'll be included as part of my commit. The first phase of this process is just to run the command git add test.txt. Now I'm going to run git status again to check that file is now being tracked. Notice again that I'm notified that my branches are up to date. But it's also telling me now that there are staged changes to be committed, which is this new file called test.txt. It prompts me asking if I want to revert those changes. For this, I can use the git restore command with the flag --stage and the file name test.txt. Running the command will unstage the file from the commit. I then run git status one more time to see the file is back to an untracked status. So once again, I'll add the file using git add test.txt, run git status, and now notice that the file is back in a tracked state. Okay, let me clear my screen before moving on. To do this, I use the clear command. Now any changes that I make from here on will be tracked. And then at the end, I will use the git commit command. The staged area is really important because you're essentially preparing to get all of the files and changes that you want as part of whatever feature you're working on. Basically, you are getting all of that content ready for commit. You also have to remember that this is only on your local machine. The distributed manner of Git means it will only push to the server using the actual push command itself. But any change you make here is only specific to you and your local machine. Anyone else who pulls down the project from GitHub will only get what's available on the remote server. Okay, now I want to explain to you how to run the git commit command. First, type in git commit. You can pass in a flag of -m, which stands for message, allowing you to type in a message which will be attached to the commit. In this example, the message is adding a new file for testing. Next, press return on the keyboard, and now notice that the response states 1 file change, 0 insertions, 0 deletions. There is also a create mode statement with the name of the file, test.txt. Finally, if I run the git status command, the response says that there is nothing to commit and the working tree is clean. However, I want to be aware of the message at the top of my screen. This message tells me to use git push to publish my local commits. And this ties back in with what I mentioned earlier. All of these changes are on my local machine, and they will only be uploaded to the remote server when I run the push command. You'll learn more about the push and pull commands in a future lesson. Okay, I've opened my command line. I should check to ensure that I'm in the correct directory using the pwd command. I can see that I'm in the My First Repo directory. Now, it's good practice to perform a git status command to make sure that I have no commits outstanding. If there are no commits and the shell is clear, then my branch will show as up to date with origin main outside of the main branch itself. So my next step would be to create a new branch. To create this new branch, I use the git checkout command by typing git checkout-b. I then call this new branch feature/lesson, which I'll refer to as feature lesson for the purpose of this video. But this is just one way to create a branch. I could also use git branch and pass in the name as well. These methods are the same and can both be used to create a branch. The key difference between them is that git branch just creates a branch, but git checkout-b moves me from the main branch into the branch that I created. I can verify that I've been moved between branches by running the git branch command. This will then tell me if I have switched from the main branch to one of the feature lesson branches. Any changes that I make will now only occur in this new branch. It's important to remember that the main branch has no indication or knowledge of any of these changes, even when I push code to the main repository. This is because that branch exists in isolation. The new branch needs to be merged back into the main branch to recognize changes in the feature lesson branch. This is where it'll come in with a pull request. The purpose of a pull request is to obtain a peer review of changes made to the branch. In other words, to validate that the changes are correct. When coding, many teams will have conditions around the unit tests and integration tests. These conditions will usually include validating that the standards have been met for merging back into the main line. A team will also check for any issues that might have been missed. The next step is to add a file to the new branch. I can create a simple text file called test2.txt using the command touch test2.txt. Then I add it using the git add command. I then commit it using the git commit command. Once I've committed the new file, I need to push my changes up to the remote repository with git push. I type git push-u origin feature lesson. It's good practice to specify -u. This means that I'm only going to get updates from the upstream, which in this case will be the main branch. The result of this is that the origin won't be my main branch anymore. Instead, it's feature lesson. I press the enter key and this pushes the new branch up to the remote repository. As I am using HTTPS, I will be prompted for my login information. Once this action has been completed, GitHub will recognize that a new branch has been added. It will then prompt me to create a pull request that can be compared against another branch, in this case, the main branch. So my next step is to open the GitHub UI. GitHub will show my new branch with a prompt. Click on the Compare and Pull Request button. A pull request lets the team know that I've made new changes that I want them to review, and that I also want to approve or request changes to the actual pull request itself. Another thing to note on the GitHub UI is that I'm comparing this with the main branch. I've essentially cut a branch from the main called feature lesson. I've then added a new file called test2.txt, and it's this file which is the main difference between the two branches. Next, I check the pull request. I can see that there's been one commit. In other words, just one file has been changed, and it's been added as test2.txt. I then click Create Pull Request. The team will then review the changes and either approve or decline them. Once approved, you can then merge your changes to the main branch. This is much cleaner than everyone working off the main branch. It's particularly useful if you have features that are closely tied together. For example, you could be working with a feature that crosses over with some code or requires changes that most likely will be altered by someone else. So, the approach of keeping everything at branch level is much easier than having everyone working from the main line. In fact, everyone working off the same branch is more likely to cause issues. Having independent branches makes the project easier to manage. Also, there's no limit to how many branches you can have. The team decide on the naming conventions that they use. In a lot of cases, when adding a new feature, you can add the keyword feature, then followed by the branch name, like a URL path, such as feature/lesson in this example. For bug fixing, fix/ can be used. So, because we have no reviewers in my current project, I'm just going to merge the branch. Then I'll confirm the merge. Once confirmed, I'm presented with the option to delete the branch. On your own projects, it's up to you whether you want to keep the branches or delete them. For now, I'm going to keep the branch. Then I can return to my code where the test2.txt file has merged into the main branch. I can then confirm that by going back to my command line. Next, I look at Git status again to check if there's something to commit. At this point, there's nothing outstanding. I'm still on the feature lesson branch. I can check out my main branch by typing git checkout main. Then I run the git pull command. I'll then receive the latest changes that were merged in from the feature branch that I just created. Notice that the test2.txt file is now available. I can also verify that by doing a simple check within the directory by using the ls command. This returns a readme file, test.txt, and the test2.txt, which is from my branch. You have now learned the branching workflow, which you'll use regularly when collaborating with other developers. In the pre-internet era, saving project files to different machines for backup and transfer was a tedious process. It required manually copying files between machines one at a time, making things slow for teams. Nowadays, the cloud has enabled a more efficient way to do this. And in this video, I'll explain the differences between remote and local on GitHub. You have previously learned about the flows modified, staged, and committed in a Git workflow. Now you will learn about pushing your changes from your local to a remote repository. Remote refers to any other remote repository to which developers can push changes. This can be a centralized repository, such as one provided by GitHub, or repositories on other developer devices. In this lesson, you will be hearing some new terms, such as clone, push, pull, and repo. Don't worry, these will all be explained soon. The remote code is accessed through a URI, which is unique and only accessible to those who have permission. Local, on the other hand, refers to your machine, which can be a laptop, desktop, or even a mobile device, and is only accessible to you. To demonstrate both of these in action, let's say we have a project called Coding Project 1, which is located on GitHub with a unique URL. In other words, this project is stored on the remote server. When a user wants to copy this project to their local device, they need to either perform a clone, if it's the first time, or pull it to get the latest changes. To clone a project, a user must first choose a folder on their local machine. Coding Project 1 is then cloned from the server and copied into the chosen folder. The user can then make changes to the project and push those changes back to the server. Other users working on the code base won't see those changes on their local machines unless they pull the latest changes from the server. One of the advantages of Git is that you can work offline and then commit your changes when you are ready. Now, let's go through an example of how exactly you would do this in GitHub. In this video, I'm going to explain what local and remote mean in GitHub and help you to understand the differences between the two. First off, I'm going to create a new local repository using the git init command. I'll start by inputting mkdir to create a new directory, and then I'll set the name as my second repo. Next, I'll use the change directory command, which is cd, followed by the name that I just set. Finally, I'll perform the git init command to create my new repository. This will return a line telling me that an empty repository has been initialized under root, projects, my second repo. If I execute another command called git remote, it comes back as blank. The reason for that is that I've only initialized a local repository which has no connection to a central repository that sits either on GitHub or another server. Right now, it's only available locally on my machine. Now I'll step back out from this directory and go into my first repo with the cd command again. This is a repository that I created earlier and does have a connection to GitHub using the remote URI. I'll then check it by using the git remote -v command. Git tells me that it's set to Git Tutorials 101 myfirstrepo.git. Next, I'm going to set this against our second repository. I'll step into the new directory once more using the cd command. In this case, we're going to add this URL to the remote settings by using the command git remote add, specifying a name and then passing in our URI. The name that is typically used here is origin, so I'll stick with that. So again, the full command with the URL should read git remote add origin git at github.com git tutorials 101 myfirstrepo.git. This time when I execute the git remote -v command, I have this set up against the Git Tutorials 101, which sits up on GitHub. What I'm going to do next is use the git pull command, which will connect with the GitHub server and pull down all the changes from the repository. So on my local, I now have all the changes. But when I check the directory, it's blank. The reason for this is that I haven't set up a branch that matches with what I have on the server repository. Fortunately, I can change that by performing the command git checkout main, which will set up a branch main on my local that tracks the branch main from the remote. And now when I check my folder using the ls command, it confirms that I have the readme, test, and test2 files available on my local. In this video, you learned about the differences between local and remote in GitHub. This will help set you up to exchange data more efficiently within your development team. See you next time. By now, you should know how to use git add and git commit to add new changes to your local repository, put them into the staging area, and get them ready for a commit. Now, let me guide you through the next step and upload these changes to the remote repository using git push. I'll also demonstrate how to retrieve changes from the remote servers and apply them to your local repository with git pull. Before we begin, let's go over the command line and perform the command git status. Git tells me that I'm on the branch main, but also that my branch is ahead of the origin main branch by one commit. What this means is that all the changes that I have on my local repository are currently ahead of what is stored in the remote repository on GitHub. That ties into Git's distributed workflow, in which you can work in an offline state and then only ever communicate with a remote repository when you use the commands of git push or git pull. Now I'll guide you on pushing your changes to the remote repository, and then I'll demonstrate how to use the pull command to get the latest changes. It's always good practice to check which branch you're currently on, and you can use git status or git branch to do this. This is important because if you do make changes in a different branch, you need to specify where you're pushing up to. So let's push up the changes using the git push command. I'll specify the origin branch to be the main branch, as in I'm pushing my changes to the origin as the remote repository, and then I want to push it to this branch as the main. I'll be prompted for my login information as I am pushing using HTTPS. Once I enter my login information, you'll notice that the commit is pushed from the local main to the remote main on the remote repository. Let's refresh the page on the GitHub website. You can see that my test.txt file now appears there. That's taken the commit snapshot that I have in my local repository and pushed it up to the remote repository. Git has then compared those files with what's on the remote repository to find any conflicts or problems. If none are found, it'll just merge them straight through, which is classed as an auto merge. If there are any conflicts, my push will fail. Before doing a push, it's also good practice to perform a git pull in order to get the latest changes from the remote repository and reduce the odds of encountering a conflict. Because I only have a single file and this will be a new repository, I'm not going to run into any conflicts or any issues. So now let's move on and I will guide you through how you can use git pull. Normally, when you're working on a project, you could have several developers all submitting with different branches, different code, and different features. In order for you to get those changes, you need to use the git pull command. To demonstrate this, I will add a single line to the test.txt file using the GitHub UI and then add the commit change, updated the test.txt file. I'll then commit it directly to the main branch by clicking on Commit Changes. The changes now appear on the UI, but because I haven't used the git pull command on my local machine yet, I should have no content on the test.txt file. Let's verify by using the cat command on test.txt, and sure enough, the file is empty, which is what you'd expect. As I mentioned before, I need to run the command git pull. This will get the latest changes from the remote repository. If any new changes were added, it'll be reflected in the shell output. I run the command, and in this case, Git tells me that one file has changed with one insertion. If I run the cat command on test.txt once more, it shows that the line "This is my change" is now available in my local directory. With git pull, you're taking all that data from the remote server. Git then merges the snapshot from the remote with the snapshot that's on your local. It will auto-merge them if there's no conflicts. Once that's complete, I'll have the latest changes on my local machine. You have now learned how to push to and pull from your GitHub repository. Have you ever applied for a job? You know the process. Prepare your resume, look for jobs, submit an application, prepare for interviews. That is an example of a workflow. In computer programming, workflows are really important. By the end of this video, you will be able to describe what a workflow is, and you will also be able to identify different workflows available. Now, let's start with an example to illustrate why workflows are important. As a developer working on a project, you first need to pull the project down from a remote repository to your local machine. This is commonly called checking out a project or pulling a project. Once on your local machine, you can build and run the project and make changes. When you are done, you have to push the changes you made back to the remote repository so other developers can see them. From this example, you can understand that the purpose of a workflow is to guide you and other members of your team. It should not disrupt or cause blockers for deployment or testing or for any other developer who contributes to the project itself. Choosing a workflow needs careful consideration. It can depend on the size of the team, the culture of your workplace, and also the type of product you intend to build or update. With that in mind, let me explain feature branching, a common workflow used by many developers. Feature branching means you create a new branch from the main line and work on this dedicated branch until the task is completed. Rules and conditions need to be made in order for this branch of code to be kept in a good state. Every code base has a main repository, which is essentially the source of truth for the application. All changes, such as add, edit, or delete, are submitted directly to the feature branch. The main branch stays as is. When you are ready and happy with the code you have added, you have to commit the changes and then push to the server repository. To commit, you push the changes, and as it's a feature branch, a pull request follows. The pull request is compared to the main branch so developers who peer review the code can see exactly what was changed. Once it's reviewed and approved, it can then be merged into the main line. Now, let me guide you through how this works using Git and GitHub. Before creating a new branch, always ensure you have the latest code. You can do this by running the git pull command to pull the latest code from the remote repository. Next, you need to create your new branch. You can do this by passing the -b flag with the checkout action. Next, let's add new content to this branch. Let's create a readme.md file. To do this, type git add dot or git add readme.md and press enter. Next, you need to commit the new file and provide a meaningful message so other developers can discover what you added. To do that, run the git commit command with the -m option to include a message with a short description of the changes being committed. The file has now been added to the local branch. This means that the file is only visible locally to you. To allow other developers to see the changes, you need to push the file to the remote repository. You can do that by running the git push command and referencing the new file. The changes are not pushed to the remote repository on GitHub. Your next action is to get it reviewed as part of a pull request, but more about that later. And that brings us to the end of this video. Now you know what a workflow is and how a feature workflow works. Well done. Previously, you learned about the hidden folder called .git that is located in each project. You know that this folder is responsible for keeping track of all changes across a project. How does Git know what branch you're currently on? Let me explain. It keeps a special pointer called head, which is one of the files inside the .git folder. This file refers to the current commit you are viewing. You will now learn how to identify the current commit you are working on. First, open the .git folder on your terminal. Type cd.git and press enter. Next, type cat head and press enter. In Git, we only work on a single branch at a time. This file also exists inside the .git folder under the refs/heads path. Let me show you. Type cd.git and press enter. Next, type cat/refs/heads/main. Press enter. After you entered this command, a single hashed ID appears. This single hashed ID is a reference for the current commit. Let's switch branches to see how the head is moved to point to a new branch. Type git checkout testing and press enter. Next, type git branch and press enter again. This moves the head to point to the testing branch. Let me explain how this happens by using a diagram. We have two branches, the main and testing branch. When you run the checkout command, it moves the head to now point to the testing branch. To check the contents of the head file inside the .git folder, you have to enter the less command. Type less.git/head and press enter. You can now verify that the head has changed from main to testing. Now I will demonstrate how Git head works with a simple example. So I am here in the terminal. To see what branch I am in, I am running git branch. When pressing the enter key, I can see I'm on the main branch. To confirm that, I run the cat.git/head command and press enter. That brings me back to the reference to where it actually points to, namely refs/heads/main. In this case, you can see the reference is pointing to the head's main. If I change my branch to feature testing branches above, I use the git checkout command git checkout feature/testing branches. I then go to my head file inside the Git folder by typing cat.git/head. The ref is now pointing to the feature testing branches, namely refs/head/feature/testing branches. Notice that my branch is up to date with origin/feature/testing branches. I'll go back into my main branch by typing git checkout main and then check the reference file inside the main directory using the cat command again, cat.git/refs/heads/main. When I press enter, I get a hash ID. This is a reference to the latest commits of that working directory. I can show you that if you make a change to any files within this directory, that this ID will then change after a commit has happened. So let's do a simple update to the README file. You can do this with any editor such as VS Code, or I can also do this by executing the vim command. Type vim readme.md and press enter. When inside the README file, add some text. In this case, add minor update to your my first repo line and save it. Then check the ID again just to verify. Type cat.git/refs/heads/main and enter. If you would like to learn more about Vim, there is a link to an additional reading at the end of this lesson. The ID should be the same because we haven't committed anything. We've just made a change to run the cat command. Therefore, the ID is exactly the same as before. If I do a git status, it is telling me that I have modified the README file. On the screen, the words modified readme.md displays in red. I'll now add that file. The shorthand to add a single file is git add space dot. Type the command and press the enter key. I am then going to do a commit. Type git commit -M for message by adding minor update to the command line and press enter. The data confirms that one file changed, there was one insertion and one deletion. I am using the cat command to verify what is in the reference file by typing cat.git/refs/heads/main. Press the enter key to confirm that the ID is changed. Originally, the ID started with a 8B55, and now it starts with 9C90. Whenever a change occurs for a commit, this ID will then update to be the latest commit for that working directory. And that's Git head. You now know what the purpose of head is. You can also change the head to point to a different branch. Great novels are rarely written in one go and usually endure several drafts before the author is satisfied with the outcome. Of course, there's always the possibility that an idea from an earlier draft will sound good again later. But without a system of organization, it can be difficult to find where this idea is located. Programming is no different, and sometimes you need to revisit old code. In this video, I'll guide you through how to use git diff to compare changes across your files, branches, and commits. You probably know that the git status command tells you which of your files have been changed. The git diff command goes a step further and tells you what exactly these changes are. When used together, you can think of them as a file system. Git status tells you the file names, but to open the file and see the contents, you'll need to use git diff. To demonstrate, let's say you have a text file named cities.txt, which contains the names of cities you visited. You've been updating the list during a tour of South America, but upon returning home, you've lost track of what you've recorded. So, what can you do? Well, this is a situation where git diff makes itself useful. Git diff will compare the previous version of the file with your current one to find any differences. It will then tell you specifically what content has been removed as well as what content has been added to the file. In your cities.txt file, git diff would tell you that you removed one city that was in version A and then added a new one that appears in version B. So, now that you've had a basic explanation, let's go into a more detailed example. In this video, I'll show you how you can use git diff. Diff is used to make comparisons against files on your local repository. It can also be used against commits and against branches. I'll start with a simple example. When I go into my local repository, I'll find a file called readme that I'd like to update slightly. You can do this with any editor, such as VS Code. I can also do this by executing the vim command to enter the file for editing, remove a few words, and then save it. If you would like to learn more about vim, there is a link to an additional reading at the end of this lesson. Next, I'm going to use the git diff tool to compare the updated file against the head. Because we haven't yet completed a commit, it's not available for a comparison against another commit. So I'll input git diff, pass in the head as the first option, and then finally the file name. This then returns an output showing the changes that occurred in each file. Here, the line starting with a minus symbol represents what it originally was, while the line with a plus symbol shows what it is now. So my example tells me that the words minor update have been removed. In addition to individual files, you can also make comparisons against previous commits. I'll start by using the git log command to display my history of commits, and I'll also use the pretty flag here so that each one is shown in one line. The pretty flag is used by developers to make the output more readable. Each commit has its own ID code, so I'll perform a git diff command on the codes from the most recent commit and from the very first one. Git will go through all the files, note all the changes that have occurred, and return the differentiation between the two. Finally, one more way of using git diff that I'll show you is how to use it for making comparisons against branches. If I perform the command git branch, it will display all the branches that are available in the repository. I can then use the git diff command to pass in my main branch, followed by my feature branch as the second option. And once again, this will display all the changes that have occurred between the two. This shows that my feature branch has the previous update, while the main branch has the most recent one. So these are a few examples of how you can use git diff. In this video, you learned how to use git diff command to keep track of changes across your files, branches, and commits. This tool can help you to stay on top of updates and avoid mistakes or overlap. See you next time. One day you might be overseeing a big team of developers. Can you imagine how complex it gets to keep track of everyone's changes and updates to files? Fortunately, Git has a very helpful command for keeping track of who did what and when. It's called git blame. In this video, you will learn about git blame, and I will demonstrate how it is used with a few examples. One of the core functions of Git is its ability to track and record the full history of changes for every file in the repository. In order to view and verify those changes, Git provides a set of tools to allow users to step through the history and view the edits made to each file. The git blame command is used to look at changes of a specific file and show the dates, times, and users who made the changes. By now, you should know how to use commands like git log to see the changes made. I will now use the feature.js file to demonstrate how git blame works. Let's get started with the git blame command. To run the git blame command, type git blame and the name of the file. In this case, feature.js. After pressing enter, Git returns a list of all changes on the file. To understand what is happening, let's break down the blame messages and go through it line by line. Firstly, let me guide you through the format of each line. Every line will start with the ID, and then the author, the date, and time when the change was made, and the exact line number where the change occurred. Then the actual change or content is also returned. The ID is a reference ID of the commit. The same ID might appear in several lines. This happens when a single commit has been made by the same developer. The author is the person who created the commit. The timestamp is the date and time when the changes were committed. Line number represents the location in the file or the exact line where the changes were made. The content is the code that was added to the file. Now that you know the meaning of each line in the blame output, let's explore a real example. In this example, you will check who made changes, when the changes were made, and also what changes were added. For the purposes of demonstration, I will be using a public repository called mkdocs. mkdocs has various different contributions from many different developers, so it's a good way to see a log file from all the changes of specific files. To begin, I will check inside the directory by using the ls command and passing in -l to get a list of all the available files, and I'll just pick one. The file I will use is called setup.py, which is a Python file. So in order to examine the different changes to that file, I create a command called git blame and then pass in the name of the file, setup.py, and press enter. The output will list all the changes made by all the different developers. It will also indicate the timestamps and line numbers as well as the actual changes that were made. Now I will talk you through the output. Starting from the left of the list is what's called a #-id. It just represents the commit of when a change occurred. Then the name of the developer who worked on the file is listed, and then you have the timestamp when the change went in. Next is the line number in sequential order. And finally, the actual change that was implemented. I can scroll through the list of changes all the way to the end of the file, depending on the size of the file or whatever number of lines it has. If I want to exit out, I click on Q. This will clear the screen to make it easier. Take note that git blame on its own and by passing the file name will list the entire file. In a lot of cases, you will work with very large files, and then you'll need a way to abbreviate the output or chop it down based on, say, line numbers. Fortunately, git blame offers a flag for that. To do this, I type git blame and pass in the flag of -l and specify the starting line number and the end line number. I will type 5,15, then pass in the file name again, setup.py, and press enter. This time, a smaller subset is returned that only starts at line 5 and ends on line 15. The output indicates that there are 4 different changes made by 5 different developers across these lines. Let me give you a few more tips around git blame now. Firstly, you can change the format of how the list is displayed. This is similar to what you can do with the ls command on the Unix commands. You can also pass in a -l flag for changing the output itself. So again, let's run git blame -l followed by the file name and press enter. This time, there are a few changes to the output. For instance, the #-id is in its full-length form. It's not in the shortened version. The output is now a bit more detailed. You can also control if you want to show email addresses or change the date format. These are the examples of the various things that you can do. Secondly, another aspect of using git blame is that you can see detailed changes or the actual commit changes of a specific #-id. To do that, I will run a git blame command on that file again in order to copy a #-id from the output. Now I will use that with a git log -p and pass in the #-id and press enter. This gives you the actual change that occurred. Just to clarify, git blame will display to you the point where it was changed. Git log will give you the detail of the change. I always use the two in conjunction to get more details about what changes occurred. You've reached the final video in this lesson on creating a repository with forking and the end of the Git module. Let's take a few moments to recap on what you've learned. You now know how to explain the principles of Git and utilize a GitHub repository, including branching and merging code. Perform a local install of Git on a Windows operating system. Create a new repository in GitHub and clone it to a local machine. Explain the fundamentals of Git and outline the Git workflow, and identify the differences between remote and local repositories in GitHub. Explain what the git add and commit commands do and describe how they work. Push content to remote repositories with git push and retrieve content from remote servers using git pull. Keep lines in your workflow clear and stable with the use of branches. And explain how head is used in Git to identify the current branch you're working on. Compare changes across files, commits, and branches using diff commands. Examine changes to files and identify their author with the use of blame commands. And create a repository with the use of forking. You're now familiar with Git, GitHub, and creating repositories with forking. Great work! In this course, you were introduced to the practice of version control. Let's do a brief recap of what you covered. In the first module, you learned about how different version control systems and effective software development workflows enable modern software developers to collaborate across the world without messing up each other's code. You gained knowledge about the history of version control and know how version control or subversion is used to bring order to the chaos of massive software projects that have the potential for mistakes and bugs. Next, you learned more about the various systems, tools, and methodologies that are leveraged by software developers to collaborate successfully as part of a global team. You explored how to resolve conflicts in Git and that version control plays a crucial part in the development of software. You then moved on to investigate the difference between staging and production, and that a staging environment should mimic your production environment. In Module 2, you learned about how to use the command line to execute commands in Linux. You were introduced to what the command line is and learned to use commands that traverse, create, rename, and delete files on your hard drive. Then you learned how easy it is to use piping and redirection to create powerful workflows that will automate your work, saving you time and effort. Finally, you explored the command line further, discovering standard input-output streams, flags that can be used to change the behavior of a command, and grep. In Module 3, you developed a strong conceptual understanding of the Git technology and how it is used in software development projects to manage team files. First, you learned how to install Git on various operating systems, and then how to connect to GitHub via HTTPS and SSH before creating a GitHub account. Next, you gained a practical understanding of how Git works, including creating and cloning a repository, add, commit, push, and pull. You also explored how to use a repository and some concepts associated with workflows, such as branches, blame, and forking. Finally, the ungraded lab is an opportunity to complete a practical version control exercise by forking a repository, creating a branch, and committing a change. It also includes staging your changes and opening a pull request with the source repo. Well done on completing this recap. Now it's time to put into practice all that you've learned. Are you ready to proceed? Good luck. Congratulations on completing the Introduction to Version Control course. You've worked hard to get here and developed a lot of new skills during the course. You should now have a great foundation in the different version control systems and how to create an effective software development workflow. And you've also demonstrated your skill set by managing a project on GitHub for the graded assessment. Following completion of this course, you are now able to implement version control systems, navigate and configure documents, files, and directories using the command line, create and manage a GitHub repository, and manage code revisions. The key skills measured in the labs showed your ability to determine the current working directory and make and change directories and files using the command line, create, clone, commit, and push to a repository, create a repository with forking, and manage a project on GitHub. So, what are the next steps? You've established a good foundation so far, but there's always more to learn. Whether you're just starting out as a technical professional or student, this project will enable you to prove your knowledge and ability. Your project experience shows employers that you are self-driven and innovative. It also speaks volumes about you as an individual and your drive to continue your educational progress. Once you've completed all the courses in this professional certificate, you'll receive Coursera certification. Certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Congratulations once again on reaching the end of this course. It's been a voyage of discovery. Best of luck, and do continue to pursue your own learning objectives to their final goal.
The digital space is a world of connection and opportunity. But take this moment, for example.
The web has made it possible for you to enroll in this program, where you'll learn from the personal stories of developers at Meta.
By the time you have completed this professional certificate, you can become a creator of digital experiences. Connection is evolving, and so are you.
You might not have a background in tech at all, and that's okay. Even if you have no experience, this program can get you job ready within a single year.
So how can this professional certificate prepare you for a job at an organization like Meta?
The Database Engineer Professional Certificate will help you build job-ready skills for a database engineering role while earning a credential from Meta.
From Meta engineers, you will learn about how they collaborate to create and test high-performance databases.
You'll also discuss interesting topics with other aspiring database engineers
and complete a range of coding exercises to improve your skills.
It's important to complete all the courses in this certificate in order, as each course will build on your skills.
Although we have a recommended schedule for each course, the program is entirely self-paced, which means your time is your own to manage.
As you make your way through the courses in this certificate,
you'll learn how to model and structure a database according to best practice and create, manage and manipulate data using SQL, one of the most widely used languages for working with databases.
You'll also learn how to use the Django web framework to connect the front end of a web application to your database.
For your final project, you will create a functional relational database designed and developed with best practice architecture
to showcase as part of your portfolio during your job search.
You'll also be ready to collaborate with other developers, as you will have learned to use Git and Github for version control.
In the final course, you will prepare for the coding interview. You'll practice your interview skills, refine your resume, and tackle some common coding challenges that typically form part of technical job interviews.
Once you complete the program, you'll get access to the Meta Career Program's job board,
a job search platform that connects you with over 200 employers who've committed to sourcing talent through Meta's certificate programs.
Who knows where you will end up? Whatever the future of connection looks like, you'll be part of its creation. Let's get started.
Welcome to the next course in database engineering. The focus of this course is on database structures and management with MySQL. Let's take a moment to review some of the new skills that you'll gain in these modules. In the first module of this course, you'll learn how to filter data using logical operators, perform joins on tables and make use of aliases, group data using the group by and having clauses, and deploy the any and all operators in a database. In the second module, you'll explore key concepts around the topics of updating databases and working with views. For example, you'll learn how to insert and update data using the MySQL replace statement, make use of constraints in a MySQL database, and change the structure of tables using alter and copy table statements. You'll also learn how to use subqueries and how to combine them with comparison operators, and you'll discover how to create virtual tables with a MySQL create view statement. In Module 3, you'll explore functions and MySQL stored procedures. By the end of this module, you should know how to make use of common MySQL functions like numeric, string, and date functions, deploy comparison and control flow functions, and work with stored procedures. During these modules, you'll encounter activities to test your knowledge and skills. You'll receive the opportunity to demonstrate some of this learning along with your practical database skill set in the lab project. And you'll also demonstrate your knowledge of these topics in a graded assessment. So, what are you waiting for? Let's get started.
You know what's amazing is databases are present in our everyday interactions with these amazing digital experiences we have. So whether it's looking up somebody's phone number on your smartphone, or whether you're looking for your next movie to stream, or paying for your groceries at the checkout counter and scanning your groceries, you're interacting with databases every step along the way. My name is Daniel Bloomfield-Ramajan. I'm a software engineer working out of our Meta DC office. And I've worked in security, in community integrity, and currently in the privacy space. As your use of data for an application grows, you increasingly need to be able to find that information quickly, need to manage it, delete it, update that information quickly. And so without a database management system, you're either left to kind of create those structures on your own, and you may be successful at first, but as the scale of what you're trying to do grows, it becomes increasingly harder. So these database management systems, something like MySQL, gives you that almost for free. You have all of that service and functionality already available to you, which frees you up to then focus on, let's say, the business problems that you're trying to solve, like the user problems you're trying to solve, without having to necessarily worry about everything that's powering the data management layer. MySQL is a relational database management system. So it allows you to store data, retrieve that data, and manage it, delete, and update it for a variety of uses. So it can be applied to many different application types. So everything from the motor vehicle administration, managing my driving records, to something like the likes and shares I get on my Facebook app. All of that can be managed in a database, and MySQL is one of the most popular databases we have in the world. So MySQL allows you to automate a lot of things like making backups and setting up failovers, updating schemas. It allows you to handle very high concurrency requests. So if you've got web applications or needs where there's a lot of requests coming in, it's particularly good at that. It also has this fantastic community, which means you have forums where you can reach out for help. You've got great people that can provide you support, documentation, and it's open source, which means you can always take a look at the code and you can actually make requests to the creators and contributors to that software. We at Meta use MySQL to store and retrieve the social graph, the interactions, the shares, the likes. And so I know that when my friends used the Facebook app and saw my picture last week, that I can visualize the thousands of requests being made across our fleet of MySQL servers to retrieve that information and display it to them and to me. So MySQL is powering all these amazing digital experiences for us. We use MySQL because it provides automation, and that means a small group of engineers can manage a very large fleet of servers and can do things like these backups and failovers and can automate all those functions. And it's also very good for these high transactional requests. So a lot of what we do at Meta are these short bursts of very precise requests for insertion of data, deletion of data, lookup of data, and MySQL excels at that. It's incredibly rewarding to learn about databases, and it can be challenging not only to code, but to learn database management and configuration, data structures. But the rewards are that you are empowered to build incredible experiences, incredible solutions to real user problems, or you can build applications that will serve, for entertainment. There's a variety of uses for software that are all going to be powered by well-organized, structured data. So hang in there, go through this lesson, learn, because you will be standing on the shoulders of giants with all this data layer that will be readily available for you, and you will propel you to take it to the next level. I hope you will have learned that data is at the heart of every application, and that structuring that data and managing the data effectively such that you can retrieve the data quickly, you can process it effectively, and you can display the right information to the user is super important. And the knowledge you have of database management will help you not only structure that data, but you will influence everything else that comes after it, the processing, the APIs, and even something like the user interface. So you have a huge opportunity to influence software development projects all the way from the back end to the front end experience by your database management skills and data skills. I hope that you get a chance to apply this knowledge to a future role, and I wish you the best in your next endeavor.
You might already be familiar with using a where clause and a condition to filter data in a database table. But what if you need to specify multiple conditions in a where clause? You can use logical operators to specify multiple conditions or rules. So when the data is filtered, all specified conditions are applied. By the end of this video, you'll be able to identify the logical and or operators and explain how they're used to combine conditions, and develop a working familiarity with the logical not operator and outline how it is used with data filtering. Before you explore how to filter data using multiple conditions, let's take a moment to recap how the where clause works. It's important that you understand it before working with logical operators. When filtering data in a database table, you can add a where clause to your SQL select statement to specify a condition or rule for how the data should be filtered. A select statement begins with the select keyword or command. You must then specify the data or columns to be queried. You then add the from keyword, followed by the table you need to query. Finally, you must add a where clause and a condition. But as you've just learned, it's also possible to specify multiple conditions in the where clause. These conditions are specified using logical operators. Let's begin by exploring the and or operators. The and operator is used with the where clause to filter data. It checks if all combined conditions meet the value of true, and the or operator checks if any of the combined conditions meet the value of true. Let's take a moment to explore the syntax for each of these logical operators. Write the select statement as usual. However, in this instance, multiple conditions are placed after the where clause and combined using the and operator. The statement checks if all these conditions yield a value of true for a record. If so, then that record is included in the result set. With the or operator, a record is included in the result set if any of the conditions separated by or is true. That is, if at least one condition yields a true value for a record in the table, then that record is included in the query result set. Next, let's look at the not logical operator. The not operator works slightly differently to other operators. It selects a result to be included in the query result set only if the conditions specified in the where clause are not true. In other words, it reverses or negates the results that are returned once the condition is evaluated. To use the not operator, you just type not after the where clause, followed by the required condition. Let's take a few minutes to find out how these operators are used over at Lucky Shrub. Lucky Shrub are reviewing their accounts and need to generate specific details on their customers and the purchases they've made. They can complete this task by filtering data with the use of logical operators. In Lucky Shrub's database is a table called Customer Purchases. This table contains the data Lucky Shrub needs to complete their queries. The data is divided into the following 4 columns: Customer ID, customer names, customer locations, and purchases. The value of each customer's individual purchase. Lucky Shrub first need to identify customers from the location Gila County who have made purchases of over $2,000. This requires two search conditions. The first is customers who are from Gila County, and the second is customers who have made purchases of over $2,000. You can retrieve these details by writing a basic select statement as follows. Begin with select all from the table customer_purchases. Next, type the where clause, then the first condition as follows. Purchases column, the greater than operator, and the figure of 2,000. Then type the AND operator to include a second condition. This second condition targets the location column and uses an equal operator to return all results for Gila County. The AND operator here combines the two conditions. It ensures that both conditions are evaluated when filtering data from the table. So, your select statement is instructing SQL to select all records from the customer purchases table that satisfy the following criteria. Purchases greater than $2,000 and made by customers in the location of Gila County. For a record to be included in the result set, its purchases column must have a value greater than 2,000. If so, then the first condition yields a true value. In addition, the location column must have a value of Gila County. If this is the case, then the second condition also yields a value of true. And as you just learned, the AND operator here insists that the results of both conditions are combined. This is another instance which yields a value of true. So any records that match are included in the result. Any records in the table that do not yield the value of true for both conditions are omitted from the results. Your query is now ready to run. So press Enter to execute. The result set that this query returns contains two records. There are two customers from Gila County who've made purchases over $2,000, Benjamin Claus and Julie Marr. Now Lucky Shrub need to identify customers who are from Gila County or Santa Cruz County. The logical operator OR can be used to combine multiple conditions in the where clause, so it's perfectly suited to this task. For this query, you first need to generate a list of customers who are from either Gila County or Santa Cruz County. So the first step is to write the following select statement. Select all from customer purchases and then add the where clause. This where clause is then followed by the first condition, location equal to Gila County. Then insert the OR operator followed by the second condition, location equal to Santa Cruz County. You now have a where clause that uses the OR operator to combine the two conditions. For a record to be included in the result set, its location column must have a value of Gila County. If so, then it meets the first condition and yields a true value. Or the location column must have a value of Santa Cruz County. If this is the case, then the second condition yields a true value. The OR operator ensures that at least one of these conditions will yield a true value. Any matching records will be included in the result. A record in the table that does not yield a true value for either condition is omitted from the result. Press Enter to execute the query. In this case, the result returns 3 records or customers. Next, Lucky Shrub need to retrieve the details of customers who do not reside in Gila County or Santa Cruz County. They can perform this task using the NOT logical operator. It's used in a similar way in the where clause of a select statement. You can write the statement as before, but this time type a NOT operator after the where clause. Then list the conditions, location equal to Gila County or location equal to Santa Cruz County. In this query, the conditions have been enclosed in parentheses because there are multiple conditions. Parentheses are not required where you have just one condition. The NOT operator checks the records for values that do not yield a true value for the given conditions. In other words, records that do not yield a value of true for either of the listed locations. Press Enter to execute the query and generate the output. So, all the records that have a location value which is not Gila County or Santa Cruz County are included in the result. The remaining records are omitted. The output shows 4 records from the customer purchases table. If you find all these examples and operators a bit complicated, don't worry. You'll review detailed examples of how to use these operators in later videos in this course. For now, you should just be able to identify each of the operators and explain their syntax. You might already be familiar with filtering data using the AND or operators. But what if you need to perform more complex data filtering tasks, like filtering data based on a pattern? You can use more logical operators such as in, between, and like. By the end of this video, you'll be able to identify the in, between, and like logical operators and explain how they're used, and explain how wildcard characters can be used with logical operators to filter data. Let's begin with a review of the in, between, and like operators. The in operator lets you specify multiple values in the where clause. The between operator selects values within a given range. These values can be numbers, text, or dates. And the like operator is used to filter data based on pattern matching. Let's look at the syntax for the in operator. The in operator requires slightly different syntax than a typical select filter statement. After the where clause, you must type the column name to which the in operator is applied. You then need to add the in operator, and you must also include the set of values within parentheses. If the specified column's value of a record matches with any value in the set, then that record will be included in the query result set of the select statement. The in operator is like a shorthand for multiple OR conditions. You also can use not in to filter the opposite results of those you receive from the in operator. Next, let's review the between operator. For the between operator, you must also specify the column name after the where clause. The between operator is then applied along with the two required values. These two values mark the boundary of a range. In other words, they're the beginning and ending values of the range. The operator then selects values within this given range. The values that can be used with the between operator include numbers, text, and dates. If the specified column's value of a record falls within the value range specified here, that record will be included in the query result set of the select statement. Finally, let's look at the like operator. The like operator is used to filter data based on pattern matching. The operator is placed after the where clause and specified column name. A pattern to be matched against the column data is then added. This pattern can be written using what are referred to as wildcard characters. The first of these is the %sign, which represents 0, 1, or multiple characters. The second is the underscore sign, which represents one single character. For example, a pattern could be written as G __ %sign within a pair of single quotes. As you've just discovered, each underscore represents one single character, while the %sign is 0, 1, or more characters. So this pattern searches for values that start with the letter G and are at least 3 characters in length. If the specified column's value of a record matches the given pattern, that record will be included in the query result set of the select statement. Let's look at a demonstration of these operators in the Lucky Shrub database. Lucky Shrub are performing a review of their accounts. They need to generate specific details on their customers and the purchases they've made. They can complete this task by filtering data with the use of the in, between, and like logical operators. In Lucky Shrub's database is a table called Customer Purchases. This table contains the data Lucky Shrub need to complete their queries. The data is divided into the following 4 columns: Customer ID, Customer Names, Customer Locations, and Purchases, the value of each customer's individual purchase. First, Lucky Shrub need to use the MySQL in operator in the where clause to identify customers from the location Gila County who've made purchases of over $2,000. You might already be familiar with filtering data using the OR operator. The in operator is like a form of shorthand for multiple OR conditions. You can get the same result as the OR example by using the in operator. To extract the required data using the in operator, write a basic select statement as follows. Begin with select all data from the table Customer Purchases. Next, type the where clause, then the first condition as follows. Purchases column, the in operator, and the figure of 2,000. Then, within parentheses, specify the set of values separated by a comma, Gila County and Santa Cruz County. When run, this query returns 3 records or customers. These are the same results as the OR operator returns. Now let's check out how the MySQL between operator functions in the where clause. In this example, Lucky Shrub need the details of customers whose purchases are in the range of $1,000 and $2,000. Write the select statement as before. Then add the where clause. The where clause is followed by the filter column, which is purchases. Then add the between operator and give the value range. The range begins with the value 1,000 followed by and, then ends with the value 2,000. The between operator filters out the records that have a purchase value between $1,000 and $2,000, including the beginning and end values. In this case, the between operator is a quicker and easier way to filter out the records that have a purchases value greater than or equal to $1,000 and less than or equal to $2,000. Finally, let's see how Lucky Shrub make use of the MySQL like operator. The like operator is used for pattern matching. When used in a where clause, it searches a column for the given pattern. This means that it filters out data from the table based on the pattern. It's often used in conjunction with wildcards for single or multiple characters. Let's demonstrate an example using the pattern on the location column. You can filter out the records that have a location value that matches the pattern. Lucky Shrub's pattern must be set to find any values that start with G and are at least 3 characters in length. First, write the select statement just as you've done before. Then add the where clause followed by the name of the filter column, location. Finally, add the like operator followed by the pattern, which in this example is G, followed by 2 underscore characters and a percentage symbol. Press Enter to execute the query. The output that's generated contains 3 values that start with G and are at least 3 characters in length. Any values that don't match the pattern have been omitted from the table. Lucky Shrub have completed their data filtering tasks and returned all the required results from their database. You should now be able to combine conditions and filter data using the in, between, and like logical operators. Great work. Little Lemon Restaurants has run into some problems with their database. Some of the table and column names in the database are too long, which is causing issues with the output of queries. They need to find a way to generate results that are simpler to use, read, and understand. Fortunately, they can solve these issues with MySQL aliases. Over the next few minutes, you'll discover how Little Lemon can make use of MySQL aliases, and by the end of this video, you'll be able to demonstrate an understanding of the concept of an alias in a database, identify examples of situations in which it is beneficial to use aliases, and demonstrate the use of alias in MySQL queries. But first, you might be wondering, what is an alias in the context of SQL? SQL aliases are used to provide database columns and tables with temporary names. These temporary names make it simpler to use, read, and understand the output of the database. For example, Little Lemon can use aliases to shorten the names of tables and columns in their database. There are 3 common situations in which it's useful to consider an alias. An alias can be used to rename a table or column whose original name is too long or technical. It can be used with a concatenation function to combine an output into one column instead of 2. And you can also use an alias to create distinct table names when dealing with multiple tables. However, it's important to bear in mind that the syntax for creating and using an alias can change depending on which of these issues you're attempting to resolve. Let's take a few minutes to review an example of the syntax for each scenario, beginning with renaming tables. To rename a table, you need to use a select statement which begins with the select keyword. Then type the original column name followed by the alias. Both must be separated by the as keyword. The as keyword creates the alias. You can also include other columns in the table, with each separated by a comma. Then write the from keyword followed by the table name. If your table requires multiple aliases, then write out each column name and use the as keyword for each column you need to create an alias for. For example, in their client orders table, Little Lemon can use an alias to rename lengthy columns like client order information to just orders. Next, let's review the syntax for a concatenation function that combines an output into one column instead of 2. The select command is used to retrieve data. This is followed by the concat function, which concatenates or combines the information extracted from the column names placed in parentheses. These names must be separated by commas and a pair of double quotation marks. The quotation marks split the output by creating an empty space between the concatenated values. The as keyword is then added, followed by the name or alias you want to assign to the new concatenated column. And the from keyword specifies the table SQL must extract the data from. Little Lemon can use a concatenation function to combine the values contained in the first and last name columns of their client details table. These values are then placed in a new concatenated column called client names. Finally, let's explore the syntax for querying multiple tables. The first thing to note when querying multiple tables is that you can use a one-character alias to represent each table. For example, if you're querying two different tables, then you can use X for table 1 and Y for table 2. So the syntax then begins with a select command followed by the tables and columns to be queried. You can query columns using dot notation, such as x.column1 to query table 1 column 1 or y.column 2 for table 2 column 2. Next, add the from keyword. Then type the original name of each table alongside its alias with both separated by the as keyword. Finally, add a where clause and conditions as required. For example, perhaps you're querying prices in an online store database and want to return a list of items that are less than $12 for table 1 and $5 for table 2. Those are the three main instances in which MySQL alias can be used along with their related syntax. Now that you're familiar with the concept of MySQL alias, let's see if you can help Little Lemon with their databases. Little Lemon Restaurant has a table in their database called Food Orders Delivery Status that keeps track of food orders. The table has two columns called Date Food Order Placed with Supplier and Date Food Order Received from Supplier. However, these column names are too long and complex, so they need to be simplified to make the database more efficient. You can use aliases to simplify the output so that the column names are easier to read and understand when queried. Begin with a select statement and target the order ID column. Then rename the Date Food Order Placed with Supplier column as Date Order Placed. And rename the Date Food Order Received from Supplier column as Date Order Received. Notice that there are double quotation marks used for order date received because the alias name contains a space. In other instances, you can declare the alias without the use of quotation marks. Finally, type a from keyword followed by the name of the table. Then click Enter to execute the query. The output now shows the alias names instead of the original column names, which makes it much easier for Little Lemon to track food orders. However, you can make this table even more efficient. For instance, you could concatenate order ID and order status into one column instead of two. As you learned earlier, you can use a SQL alias with functions. Write the statement as follows. Begin with a select command and then the concat function. Then place the columns you want to concatenate in a pair of parentheses. You should also make sure that you include quotation marks to split the output. Next, use the as keyword to create the alias. In this instance, you can call the alias column order status. Then use the from keyword to identify the table. Finally, hit Enter to execute the query. The output shows the new order status column with the concatenated info. Finally, let's review how to work with multiple tables in the database. The restaurant has divided their menu into two tables called Starters and Main Courses. Both tables show the names of the meals available to order and their respective costs. As part of a new promotional campaign, Little Lemon want to promote starters that cost $7 or less and main courses that cost $15 or less. So, you need to query these tables and identify the meals that match these prices. In this instance, you can use a one-character alias of S to represent starters, and you can use C to represent main courses. Add these aliases into a select statement and use dot notation to request the name and cost of the meals. Then use the from keyword to identify the tables and the as keyword to create aliases for each one. Courses is C and starters are S. Finally, add a where clause and specify the condition. The condition returns all starters less than $7 and all main courses less than $15. Finally, press Enter to execute the query. SQL generates an output that shows all related costs in one table. All issues with Little Lemon's database have now been solved using MySQL aliases. Thanks to your assistance, Little Lemon's database is now more efficient to use, and they've identified some great meals to include in their next promotional campaign. With the skills you've gained from these tasks, you should now be able to demonstrate an understanding of the concept of an alias in a database, identify examples of situations in which it is beneficial to use aliases, and demonstrate the use of alias in MySQL queries. Great work! Lucky Shrub Gardening Centre need to gather information on their customers and the orders they've placed, but the records are held in 3 different tables. However, they can extract this information from their database using joins clause to join the required elements of these tables together. Over the next few minutes, you'll discover how the joins clause works, and by the end of this video, you'll be able to demonstrate an understanding of the join concept in a database and describe the main types of joins in MySQL. Let's take a closer look at the problem that Lucky Shrub has encountered with their database tables. Lucky Shrub needs to determine what products were ordered and which customers placed the orders. However, this information exists in 3 separate entities or tables: customers, orders, and products. So, how can Lucky Shrub extract records from 3 different tables? Before you can begin to assist Lucky Shrub, you first need to understand the concept of joins. The SQL join clause is used to query data based on a common column between 2 target tables. For example, the customers and orders tables both contain a customer ID column, and the product ID column is a common column between the orders and products tables. These common columns can be used to join these tables together and extract the required records. There are 4 types of join used to combine tables: an inner join, which extracts or selects records of data that have matching values in both tables, and a left join that extracts or selects records of data from the left table and all matching records from the right table. The right join, which extracts or selects records of data from the right table and matching records from the left table, and the self join, in which a table is joined with itself to retrieve info that exists in the same table. Let's begin with a review of the inner join. An inner join returns records of data that have matching values or columns in both the left and the right tables. This relationship between the 2 tables can be conceptualized in the format of a Venn diagram, as can all other joins. In terms of syntax, the left and right tables are identified as Table 1 and Table 2 respectively. Lucky Shrub need to identify the full names of all clients that placed orders with the business. To complete this query, they need the clients table and the orders table. They can then create an inner join using the client ID column that exists in both tables. The output result reveals the records of all clients who placed orders, and the client ID represents all records with matching IDs to be listed. The syntax of an inner join begins with a select statement which queries the left table and the column with the matching values. The from keyword is then added, along with the name of the left table. Next is the inner join clause, followed by the name of the right table. Finally, the on keyword is used to identify the inner join that the tables share. Next, let's move on to review the left join. The left join returns all common records in a similar way to the inner join. In addition, it returns all available records of the common column from the left table, even if there isn't a match in the right table. Lucky Shrub can use the left join table to extract data from the clients and orders tables using the client ID values. The join locates 4 matching records between the 2 tables and places them in the common area of the Venn diagram. The left join syntax begins with a select statement in which the required columns from Table 1 are identified. The as keyword is then used to create an alias for each column. The from keyword is used to identify the left table, which is the one that must be queried. And once again, the as keyword is used to create an alias for this table. The left join clause is then used to join Table 2 and assign an alias. Finally, the on keyword equates the matching columns between the 2 tables. Now let's review an example of the right join. The right join returns all records from the right and left tables, but with the right table as the main target table. For example, Lucky Shrub can use the right join to extract records of data from the orders and products table based on the product ID values. This lists all products from the products table joined with the matching related orders details in the left table. The right join syntax is very similar to the left join. The only difference is that the right join clause is used to extract records of data. Finally, there's the self join. A self join is a special case in which a table must be joined with itself. In other words, one table is treated as two in order to extract specific information from either the left, right, or inner join. In the case of Lucky Shrub, the business holds records of all staff members in a staff table. The table contains records on sales floor employees and line managers. Lucky Shrub can treat the table as two tables to determine who is a line manager and who is a sales floor employee. A self-join syntax is written as a select statement in which an alias is created for the common column in table 2. You've encountered a lot of information in this video, particularly in terms of syntax. Don't worry if it doesn't all make sense at this stage. In the videos that follow, you'll learn how to create each type of join in more detail. But for now, you should be able to demonstrate an understanding of the join concept in a database and describe the main types of joins in MySQL. Well done. Lucky Shrub Gardening Centre require information on orders recently made by their clients. This information is stored in two separate tables, the clients table and the orders table. But there must be a more efficient way to review this information that doesn't involve using two tables at the same time, right? Thankfully, Lucky Shrub can use the inner join clause to return records of data based on a common column with matching values in both tables. In this video, you'll help Lucky Shrub to complete this task. And by the end of this video, you'll be able to apply the inner join concept in MySQL and use SQL aliases to create temporary column names. As you're probably aware by now, databases normally have more than one table. In fact, database normalization rules dictate that related data should be held in separate tables. So let's begin with a quick review of the two tables. The clients table has 4 columns: client ID, full name, contact number, and address. And the orders table has 5 columns: order ID, client ID, product ID, quantity, and cost. The first task is to identify the full names of all clients who made orders. You can do this using the inner join clause in a SQL select statement. The statement begins with the select command. This is then followed by the column full name attached to the client's table, separated by a dot. This queries data from the full name column of the clients table. Then the from keyword is used to target the clients table. Next, the inner join clause creates a new row of data for each matching record. In other words, where the client ID in the client table matches the client ID in the orders table. And the equal operator ensures the matching condition must be met. Remember that it's important to specify the table name of each column when you are dealing with multiple tables in the same statement. This is especially important when the column name is used in more than one of the queried tables. For example, client ID exists in both the clients and the order tables. Press Enter to execute the query. The output results set lists the full names for all clients that have made orders. This example just extracts a list of names. But you can also query other information from both tables. For example, you can display the column names with more user-friendly labels if required. For instance, you can take the client ID, full name, and contact number columns from the client's table and create a join with the product ID, quantity, and total cost column from the orders table. You can do this with the following SQL statement. Start with a select command that selects the required columns from the client's table. Then use the as keyword after each column to create an alias. In other words, create a new name for each column. Then do the same for the required columns on the orders table. So, in this statement, each column is attached to the related table name. And the alias technique is used to create new names for each column. Click Enter to execute the query. The result set is a table with all required data related to the 4 matching clients' IDs: CL1, CL2, CL3, and CL4 as shown in the output table. In this video, you explored how to work with the inner join clause in MySQL to query data from 2 tables in the database. Also, you learned how to use an alias to create temporary column names that have more readable labels. Lucky Shrub can now review the data they need using a more efficient table thanks to the inner join clause. And you should now be able to apply the inner join concept in MySQL, and use SQL aliases to create temporary column names. Great work. Lucky Shrub need to review data on orders made by their clients. This data exists in two separate tables, clients and orders. Lucky Shrub can query data from both tables using the left and right join clauses in MySQL. These clauses will work because both tables share several closely connected columns. In this video, you'll help Lucky Shrub use the left and the right join clauses. And by the end of this video, you'll be able to demonstrate how to apply a left join and a right join in MySQL, and utilize aliases to create temporary columns and table names. Let's quickly review the two tables before creating the query. The clients table contains 4 columns: customer ID, full name, contact number, and address. And the orders table contains 5 columns: order ID, client ID, product ID, quantity, and cost. The first step is to create a query for the client ID and client name columns within the clients table, which is the left table. Then you must create a join with the following columns from the order table, the right table: order ID, quantity, and cost. You can use the left join clause in the SQL statement to complete this task. To start, use the select command to retrieve data, followed by the column client ID and full name attached to the client's table, separated by a dot. This syntax retrieves data from the 2 columns from the client's table. This data then joins the order ID, quantity, and cost columns from the orders table. As you're probably already aware, it's important to specify the table name of each column when dealing with multiple tables in the same statement. This is especially important when the column name is used in more than one of the query tables. For example, the client ID column exists in both the clients and orders tables. You can also use the SQL as keyword to create suitable aliases for the column names when displayed in the output result set. And you can use the as keyword to create aliases for the 2 tables as follows: C for clients and O for orders. This now means that instead of repeatedly typing clients to specify the column source table, you can just use C, and instead of using the word orders, you can write O. In this statement, the left join clause creates a new row of data for each matching record from the left table, the clients table. It does this even if there are no matching records in the orders table, which is the right table. For example, the clients with IDs CL5 and CL6 have yet to place any orders. This means that null values will be inserted for related columns from the right table. Finally, press Enter to execute the query. The output result table contains several null values for the clients with IDs of CL5 and CL6. This is because they have not yet made any orders. Next, let's create a similar query using the right join concept. You can use similar syntax to the previous query. Just replace the left keyword with the right keyword. In this statement, clients represents the left table and the orders represents the right table. The right join clause extracts data from both tables based on the client ID values, just like the previous example. Executing this query should return all requested information from the orders table, right table, joined by the requested information from the clients table, left table, based on the common column, client ID. So, press Enter to run the query and create the output. The output shows that the right join has returned all records from the right, or orders table, where a client has made an order. And it extracted the matching records from the left, or clients table, based on the client ID values. No null values were printed in the output result table. This is because all clients who made orders already exist in the clients table. Lucky Shrub now have the order and client information they need. And you should now be able to demonstrate how to apply a left join and a right join in MySQL, and utilize aliases to create temporary columns and table names. Good work! The Lucky Shrub database has a table called Employees, which lists all staff in the business. Some of these staff members are line managers, and other employees report to these line managers. Lucky Shrub needs to query the data from this table to determine which roles everyone is assigned. They can complete this task using the self-join clause, a special join case. This clause lets Lucky Shrub create a join between rows on the same table so that they can extract specific information. but the table must be treated as two tables to perform the required joins. Over the next few minutes, you'll help Lucky Shrub with this query, and by the end of this video, you'll be able to apply the self-join concept in MySQL and use an alias to provide same table with two different names. Let's begin by reviewing the employee table from the Lucky Shrub database. This is the table that stores the required information on employees and their line managers. The table includes 5 columns: employee ID, full name, job title, county, and line manager ID. In this table, the primary key employee ID values are also used in the line manager ID column to show who manages each employee in the Lucky Shrub firm. So, your main task is to list the full name of all line managers and the employees they manage. The full names of both sets of employees exist within the full name column. To complete this task, you can create the employees table as 2 identical tables. Then create an inner join to investigate each employee ID and match it with the line manager ID. Then extract the full name value and print it as either line manager or employee. And remember that the line managers are also employees. Before writing the query, remember that the self-join clause creates 2 tables from 1. In other words, know you're dealing with 2 tables in your query, not just 1. So let's begin with a SQL select statement. The statement uses E1 with an as keyword to declare an alias for the first employee table. And it also uses E2 with an as keyword to declare an alias for the second employee table. Remember that the employee table is the same in both cases. In addition, your statement queries the full name column from the E1 table, and it uses the as keyword to declare a suitable alias name of line manager from the left table. It then queries the full name column from the E2 table and uses the as keyword to declare an alias of employee from the right table. Name columns from both employee tables, but only once there's a match between the column values. In this instance, the condition is E1.employeeID equal to E2.linemanagerID. In other words, the condition matches the employee ID with the line manager ID. If it finds a value of true, then the full name is returned from the left table and displayed in the line manager column. And the full name is also returned and displayed as an employee from the right table. Press Enter to execute the query. The output results set links the line managers with the employees they manage. A quick summary of the output results set shows that the employees, Seamus and Greta, report to the line manager Simon. Simon reports to himself, and all other staff report to Seamus. Thanks to the self-join clause, Lucky Shrub have now determined which employee is in which role, and you should now be able to apply the self-join concept in MySQL and use alias to provide the same table with 2 different names. Good work. Lucky Shrub are filing their end-of-year tax returns and must provide information on all employees that they have hired over the last 12 months. There are several full-time employees in the business, and there are several part-time employees who were recently hired to help with the holiday season. But the records for the full-time and part-time employees are stored in separate tables. So how can Lucky Shrub combine these records into one table? They can use the MySQL union operator. Over the next few minutes, you'll discover how the union operator works, and by the end of this video, you'll be able to demonstrate an understanding of the union operator and explain how the union operator is used in MySQL. Let's begin with a definition of the union operator. The union operator is used to combine result sets from multiple statements in the same query. For example, you can use the union operator to join 2 select statements in order to combine their result sets and present as one table. So how does the union operator work? Let's look at the syntax and find out. You begin with a select statement, followed by the names of the columns that must be queried. The from keyword is then used to target the table in which the records are located. Next, you add a union operator, followed by a select statement that queries the required records from the second table. The union operator essentially creates a union between the 2 select statements. There are a few best practices that must be observed when creating SQL select statements with a union operator. Every select statement must have the same number of columns. All related columns have similar data types, and all related columns must have the same order in every select statement. But what about cases where the same value exists in both tables but appears only once in the combined set of results, like a name or a location? This happens because the union operator only returns distinct values from the targeted tables. To list all values, including duplicated data, you can use the all keyword. The use of the all keyword after the union operator ensures that all values remain, even duplicated ones. Let's explore a working example of the union operator. As you saw earlier, Lucky Shrub need to gather information on all employees that they have hired over the last 12 months. But the data for their full-time and part-time employees is stored in separate tables. Let's help them out. Lucky Shrub need to combine the records from two tables into one using the MySQL union operator. Both the full-time employees and part-time employees tables include the same four columns: employee ID, full name, contact number, and location. Lucky Shrub need to query the full names and addresses or locations of all employees. To combine the results from both tables, you can write two select statements that target the full name and location columns. One statement targets the full-time employees table, the other targets the part-time employees table. And a union operator is placed in between both statements to combine the results. Before executing these statements, you must check that each of these select statements includes the same number of columns. In addition, all columns must contain the same data types and must be placed in the same order in both statements. Finally, click Enter to execute the query. The output places the results of both select queries into the one table that contains two columns, full name and location. These columns hold all required records for all Lucky Shrub's part-time and full-time employees. However, Lucky Shrub has two employees named Julia Marr, one who works part-time and another who works full-time. But only one Julia Marr appears in the combined set of results. This is because the union operator only returns distinct values. Yet it's interpreted both instances of Julia Marr as a duplicated value. Fortunately, you can use the union operator to generate an output that contains both employees. Just write the same select statements once again with a union operator in between. But this time, place the all keyword after the union operator. As you learned earlier, the all keyword ensures that the output retains all results from both tables, even if they're duplicate values. Finally, click Enter to execute the query. The output is then generated on screen and it contains both instances of Julia Marr. Thanks to the union operator, Lucky Shrub now have all the information they need. And having helped them out, you should now be able to demonstrate an understanding of the union operator and explain how the union operator is used in MySQL. Well done. Lucky Shrub are reviewing recent customer orders in their database. They need to find a way to group records with similar values into one single record so that they can analyze the order data and produce summaries. The MySQL group by clause and its related aggregate functions are a great way for the company to complete this task. Over the next few minutes, you'll explore these concepts and use them to help Lucky Shrub produce summaries of their orders. And by the end of this video, you'll be able to group rows into subgroups using the MySQL group by clause and utilize the MySQL group by clause with SQL aggregate functions. So, before you begin helping Lucky Shrub, let's take a moment to find out what database developers mean by the term group by. The group by clause is used in SQL syntax to group rows in a table based on given columns into summary rows, also known as subgroups. To get a better understanding of this clause, let's look at the syntax. The syntax begins with a select statement followed by the name of the required column. The from clause is then added and targets the name of the table that holds the required column. Finally, there's the group by clause. After this clause, a list of column names are added. Each one is separated by a comma. These are the columns according to which the data must be grouped. If there's a where clause in your select statement, then the group by clause must be placed after this clause. And make sure that the columns listed in the select clause include the columns listed in the group by clause. Additionally, the group by clause is also frequently used with aggregate functions. An aggregate function can be used with the group by clause to perform one or more calculations and return a single value for each subgroup. You might be familiar with aggregate functions from previous videos, but if not, don't worry. Here's a quick recap of the main aggregate functions used by database developers with the group by clause. Sum, used to add values of given columns together and return a single value. Average, used to determine the average of column values. And max, which returns the maximum value of one or more given columns. The minimum aggregate function determines the minimum value of one or more given columns. And finally, count is used to count the number of instances that a given column value occurs. Let's review the syntax of the select statement when using the group by clause with an aggregate function. First, input a select statement, followed by a list of columns. You can then apply the aggregate function on any of these columns as required. For example, you can use the max aggregate function to calculate the maximum values in column 1. Just make sure to place the column in parentheses. Next, include the from clause and the name of the table that holds the columns. Finally, include the group by clause, followed by the names of the columns by which the data should be grouped. Make sure that these same columns are also present in the select column list. Lucky Shrub can make use of the group by syntax and aggregate functions to determine the total number of orders received by each department in the business. So, now that you've learned about the group by clause and aggregate functions, it's time to use your knowledge to help Lucky Shrub. Let's start with a quick review of the order table. The table contains 5 columns: order ID, department, order date, order quantity, and order total. There are multiple records with the same value for the department column. For example, there were 5 orders placed with the lawn care department. This means that there are a total of 5 records for the lawn care department. And there are more instances of multiple records with the same value for other departments, like decking. The best approach in this instance is for Lucky Shrub to group all these records so that they have just one row for each group or department. This will make it much easier to analyze the data and produce summaries. You can help them to reduce the departments into 5 groups or subgroups using the group by clause. First, write a select statement followed by department, the column name. Next, insert a from clause followed by orders, the table name. Then add the group by clause and the name of the column. Finally, run the statement to generate the output. In the output that's returned, all records in the department column have been reduced to 5 groups. 1 row or 1 single record for each department in the business. Now that you've simplified the table, you can use aggregate functions to analyze the data. Lucky Shrub's report must show the number of orders placed with each department. You can use the count function to produce this data. The syntax for this query is almost the same as the previous one you just performed. The key difference is that you must add the count function followed by the column name in parentheses after select department. This specifies which column holds the data, and the count function counts the occurrences of each department among the order records. Now just execute the query to generate the output. The output returns the 5 departments alongside the total number of orders placed with each. Next, let's find out how much money each department made from these orders. You can use the same syntax from the previous query, but this time use the sum aggregate function with the order total column. Then execute the query. The output returns the total sum of the selected numeric column. In other words, it adds the values in the order total column for each instance of each department. Now let's determine the minimum order quantities for each department. Once again, you can use the same syntax but with the min function targeting the order quantity column. Once you run the query, the output returns the smallest value of the column. Finally, Lucky Shrub also need the average order total for each department. So, write the syntax one last time. And in this instance, you can use the average aggregate function to query the order total column. The output that's returned shows the average value of the order total column. Thanks to your help, Lucky Shrub now have a summary that shows all the relevant data from the order table grouped together as required. Having proved your skills with Lucky Shrub, you should now be able to group rows into subgroups using the MySQL group by clause. And you should also know how to use the clause with SQL aggregate functions. Well done. At this stage of the course, you may be familiar with the group by clause, having helped Lucky Shrub group data from their customer orders in an earlier video. Lucky Shrub now need to filter this grouped data against a list of conditions to determine the best performing departments in the business. They can use the MySQL having clause to specify filter conditions that will generate this data. Look at the syntax. Over the next few minutes, you'll explore the having clause so that you can help Lucky Shrub. And by the end of this video, you'll be able to identify the MySQL having clause and explain its purpose, and demonstrate the use of the having clause to specify a filter condition for groups of rows. So, what is the having clause, and what does it add to your grouping data skill set? The having clause is used in a SQL statement to specify a filter condition for the group data that the group by clause generates. Let's take a moment to review the syntax for this clause, starting with a quick recap of the syntax of a typical SQL statement. As you learned in previous videos, the where clause is used in a select statement to specify one or more filter conditions, and you must place a where clause before the use of the group by clause. But the where clause can't be used to specify a filter condition for the group data that the group by clause generates. So how do you filter this data? You can add the having clause to your SQL statement. The having clause is added after the group by clause. The having clause is used to specify the filter condition that needs to be applied to your grouped data. The having clause evaluates the group filter condition against each group returned by the group by clause. If the result is true, the row is included in the result set. However, don't forget that if you omit the group by clause, then the having clause behaves just like the where clause. Let's take a quick look at a basic example of the having clause. Lucky Shrub can use the having clause with aggregate functions to determine which of their departments received orders of a certain dollar amount. Now it's time to use your new having clause knowledge to assist Lucky Shrub. As you discovered earlier, Lucky Shrub needs to filter their customer order data to check which departments met their monthly sales target of $2,275. Let's see if you can help them out. Let's begin with a review of the order table, which holds the required data. The table is divided into 5 columns: order ID, department, order date, order quantity, and order total. The first task is to identify which departments have order totals of a value greater than $2,275, so you're only concerned with the department and order total columns. You can determine the order total of each department by using a select statement with a group by clause. First, type the select clause, followed by the department column. You then need to include the sum aggregate function. Then place the order total column in parentheses. Next, add the from keyword, followed by the table name, which is orders. And finally, include the group by clause and target the department column. Run the statement to retrieve an output that shows the total sales figures for each of the 5 departments. Your next step is to filter this data to retrieve the results that have an order total value greater than $2,275. You can use the same statement as before, but this time add the having clause after the group by clause. The having clause is followed by a second instance of the sum aggregate function, which once again targets the order total column. Finally, use the greater than operator, followed by the figure 2275. This instructs the SQL statement to filter results greater than $2,275. This SQL statement is now ready to execute. However, you could make the syntax more efficient by using an alias. You should be familiar with the concept of an alias from previous lessons. You can use an alias called total in the select clause for the aggregate function. This alias can then be referred to in the having clause. This makes the condition concise and easier to read. Now you can execute the query. The output that's generated reveals 3 departments in Lucky Shrub which met this month's sales targets. Thanks to your assistance, Lucky Shrub has identified their best performing departments. You should now be able to identify the MySQL having clause and explain its purpose. And you should also be able to demonstrate the use of the having clause to specify a filter condition for groups of rows. You're making great progress with grouping data. Congratulations, you've reached the end of the first module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you received an introduction to the course in which you learned why MySQL is a key language for database engineers and how Meta uses MySQL. And you enhanced your knowledge by reviewing some key additional resources. In Lesson 2, you explored the topic of filtering data. You began the lesson by learning about the concepts of data filtering and logical operators. You then discovered how to use logical operators to filter your data sets. Next, you completed a reading in which you explored some real-world examples of data filtering. Finally, you reviewed some additional resources on the topics of data filtering and logical operators. You then progressed to Lesson 3, in which you learned the skills required to join tables. You first learned about the concept of aliases and how they can be used in MySQL. You then learned how to identify different types of joins and how to utilize them in your database tables. And you demonstrated these new skills in a lab environment. Next, you learned about the concept of a union operator and you demonstrated its use in your databases. Finally, you enhanced your knowledge of these topics by exploring additional reading materials. In the fourth and final lesson, you gained skills in grouping data. You began the lesson by learning how to identify and make use of the group by clause. You then learned how to use a having clause. Next, you completed a reading in which you learned how to utilize the MySQL any and all operators. Finally, you were challenged to demonstrate these new data grouping skills within a lab environment. You should now be able to filter data, join tables, and group data in a database using MySQL. Great work! I look forward to guiding you through the next module in which you'll discover how to update databases and work with views. Lucky Shrub Gardening Centre are hiring some new employees. Once these new employees have been hired, the company then needs to add their contact details to the database. Some of these contact details must also replace those of employees who've recently left. The replace command is the best method for Lucky Shrub to make these changes. In this video, you'll learn how the replace command can be used to help Lucky Shrub make these changes. And once you've helped Lucky Shrub, you'll then know how to explain how the replace command works in a MySQL database and demonstrate an understanding of the replace command by inserting or updating data. Let's begin with an overview of the replace command. The replace command is used to insert or update data in a table. However, unlike the standard insert and update commands, replace first checks for a duplicate key. If found, it deletes the existing record and replaces it with the new one. So now that you know what the replace command is used for, it's time to look at the syntax. But first, let's quickly recap the syntax for the insert command. Its similarity to the replace command should help you to understand the replace command better. You should be familiar with the insert into command from the previous course. With this command, you instruct SQL to insert new values into designated columns within your chosen table. The replace command works in much the same way. You type out your table name, column names, and values just like before. The only difference is that you must begin the statement with a replace command. You can also use the replace command with the set keyword. The set clause assigns a value for the selected column, but without using the where clause to specify the condition. In other words, it locates the required record of data, then replaces the values with the new set. If you don't specify a column value in the set clause, then the replace command uses a default value or sets the value to null. The replace command is a complicated concept, and its similarity to other commands can be confusing. So, to help you out further, let's take a moment to visualize how the replace command works. As you just learned, the replace command first checks if the new record of data already exists in the table by checking the primary or unique key of existing records. If there's no matching key, then replace works like a normal insert statement and adds the new data. If a matching key is found, then the command deletes the existing record and replaces it with the new one. Now that you're familiar with how the replace command works, take a few moments to see if you can help Lucky Shrub insert and replace new and existing employee records in their database. Lucky Shrub's employee contact records are stored in the Employees Contact Info table. The table consists of 3 columns: the employee ID, which is the primary key, the contact number, and email address columns. You need to insert a new record of data for the new employee Seamus Hogan with the following details: an ID equal to 1, a contact number, and an email address. You can add this data to the table using the standard insert command. Just type insert into followed by the table and column names. Then add the values to be inserted into each column: ID, contact number, and email address. Click enter to execute the query. The new employee record is added to the table. You can do the same with the replace command for the employee Thomas Erickson. Begin with the replace into command, followed by the table and column names to be updated. Then use the values keyword and list the values to be added to the table for Thomas. These values are his ID, contact number, and email address. Click Enter to execute the query. You can then use a select statement to check the table's records. The output shows that Thomas's contact details are now in the table, as are those of Seamus. However, Seamus has decided to leave Lucky Shrub to work for a rival gardening centre. So, you now need to replace his details with those of a new employee, Maria Carter. You can try updating the table using the insert command. Type an insert into statement just like before, and assign Maria an ID of 1 in your statement's values, alongside her contact number and email address, so that her records replace those of Seamus in the table. Then execute the query. But it looks like SQL can't execute this query. Instead of adding Maria's details to the table, it's returned an error message warning of a duplicate entry. This is because you're trying to assign Maria an ID of 1. But this ID is already assigned to Seamus as a primary key value. The primary key must always have a unique value in each row of the table. Otherwise, MySQL returns an error message. So, how can you replace Seamus's records with Maria's? Type the statement again, but this time use the replace command instead of insert. Then click Enter to execute the query. MySQL has accepted the statement with no errors. Let's query the table to make sure it contains Maria's records. Type a select statement and from keyword followed by the table name. Then click Enter to execute the query. The output returns the contact details for Maria and Thomas. MySQL has replaced Seamus's records just like you instructed. There's one more task to complete. Maria has recently changed her contact number, so the number also needs to be updated in the table. You can use the replace command to update the record of data. Type the replace command and the table name. Then use the set clause with Maria's employee ID of 1, followed by the new value, which is her contact number. But make sure that you set values for all columns. Otherwise, they'll be set to null or default values. Press Enter to execute the query. You can use a select statement to check the table and confirm that Maria's details were updated. Thanks to your efforts, Lucky Shrub's employee contact info is now up to date. You should now be able to explain how the replace command works and demonstrate the replace command by inserting or updating data. Great work. Little Lemon Restaurant have built 2 new tables in their database that allow customers to create accounts and register bookings. To make sure that these tables work as required, the restaurant has set up constraints which ensure that the tables only accept valid data. Over the next few minutes, you'll learn about the concept of constraints in MySQL by exploring how Little Lemon have made use of them in their database. And by the end of this lesson, you'll be able to identify the main types of constraints and explain how they function, and explain the MySQL on delete cascade and on update cascade options. Let's begin with an overview of what database engineers mean by the term constraints. When creating a table, you might decide that each column must hold a unique value in each row of the table, like a phone number. You can enforce this rule using the unique constraint, which prevents any violation of the rule whenever data is inserted or updated in your database. There are 3 main types of constraints in MySQL database which can be used to enforce these rules. Key constraints, which apply rules to key types. Domain constraints, used to govern the values that can be stored for a specific column. And referential integrity constraints, which establish rules for referential keys. Let's take a few moments to explore each of these 3 MySQL constraint types and discover how they're used by Little Lemon in their database. As you learned in the previous course, all tables include different types of keys, like primary keys and foreign keys. You can use constraints to establish rules for these keys. For example, the primary key constraint can be used to specify that 1 or more column values must always be unique, and they cannot accept a null value. Little Lemon's database contains a table called Customers. This table records key data on customer bookings using the primary key constraint. The table has 3 columns called Customer ID, Full Name, and Phone Number. Customer ID is defined as the primary key which returns data on the table's unique records. Thanks to the primary key constraint, this column's values must always be unique and it can never accept null value. In other words, every row in the column must hold a customer ID and all customer IDs must be unique. Next, let's look at domain constraints. As you learned earlier, These are special rules defined for values that can be stored for a certain column. Little Lemon's database contains a bookings table that records data on customer bookings. However, the restaurant can only facilitate a maximum of 8 guests per booking. So they enact the SQL check constraint on the number of guests column. This limits the value range that can be placed in the column, which means the table rejects any numeric values greater than 8. Finally, let's explore referential integrity constraints. You learned earlier that this type of constraint establishes rules for referential keys. But how exactly does this work? Basically, in a referential integrity constraint, there are 2 types of tables: a referencing table that holds a primary key and a referenced table that contains a foreign key. The value of the foreign key column that exists in the referencing table must always exist in the referenced table. Otherwise, a connection can't be established between the 2 tables. To understand this better, let's explore the example of the related tables in Little Lemon's database in the form of an entity relationship diagram. Little Lemon's database includes 2 related tables: the customers table that holds data on customers, and the bookings table that records information on customers' bookings with the restaurant. Each booking in the booking table must relate to a specific customer in the customers table. Otherwise, the restaurant can't identify who made the bookings. And this also means that each customer must already be registered in the customers table before they can make a booking in the bookings table. The customer ID column in the bookings table is defined as the foreign key. This is the attribute that joins the 2 tables together and establishes dependency between them. This means that if a row of data is altered or deleted in the customers table, then this action destroys the related row of data in the bookings table. In other words, deleting a row of data from the customers table violates the referential integrity rule. And this results in an error message from MySQL warning that the action directly impacts on the bookings table. So, how can you make the required changes to the bookings table without violating the referential integrity constraint? In this instance, you can use the onDelete cascade option. This option automatically deletes the related rows of data from the bookings table. And if you want to update a primary key value in the customers table, you can use the onUpdate cascade option to automatically update the related rows in the bookings table. You'll discover more about these options in a later video. You should now be able to identify the main types of constraints and explain how they function. And you should also be able to explain the MySQL onDelete cascade and onUpdate cascade options. Well done. Little Lemon Restaurant need to build 2 tables in their database that let customers create accounts and register bookings. They also need to apply constraints to the columns in these tables to ensure data consistency and integrity. Over the next few minutes, you'll help Little Lemon create these tables and apply the following common constraints: not null, unique, check, and foreign key. And by the end of this video, you'll be able to demonstrate how to apply these common constraints in a MySQL database table. The first table that must be created is customers, which records customer details. And the table requires the following constraints: the primary key constraint on the customer ID column, the not null constraint on the full name column, and a unique constraint on the phone number column to ensure that each customer has a unique number. So let's get started. Begin with the create table command and call the table customers. Then add a pair of parentheses. Within the parentheses, define the customer ID column as not null and as the primary key. This ensures that all IDs are unique in each row of the table and that the column does not accept a null or empty value. Next, add a full name column with the constraint not null. And assign a value of varchar with a character limit of 100. Then declare the phone number column as not null unique. This ensures that it only accepts a unique number for each customer. Finally, execute the statement. Now let's view the output by writing and executing the following statement: show columns from customers. This shows the customers table. The table contains all relevant constraints. The columns are defined with not null. 2 keys have been declared. The customer ID column is the primary key, and the phone number column only accepts unique values. The next task is to apply referential integrity. This ensures that each customer can make a booking in the restaurant and that each booking must be assigned to a specific customer. In other words, any customer ID that exists in the bookings table must also exist in the customers table. Otherwise, it won't be possible to identify who made the bookings. When creating the bookings table, it's important to focus on the referential integrity constraint and the check constraint to limit the number of guests to a maximum of 8. Begin with a create table command, followed by bookings and parentheses. In the parentheses, create the following columns: booking ID, booking date, table number, number of guests, and customer ID. All columns are defined as not null to ensure that each one must accept a value. All columns are also assigned the integer value, except bookings date, which is assigned a date value. The booking ID column is defined as the primary key. The number of guests column is defined with a check constraint that specifies it's not null. And use a smaller than or equal to operator so that it can only accept a maximum of 8 guests. Next, define the customer ID column with the foreign key constraint. Then use the references constraint so the foreign key references the customer ID column in the customers table. Now use onDelete and onUpdate cascade options to delete and automatically update the related rows of data in the bookings table. However, be aware that these actions depend on the update and delete operations taking place in the customers table. Click Enter to execute the statement. To display the table structure, type the following syntax: show columns from bookings. The output set result shows all columns are assigned the required constraints and values, and the customer ID column is mul. This means that it's not a unique key and multiple rows can have the same key value. This makes sense because each customer might make multiple bookings at the same or at different times. This code also joins the two tables and establishes dependencies between them. So if you change or delete the customer ID in the customers table, then you also update or delete the related record in the bookings table. You should now be able to apply different types of constraints in MySQL database to maintain data integrity and consistency. Great work. Lucky Shrub Gardening Centre has bought new heavy machinery, but it can only be operated by qualified employees. The business has a database table called Machinery that records the contact info of all qualified employees. However, the table has issues with its constraints, and it's also missing some key information. Lucky Shrub can fix these issues by making alterations to the table using the alter statement. Over the next few minutes, you'll learn about the alter statement and then use what you've learned to help Lucky Shrub alter their database. And by the end of this video, you'll be able to add, delete, and modify columns and constraints in an existing table. Let's begin with an overview of the alter statement and its syntax. You might often encounter tables in a database that contain missing columns or constraints, or their existing columns and constraints may need to be modified. You can use the alter table statement to make these changes. The alter table statement is often used alongside different SQL commands. Here's a quick overview of some common commands used with the alter table statement. The modify command is used to target specific columns and instruct SQL to make changes to them. The add command can be used to add a new column to a table, and the drop command can be used to drop or delete a column from a table. So, how are these commands used to make alterations to a table? The alter table statement begins with the alter and table clauses, followed by the name of the table to be altered. Next, insert a modify command, followed by the name of the column to be altered and the changes to be made. For example, you can change a column's data type and add a not null constraint. Then repeat the modify command for all other columns you want to alter. You can also alter a table by adding another column. Just use the add column command, followed by the name of the new column. To remove a column from a table, just use the drop command, followed by the name of the column you want to drop or delete. Now that you're familiar with the alter table statement, see if you can help Lucky Shrub make the required changes to their table. The tasks that Lucky Shrub need to complete are as follows. Set the employee ID column as the primary key, change the column constraints, and add a new column to the table. Let's get started. Lucky Shrub's machinery table includes 4 columns: employee ID, full name, phone number, and county. The table is missing a primary key. Fortunately, the employee ID column is the perfect candidate because all values are unique. To set this column as the primary key, you can write an alter table statement. Add the alter table clauses followed by the table name. Then write the modify command and the employee ID column name. Next, set the data type as varchar with a character limit of 10. Then set a not null value to ensure that the column always contains data. Finally, add the primary key value to the column. The employee ID column is now the table's primary key. It looks like each column in the table is also set to accept null values. This means that the table can contain empty fields or rows, which is poor practice in a database. So, to change all columns to not null, you can write another alter table statement. In fact, you can use the same statement as before and just add a new line for each column. For the full name and county columns, you can write the following syntax. Add a modify command, set the varchar data type to 100 and a value of not null. For the phone number column, you can write the same syntax but with integer and unique values. This means that the column now accepts unique numeric values only. This avoids any duplicate values. To view the new table structure, write the following statement. Show columns from machinery. This query's output shows that the employee ID is now set as the primary key, the phone number is a unique value, and all columns are set as not null. Now, your final task is to add a new column to the table. Lucky Shrubb's machinery can only be operated by employees aged 18 and over. So, the company needs to identify each employee's age and determine who is old enough to operate the machinery. There's currently no age column in the table, so you'll need to create it and add a constraint to ensure every new employee added to the table is at least 18 years old. You can write the statement as follows. Alter table followed by the machinery table name, then the add column command. Next, call the new column age and assign it an integer value. Finally, use the check function to limit the values in this column to at least 18 or more. Then click Enter to execute the query. To view the table's new structure, write Show columns from machinery. The output now displays the machinery table with a new age column. Thanks to your help, all the required changes have now been made to Lucky Shrubb's machinery table. You should now be able to use the alter table clause to add, delete, and modify columns and constraints in an existing table. Great work. Lucky Shrub are planning an overhaul of their database. In preparation, they want to create copies of their data to keep it safe during the rebuild. They can complete this task using the copy table process. Over the next few minutes, you'll learn about the process for copying a table and then help Lucky Shrub to copy tables in their database. And by the time you complete this video, you'll have learned how to copy data from an existing table to a new table within the same database, copy a table to a new location while ensuring it retains its constraints, and copy data from an existing table to a new table from a different database. These tasks are carried out using the create table syntax. However, before you explore this syntax, let's take a moment to review the process for copying tables. It's important that you're familiar with the process before you begin copying tables. You first need to identify the database and the table you want to copy the data from. Next, determine the columns you want to copy, either all columns or just some of them. Then, use the create table statement to build a new table with a relevant table name. And finally, use the select command to structure the new table by specifying the columns you want to copy data from. Now that you're familiar with the process steps, let's review the create table syntax. The copy table SQL statement begins with the create table command, followed by the name of your new table. Next, write the select command, then identify the columns to be copied. You can copy one, several, or all columns. Finally, use the from command, followed by the name of the existing table you want to copy. But what about copying a table between two different databases? Once again, begin with a create table command. However, in this instance, you must use dot notation to identify the names of the new database and table. Then use the select command to select the existing table's columns. And finally, use the from clause. Then follow this with another instance of dot notation that identifies the names of the existing table and database to be copied. Lucky Shrub are now ready to begin copying tables in their database. They want to carry out the process as follows. First, they need to copy the client's table to a new table called client's test in the same database. They then need to copy a few select columns to the table. Next, they need to make sure that all constraints from the original table were copied over to the new one. And finally, they want to copy a table from one database to another. Use your new knowledge of the copying tables process to help them out. First, let's review the clients table in the Lucky Shrub database by typing select * from clients. Then click Enter to execute the query. This generates the client table on screen. The table contains 4 columns: client's ID, full name, contact number, and location. For the first part of the test, Lucky Shrub need to copy the client's table to a new table called client's test in the same database. You can perform this task using the Create Table SQL query to create 2 statements. In the first statement, use a basic Create Table clause to create the new client test table. In the second statement, type the select command with the asterisk as shorthand for all columns. Then type the existing table name, which is clients. Finally, click Enter to execute the query. This query copies all columns and their data from the client's table to the new client's test table. To check that the query was successful, you can type the following statement: select * from client test. Then click Enter to execute. This query generates the client's test table, and the table contains a copy of all the data as required. Next, Lucky Shrub needs you to copy partial data only. They need to copy the full name and contact number columns from the client's table to another table. Begin with a Create Table statement, followed by the name of the new table, which is Client Test 2. Then use a select command. But in this instance, specify just the full name and contact number columns. Type the from keyword, followed by the name of the existing table, which is clients. Finally, use the where clause in the select statement to specify a condition. In this case, copy the data only for those employees who live in Pinal County. Click Enter to execute the query. The query's output shows the client's test 2 table, and the table contains a copy of all the data from client test for all employees from Pinal County. The test worked. Next, you need to make sure that all constraints from the original table were copied over to the new one. It's important to remember that copying data using the methods you've encountered so far doesn't copy the key constraints. You can check the constraints on the original table by typing and executing the statement. Show columns from clients. The query generates the client's table. The table structure shows all columns with the key constraints set for the client ID and contact number columns. Now let's check for these constraints on the client's test table by typing and executing the following statement. Show columns from client's test. This statement shows the client's test table. The table is missing the primary and unique keys defined in the original table. So how can you copy these keys? You can use the following statement. Create table clients test 3 like clients. The like keyword creates an exact copy of the existing table structure. Press Enter to execute the statement. Then type and execute the following SQL statement to display the new table structure. Show columns from clients test 3. The output shows an exact copy of the initial clients table, and all the key constraints have been copied as expected. Your final task is to copy the clients table from the Lucky Shrub database to the new test database. Begin with a Create Table statement. Then specify the new database and table names as testdb.clientstest. Type select * to instruct SQL to copy all data. And finally, add the from keyword followed by the existing database and table names, which are luckyshrub.clients. Click Enter to execute the query. Now you just need to check that the query was successful by moving into the test database. Type testdb, then show tables to reveal all tables in the test database. This statement reveals all the tables created in the test database, including the client's test table you just copied over from the Lucky Shrub database. And the table contains all the data from the original one. Lucky Shrub now have all the required copies of their tables in their database. You should now be able to copy data from an existing table to a new table within the same database, copy a table to a new location while ensuring it retains its constraints, and copy data from an existing table to a new table from a different database. Great work. Little Lemon Restaurant need to extract financial info from their database to complete their accounts. They can carry out this task using a subquery. Over the next few minutes, you'll explore the concept of a subquery and learn how to recognize a subquery and understand its syntax, identify scenarios in which a subquery can be used, and explain how subqueries are used to retrieve data. So, to begin, let's answer the question of, what is a subquery? As the name states, a subquery is a query within another query. In other words, it's an inner query placed within an outer query. The inner query is viewed as the child query and the outer query as the parent query. But what does a query within a query look like? Well, the best way to understand a subquery is through its syntax. As you just learned, a subquery is a query within a query, an inner or child query within an outer or parent query. The inner query or subquery executes first, and its results are then passed to the outer or parent query. You can also build multiple subqueries in MySQL. The outer query is presented like any normal query. It contains select, from, and where clauses. Likewise, the subquery is written as a standard query. However, the subquery must always be placed within a pair of parentheses. When executed, a subquery can return any of the following results: a single value, a single row, a single column, or multiple rows of one or more columns. A key advantage of a subquery is that you can compare it against other values using a comparison operator. You should be familiar with comparison operators from previous lesson items in this specialization. If not, here's a quick recap. Examples of commonly used standard comparison operators include equal to, less than, and greater than. There's also less than or equal to, greater than or equal to, and not equal to. Let's look at the syntax for subqueries and comparison operators. A subquery can be placed before or after a comparison operator in the where clause of your parent query. Now that you're familiar with the basics of subqueries, here's a demonstration of how they're used. Little Lemon Restaurant are reviewing their accounts and need employee salary data from their database. This data is held in the Employees table. The table contains 4 columns: Employee ID, Employee Name, Role, and Annual Salary. Little Lemon must use this table to identify which employees earn a salary higher than that of the assistant chef. You can use a subquery to complete this task. This query can be completed in 2 parts as follows. The outer or main query must extract details of all employees whose annual salary is greater than the specified value, and the subquery must identify the annual salary of the assistant chef. When executed, the subquery provides a subset of data from the employees database, and this subset of data is then used as an input for the outer query. Begin by writing the outer query as follows: a select command followed by an asterisk. Then the from clause, which targets the employees table. The next part of the outer query must filter out the employees table data based on the annual salary. So add a where clause followed by the annual salary column. Then add the filter condition in the where clause, the annual salary column followed by a greater than operator symbol. The greater than operator must target a specific value. But how do you determine what this value is? You can use a subquery. Write a subquery within your main query as follows. Add parentheses after your greater than operator. Within the parentheses, write select annual salary column from employees table. Then write a where clause followed by the role column. Finally, add an equals operator followed by the assistant chef value. Now that you've written both queries, press enter to execute. The subquery executes first and extracts the annual salary of the assistant chef. This value is now the input for the outer query's where clause. Next, the outer query is executed. The outer query's where clause filters out the records of all employees earning an annual salary greater than that of the assistant chef. In other words, the outer query filters out the values greater than the value retrieved by the subquery. The subquery's result shows that the assistant chef earns $45,000 a year. And the outer query shows that there are 3 employees who earn more than the assistant chef. These employees are the manager, assistant manager, and head chef. And that's an example of how the subquery is used in a database. You should now be able to recognize a subquery, understand its syntax, and identify scenarios in which a subquery can be used. Well done. Little Lemon Restaurant need to perform complex queries in their database, and standard subqueries might not be enough for this task. So they'll need to use multiple row subqueries with complex comparison operators. Over the next few minutes, you'll explore subqueries and complex comparison operators and learn how to explain how subqueries interact with complex comparison operators, and demonstrate the use of subqueries in a complex data retrieval scenario. As you might already know, a key advantage of a subquery is that you can compare it against other values using an operator. However, there are more complex operators that can be used with multiple row subqueries. The any operator returns data for any values that meet the specified condition. All returns data for all values, and the sum operator returns data for one or more matching values. Let's look at how to write multiple row subqueries using the all, any, and sum operators. These comparison operators let you perform a comparison between a single common value and a range of other values. They result in multiple records or target multiple values within a table. Subqueries can also be used with the exists and not exists operators. The exists operator tests for the existence of rows in the results set returned by the subquery. It returns true if the subquery returns one or more records. On the other hand, the not exists operator checks for the non-existence or absence of results from the subquery. Not exists returns true when the subquery does not return any row of results. Let's review the syntax for the exists and not exists operators. The syntax is very similar to a standard subquery. The key difference is that the exists operator is placed after the where clause to determine the existence of the value specified in the subquery. Or you can use the not exists operator to check for the non-existence or absence of results from the subquery. Let's look at a demonstration of how subqueries are used with these operators. The Little Lemon Restaurant need to identify all employees earning an annual salary that's less than or equal to the annual salary earned by all employees in the following roles: manager, assistant manager, head chef, and head waiter. The data required to complete this query is in the employees table. The table has 4 columns as follows: employee ID, employee name, role, and annual salary. You can extract the data required from this table using 2 queries. An outer query to identify all employees who are earning an annual salary that's less than or equal to the specified values, and a subquery that extracts the data of annual salaries earned by employees who are in the roles specified earlier. Let's begin with the outer query. It starts with a select command and an asterisk. Then add a from clause that targets the employees table. Next, write a where clause followed by the annual salary column name. Finally, write a less than or equal to operator. Now you must write the subquery within parentheses. Write a select command to select the annual salary column. Then a from clause to target the employees table. Next, write a where clause followed by a condition that extracts data from the role column. Finally, in parentheses, write the required roles: manager, assistant manager, head chef, and head waiter. These queries must return a result that lists all employees earning an annual salary that's less than or equal to the annual salary earned by all employees in the role specified. So, to ensure that you get the desired result, place the all operator after the less than or equal to comparison operator, but before the subquery. Then execute the query to return the output. The subquery executes first and identifies the salaries of the manager, assistant manager, head chef, and head waiter roles. These salaries are the values that the outer query uses. The values are $70,000, $65,000, $50,000, and 40,000. So the outer query filters out the employees who earn an annual salary less than or equal to all these values. The final output shows that the employees with IDs of 5 and 6 earn an annual salary less than or equal to the other roles. On the other hand, the any operator compares the results of the subquery to determine whether it can exclude records from the outer query that satisfy the conditions for any of the values returned by the subquery. Little Lemon's next task is to identify employees earning an annual salary that's greater than or equal to the annual salary earned by any employee in the 4 roles specified earlier. You can use the same query as before, but remember that this time you're checking for values that are greater than or equal to those in the subquery. So change the comparison operator in the where condition of the outer query to a greater than or equal to operator. Now, just before the subquery, replace the all operator with the any operator. Finally, press enter to execute the query. The output shows that there are 5 employees who earn a salary greater than or equal to the other roles. For their final query, Little Lemon needs to determine if their head chef and waiter are assigned to a booking. They can do this using the exists or not exists operators. The query involves 2 actions. In the first action, the outer query extracts details of employees, and in the second action, the subquery determines if the head chef or head waiter have been assigned to a booking. The required data is held in the bookings table. This table has 6 columns as follows: booking ID, table number, first name of guest, last name of guest, a column for each booking slot or time, and a column that shows the ID of the employee assigned to the booking. Begin by writing the outer query as follows: select asterisk from employees. Then add a where clause. The subquery must determine if there are any employees in the role of head chef or head waiter assigned to a booking. So add the exists operator after the where clause. Then write the subquery in parentheses as follows: a select command and an asterisk, a from clause targeting the bookings table, a where clause, and a condition that must return results for the required employees if they're assigned to a booking. Press enter to execute the query and generate the output. So the exists operator has checked for the existence of the specified results in the subquery, and it has found that these results exist. Therefore, the operator result is true. The result is that the outer query filters out the details of the 2 employees who are assigned to these 3 bookings. Now, let's replace exists with the not exists operator to see what results are returned. The output returns the same 3 records as before. However, the not exists operator checks for the non-existence of results from the subquery. Also in this case, the where clause filters out employees that do not exist in the results obtained by the subquery. This returns the results of 4 employees that don't exist in the subquery's results. In other words, this is the data for employees who don't meet the subquery's criteria and aren't identified in the results. You should now be able to explain how subqueries interact with comparison operators and demonstrate the use of subqueries in a complex data retrieval scenario. Well done. Lucky Shrub have had particularly good sales so far this year. They now need to identify the top 3 best-selling products to make sure they have enough quantity in stock for the next few months. There's a lot of data to parse through in their database, so they've decided the easiest way to identify the best-selling products is with the use of a virtual table or view. In this video, you'll explore views and then use what you've learned to help Lucky Shrub. And by the end of this video, you'll be able to explain the concept of views in database and demonstrate how to create, rename, and drop views in MySQL database. Let's begin by developing an understanding of what database engineers mean by the term views. Views are virtual tables created from one or multiple tables depending on the requirements. The view presents a table interface that lets the database users access and manipulate the data within the table using MySQL. So why do database engineers use views? Let's look at some common use cases. Views can be used to create a subset of a table's data. For example, a table might have 7 columns, but you only need data from 3. So you could create a subset from these 3 columns. And views can also be used to combine data from multiple tables. You might need to query 2 columns from one table and 4 from another. You can use views to combine both sets of columns into one virtual table. Now that you understand what views are, let's review the syntax. The syntax begins with the create command, followed by the view keyword and the name of the view or virtual table. The as keyword is then used to define the view table functionality. Next, use the select command to specify the columns the table must be built from. You can specify these columns using dot notation, making sure to include both the table and column name. For example, table1.column1 to select the first column in the first table. Then use the from keyword to specify the tables that the data must be extracted from. Finally, you can use the where clause and a condition to set data order and filtering rules. That's how you can create a view by extracting data from one table. However, creating a virtual view based on multiple tables requires a bit more effort. Let's find out more. When creating a view from multiple tables, much of the syntax remains the same. The key difference is after the select command. You must list the columns that you require from both tables using dot notation. You then need to create an inner join after the from keyword in which you join the 2 tables together. Then use the on keyword to determine the matching columns used to create the join. Let's take a closer look at the use of dot notation. Dot notation is used to link columns with tables. This is particularly important if you're dealing with multiple tables. Multiple tables might give rise to a potential conflict in names. For example, 2 tables could use the same name for a specific column. To avoid this, you can establish a link between each column and its respective table by placing a dot in between them. However, dot notation is optional if your query is only dealing with one table. The view syntax presents a clear 5-step process for creating a virtual table or view. Create the virtual table using the create view syntax. List the columns to be moved from the original table to the virtual one. Specify the original table from which data must be extracted to create the view. Set the conditions. And finally, set the data order and filtering rule. Now that you've been introduced to what a view is and been shown how to create one, it's time to see if you can assist Lucky Shrub. As you discovered earlier, Lucky Shrub need to identify their top 3 best-selling products with the use of a virtual table or view to make sure they have enough quantity in stock for the next few months. Let's use your new knowledge of views to help them out. You can create a virtual table or view for Lucky Shrub using the data in the orders and products tables in their database. Let's take a moment to familiarize ourselves with these tables before using them to create the view. The orders table has 5 columns that include information about the order ID, client ID, product ID, quantity, and cost. While the products table has 3 columns that include information about the product ID, item name, and price. Lucky Shrub want to identify their top 3 best-selling products. So to create the view, you only need data from the item name column from the products table, the order quantity, and total cost columns from the orders table. As you learned earlier, the key steps for creating the view lie in the syntax. So write a create command and the view keyword. Then write the name of the view, which you can call top 3 products. Include the as keyword to define the view table's functionality. Then use the select command and dot notation to target the required columns for your view. Next, use the from keyword to identify the tables. However, the view is created from 2 separate tables. So you'll need to join these tables together using inner join based on their matching product ID value. Finally, use order by to list the products based on the highest cost, with only the top 3 products appearing on screen in descending order. Execute the query to generate a new virtual table called top 3 products with the 3 required columns, item, quantity, and cost. You can now query this virtual table just like any other normal table using the following basic SQL statement. Select asterisk from top 3 products. The table prints the top 3 best-selling products along with their name, quantity, and cost. Why don't you try renaming the table to something shorter, like top products? You can rename a virtual table using the MySQL rename command. To rename the table, write rename table top 3 products to top products. This syntax is used to rename all types of tables in MySQL. In this statement, you just specify the view's current name after the rename table clause. Then you specify the view's new name after the to keyword. Finally, click Enter to execute the query. The table has now been renamed top products. What if you no longer require a virtual table? You can just drop it using the SQL drop command, drop view top products. Click Enter to execute the query. The view has now been removed and there's no impact on the original table it was created from. Thanks to the view, Lucky Shrub now know what their top 3 best-selling products are, and they can make sure that they have enough quantity in stock for the next sales period. You should now be able to explain the concept of views in database and demonstrate how to create, rename, and drop views in MySQL database. Well done. Congratulations! You've reached the end of the second module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you learned how to insert and update data and should now be able to explain the concept of the replace statement, outline how the replace statement is used to insert or update data in a database table, and demonstrate the replace statement following your completion of the projects in the lab environment. In Lesson 2, you learned how to work with values and constraints. Now that you've completed this lesson, you're able to identify the main types of constraints, explain how constraints work in a database, outline the MySQL on-delete cascade and on-update cascade options, and demonstrate your ability to utilize values and constraints as proven in the lab environment. You then moved on to the third lesson in which you learned how to change the structure of a table. Having completed this lesson, you're now able to add, delete, and modify columns and constraints in an existing database table. Copy data within and between tables and databases using the copy table syntax. You also demonstrated your ability to alter tables in the labs, and you reviewed the additional resources to learn more about these concepts. In the fourth lesson, you explored the concept of subqueries. Now that you've completed this lesson, you're able to recognize a subquery and understand its syntax, identify scenarios in which a subquery can be used, and explain how subqueries can be used to retrieve data. You also demonstrated your ability to work with subqueries in a lab environment. Finally, in Lesson 5, you learned about virtual tables or views. Now that you've reached the end of this lesson, you're able to explain the concept of views in a database, demonstrate how to create, rename, and drop views in a database, identify the advantages of using views in MySQL, and you completed readings in which you gained additional knowledge on the topics of views. Having completed this module, you should now be able to update data, work with values and constraints, change the structure of a table, and utilize subqueries and virtual tables. Great work! I look forward to guiding you through the next module in which you'll discover how to work with functions and MySQL stored procedures. The jewelry store Magenta and Gallo, also known as M&G, are reviewing client orders in their database. They must determine the average amount of money that each client has spent with the business. M&G can use numeric functions to extract this information. In this video, you'll explore numeric functions and learn how to identify common MySQL numeric functions and explain how these functions are used to process and manipulate data in a MySQL database. At this stage of the course, you've encountered some basic functions. So here's a quick reminder of what database engineers mean by the term functions in the context of MySQL. As you've learned in earlier lessons, a function is a piece of code that performs an operation and returns a result. Some functions accept parameters or arguments, while other functions do not. Functions are very useful for manipulating data in a database table. Broadly speaking, MySQL functions can be grouped into 5 different categories as follows: numeric functions, string functions, date functions, comparison, and control flow functions. You'll review each of these functions in more detail over the course of this lesson. The focus of this video is MySQL numeric functions, which can be divided into two categories: aggregate functions, which can be used on a set of values, and math functions, which perform basic mathematical tasks on data. You should already be familiar with aggregate functions, having used these previously in the course with select statements to calculate aggregated values. So let's just recap them briefly. Commonly used aggregate functions include sum, average, and max. There's also the minimum aggregate function and count. Now that you've recapped aggregate functions, let's look at some common math functions. A number can be rounded to a specific decimal place using the round function, and the mod function can be used to return the remainder of one number divided by another. These functions are a great way for M&G to perform additional tasks while also determining the average dollar amount that each client has spent with the business. But how can you and M&G make use of these functions in a MySQL database? You can build them into your SQL select statements. Let's review the syntax. The round syntax begins with a select command, followed by the name of the column to be queried. You then call the round function, followed by a pair of parentheses. Within these parentheses, write the required arguments. The first argument can be a column name or any numeric value. The second argument must be the number of decimal places. Finally, write the from keyword, followed by the required table name. The mod syntax is very similar. Just call the mod function instead of round. And within parentheses, identify the column or value and instruct MySQL what number to divide the value by. Finally, identify the table that holds the data. When working with the mod function, bear in mind that the first argument can be a table column or any numeric value, while the second argument must be the value by which the first will be divided. For example, M&G can use the round syntax and average numeric function to determine the average dollar amount each client spent rounded down to 2 decimal places. Let's take a few moments to explore M&G's database and find out more about how they make use of numeric functions. As you learned earlier, M&G are reviewing client orders and must determine the average dollar amount that each client has spent with the business. The company has a table called client orders that shows the average amount each client has spent. The table has 2 columns: client ID, which shows the ID of each client, and average cost, which displays the average amount each client has spent. However, even though this table shows the average amount, M&G need to round down these values to 2 decimal places. You can help them using the round function. Write select followed by the column names. Then call the round function on the average cost column. In parentheses, put the average cost column as the first argument. Then pass the number 2 as the second argument to round the value to 2 decimal places. Next, use the from keyword to target the client orders table. Finally, group by client ID. Execute the query to create the output and display all decimal places reduced to 2. In the next task, M&G are restocking their inventory and need to identify which items they've placed an even number of orders for. The data they need is in the table MG orders. The table contains several columns, but the ones you need to complete this task are order ID, item ID, and quantity. To determine if a given quantity is odd or even, you can divide the quantity by 2. The remainder is your answer. This can be done using the mod function. First, write select followed by the column names. Then call the mod function. Pass the quantity column as the first argument and the number 2 as the second argument. Execute the query. The query returns the following values: a value of 0 if there is no remainder when all data is divided by 2, or it returns just the remainder value. The output shows that an even number of orders have been placed for items 1, 3, 5, and 6. M&G have now completed their database tasks using common MySQL functions. And you should now be able to identify frequently used MySQL numeric functions and explain how these functions contribute to data processing and manipulation in a MySQL database. Well done. Magenta and Gallo, or M&G, are performing an inventory review. They require a list of item names and their available quantities. They can extract this data from their database using common MySQL string functions. Over the next few minutes, you'll learn how string functions can be used to perform tasks like this. And by the end of this video, you'll be able to identify common MySQL string functions and explain how these functions are used to process and manipulate data in a MySQL database. Let's take a moment to find out what database engineers mean by the term string functions. String functions are used to manipulate string values. For example, adding strings together or extracting a segment of a string. Here's a few examples of some commonly used string functions. The concatenation function is used to add several strings together. And there's also the substring function, which extracts a segment of a string from a parent string. Uppercase converts a string to uppercase, and lowercase converts a string to lowercase. Next, let's explore the syntax of these strings to find out how they're used in a MySQL database. A very simple example of a concatenation function begins with a select command, which calls a concatenation function. You then type a pair of parentheses in which you include the string values to be concatenated. Ensure both are contained within double quotes and separated by a comma. Then include the from keyword and the name of the table that contains the data. You can also use the where clause to specify a condition. A more complex example of the concatenation function might involve extracting string values from two separate tables. For example, the data that M and G require is on two separate tables, items and MG orders. M and G can pass their arguments in the select clause, identify the two tables they required in the from clause, and specify the condition in the where clause so that SQL filters the required data from the combination of the two tables. This example might seem complicated, but don't worry. You'll explore it in more detail in a few moments when you help M and G query their database. Let's continue to review string function syntax with substrings. The syntax of a substring function is similar, but there are three arguments contained within the parentheses. The first of these is the string itself. The next one is the start index, the point in the string at which the substring must begin. And length refers to the length of the string portion that must be extracted. Next, let's review the syntax for the uppercase and lowercase string functions. M and G often convert the values in one column of a table to uppercase and the values in a second column to lowercase. Here's how they perform this task. An uppercase string function begins with a select statement and uppercase function. In parentheses, write the name of the column whose values must be converted to uppercase. Finally, instruct SQL which table to target. A lowercase string function is very similar. The only difference is that the parentheses must contain the name of the column whose values are to be converted to lowercase. Next, let's look at how M and G make use of string functions in a MySQL database. As you learned earlier, M and G need a list of item names and their available quantities ordered in the format item name order quantity. The item details are in the items table and the order details are in the MG orders table. The items table records information on items in M and G's inventory within the following columns: item ID, name, and cost. The MG orders table records data on deliveries within the following columns: order ID, item ID, quantity, cost, order date, delivery date, and order status. You can extract the required data from these tables using the concatenation string function. Begin with a select command, then call the concat function and write a pair of parentheses. Within the parentheses, pass the arguments name and quantity. These are the names of the columns for your output. These columns stand for the items table and MG orders table, respectively. Then add a hyphen in between the arguments to combine them. Use a pair of single quotes for the hyphen and ensure all arguments are separated by commas. Use a from keyword to specify the two tables. Finally, use a where clause to specify a condition that filters the required data from the combination of the two tables. Then execute the query. MySQL extracts a table that shows the total quantity of each item in the inventory. The next task is to retrieve all string values in the order status column of the MG orders table in both upper and lower case. You can target the string values from the order status column using the upper and lowercase string functions. In your select query, call the uppercase function and pass in the column name order status. Then target the mg_orders table with the from keyword. Execute the query to retrieve all values in uppercase. To retrieve all values in lowercase, just type the same query again, but this time call the lcase function. Execute the query once more to retrieve all values in lowercase. As part of their next task, M&G are reviewing an order from a client. They need to extract the first name of this client from the clients table. The clients table records key information on clients and stores it in the following columns. The client ID column, in which the required client is assigned an ID of 1, the client name, address, and contact number columns. You can retrieve the information M&G need by using the substring function to extract the relevant part of the string from the table's client name column value. First, write a select statement and call the substring function followed by a pair of parentheses. Then pass in the client name column as the first argument to the substring function. Pass in the start index as the second argument, which is the letter K, or character 1 of the string. And pass in the length of the string portion you need to extract as the third argument. The client's name is Kishan, which is 6 letters long. So 6 is our third argument. Then identify the table to target with the from keyword. Finally, add the where clause with the client's ID as the condition. Run the query to extract the client's first name. You've now helped M&G to complete their database tasks using string functions, and you should now be able to identify common MySQL string functions and explain how they're used to process and manipulate data. Great work. M&G are reviewing some recent orders delivered to the store. They must determine how many days have passed between the date these items were delivered and the day they were ordered. They can complete this task using date functions. In this video, you'll explore date functions and learn how to identify common MySQL date functions and explain how these functions are used to process and manipulate data in a MySQL database. First, let's find out what date functions are. Date functions are used in a MySQL database to extract time and date values in a range of different formats. M&G often use date functions to identify key time and date details for customer orders. Commonly used date functions that M&G take advantage of include current date, which returns the date in year, month, date format, and current time, which returns the time in hours, minutes, seconds format. There's also date format, which is used to format a date according to a given format, once that format is valid in MySQL. And date difference identifies the number of days between two date values. Perhaps M&G can use the date difference function to find out how many days have passed between orders. But before you find out how, let's take a few moments to explore the syntax for these functions. In most instances, date functions are written as select statements. To extract today's date in year, month, date format, just type select, the current date function, and open parentheses. For the current time in hours, minutes, seconds format, type select, the current time function, and open parentheses. However, the syntax becomes a bit more complicated with date format and date difference. To change the date format, type the date format function and open parentheses. Within the parentheses, type today's date in standard SQL year, month, date format, enclosed in double quotation marks. Then input a valid MySQL format in a pair of single quotes. You can refer to the further reading section at the end of this lesson for a list of valid formats. To determine the number of days between two date values, type the select command and date difference function followed by parentheses. Within the parentheses, type the first and second date values in year, month, date format and ensure both are enclosed in double quotation marks. Then run the query to create the output. Now that you've reviewed the syntax for date functions, let's see if you can use this knowledge to help M&G. M&G need to complete a series of time and date tasks using date functions. The first of these tasks is extract the current date and time. To retrieve this data, just write select command followed by the current date function, and a second select command followed by the current time function. Execute these queries to return the current date and time. Now M&G needs you to format a date by displaying the month name of a given date. You can do this by using select and calling the date format function. Then pass in the order date as the first argument. Type the required format to get the full month name. Finally, identify the required table. Execute the query to create the output. For the final task, M&G must determine the number of days between the delivery date and order date for their most recent orders. As you discovered earlier, the date difference function can be used to complete this task. The delivery data is contained in the MG orders table. The table records delivery data within the following columns: order ID, item ID, quantity, cost, order date, delivery date, and order status. To complete this task, you need to focus on the values from the delivery date and order date columns. First, write a select query and call the date difference function. Pass the values from the delivery date column as the first argument. Then pass the values from the order date column as the second argument. Use the from clause to target the MG orders table. And finally, use the where clause to filter out the records that do not have a null delivery date. Once executed, the query reveals the number of days between the delivery and order dates for the most recent orders. M&G now know how many days passed between the delivery date and order date for their most recent orders. And you should now be capable of using common MySQL date functions to process and manipulate data. Well done. M&G are approaching the end of their business year and need to extract sales revenue data for each item in their inventory. They can extract this data using comparison functions. Over the next few minutes, you'll explore the concept of comparison functions. And by the end of this video, you'll be able to identify common MySQL comparison functions and explain how these functions are used to process and manipulate data in a MySQL database. So, what do database engineers mean by the term comparison functions? MySQL comparison functions allow you to compare values within a database. For example, the function can be used to determine the highest, lowest, and other values. A benefit of comparison functions is that they can be used with a wide range of values, including numerical, strings, and characters. Here's a few examples of MySQL comparison functions. The greatest function is used to find the highest value. Least determines the lowest value. And isNull is used as an alternative to the equals operator to test if a value is null. To demonstrate the syntax, let's identify the highest and lowest values from a table that contains numerical values only. The syntax begins with a select command, followed by the name of the required column. Often this is the column that holds the table's primary key or identifying attribute. Next, type the greatest function, followed by parentheses containing the names of the columns you need to compare. Then use the as keyword with a column alias of highest to ensure SQL returns the required values in a new table under this column. Next, utilize the least function in the same manner. Finally, identify the table to be queried. For example, M&G can use the greatest and least syntax to extract sales revenue data. They can target the last 4 business quarters and deliver the highest and lowest values from each. You'll find out more about how M&G can do this in a few moments. For now, let's look at the syntax for the final comparison operator, isNull. IsNull is often used with a select command, followed by the name of the required column. Then a from keyword is used to identify the required table. An isNull function can also be used with a where clause. The clause calls the isNull function and identifies the column it must pass through. Now that you're familiar with the syntax of comparison functions, let's take a few moments to find out how they're used in the M&G database. As you learned earlier, M&G require data on their sales revenue for each item in their inventory for the last 4 business quarters. The sales revenue data is contained in the sales revenue table. The table has 5 columns. One column called item ID, which identifies each item in the inventory, and an individual column for each quarter. M&G first need to identify the highest and lowest revenue each item brought in over the past 4 quarters. You can help them by using the greatest and least comparison functions, just like the syntax example from earlier. Start with a select command and list item ID as the first column. Then, to identify the items that brought in the highest revenue, call the greatest function and pass the 4 business quarter columns as arguments. Then create the alias highest. Write a similar line of syntax for the least function and assign it the alias of lowest. Finally, use the from keyword to target the sales revenue table. Once executed, the query's output presents the highest and lowest sales revenue values for each item over the last 4 business quarters. For example, the item with the ID of 1 was worth $138,000 to M&G at its peak, and $60,000 during its lowest sales period. M&G need to determine which of their most recent orders have yet to be delivered. The delivery data is held in the MG order table. The table contains 7 columns: order ID, item ID, quantity, cost, order date, delivery date, and order status. The delivery date column is your primary concern here. All orders yet to be delivered have a null value within this column. So you can use the isNull function on this column with the where clause to filter these orders. Begin by writing the select statement as usual, followed by an asterisk. Then use a from keyword to target the table. Finally, write a where clause and call the isNull function to pass through the delivery date column. Once executed, the query returns a value of 3. This is a true value for all records that have a null value for the delivery date column. M&G now have their required sales data, and you should now be able to use comparison functions in a MySQL database. Great work! M&G need to determine which items in their inventory are turning a profit and which items are making a loss. They can use a control flow function to carry out this task. Over the next few minutes, you'll explore control flow functions, and by the end of this video, you'll be able to identify common MySQL control flow functions and explain how these functions are used to process and manipulate data in a MySQL database. So, what are control flow functions in a MySQL database? Control flow functions let you evaluate conditions and determine the execution path or flow of a query. The most common control flow function used in a MySQL database is the case function. The case function runs through a set of conditions contained within a case block and returns a value when the first condition is met. Let's take a moment to explore how this function operates. The case function is held within a case block. It operates in a similar manner to an if-then-else statement. Once it finds a condition that's true, it returns the result. If no conditions are true, then it returns the value specified in the else clause. If there's no else clause and no conditions are true, it returns null. So, what does the full syntax of a case function statement look like? First, write a select keyword, followed by the name of one or more columns that contain the required values. This is followed by the case function, which denotes the start of the case block. Next is the list of conditions which are written using the when and then clauses. The case block is then closed with the use of an end clause. You can also add an alias for the expression, depending on the needs of your code. Finally, identify the table to be queried. For example, M&G can use the case function to identify which items in their inventory are loss-making and which ones have turned a profit. They can extract the sales data for each item from the sales revenue table. Any items with a value less than or equal to $25,000 are considered loss-making. Any items with a higher value are viewed as profitable. MySQL displays the terms profit or loss next to each item's ID depending on the result. Let's take a few minutes to explore M&G's database and find out how they extract sales revenue data using a control flow function. As you've just discovered, M&G need to check which items in their inventory have turned a profit this year. Any items that have accrued at least $25,000 in sales are considered profitable. All other items are making a loss and should be removed from sale. The data they need is contained in the sales revenue table. The table has 5 columns. One column called Item ID, which identifies each item in the inventory, and an individual column for each of the 4 business quarters. By checking if the value of the lowest quarter is less than or equal to 25,000, M&G can determine which items made a profit and which items made a loss. The easiest way to perform this task is by using the case control flow function. First, write the select statement and target the item ID column. This is the column you need to display results against. So, write the case keyword to begin your case block. In the case block, write when and give the condition with the least function. Then list the quarterly sales columns in parentheses. The next set of steps involves the operator and conditions. Write a less than or equal to operator, and write then to specify what information you intend to display if the condition is true. In this instance, you need to display the word loss. Then write the else keyword and specify what information must be displayed if the condition is false. In this case, it's profit. End the case block with the end keyword. Now you need to create the aliases and identify the table to be targeted. Use an as keyword to create the profit-loss alias. This is the name of the column that the results of your case query are placed in. Finally, write the from keyword and target the sales revenue table. Execute the query to extract the results. The results show that items 1, 4, 5, and 6 generated a profit, while items 2 and 3 made a loss. M&G have now completed their database tasks with your help, and you should now be able to use control flow functions when writing SQL select statements. Nicely done. Lucky Shrub often perform the same queries on their database every day, and each time they perform these queries, they have to rewrite the same SQL code again. There must be an easier way, right? Well, with MySQL, Lucky Shrub can use the stored procedures method to save a specific query as a block of code that they can then recall whenever required. Over the next few minutes, you'll discover how this works by exploring the concept of stored procedures. And by the end of this video, you'll be able to demonstrate an understanding of stored procedures in a MySQL database, and create and drop simple stored procedures in MySQL. So, let's begin with an overview of what database engineers mean by the term stored procedures. A stored procedure is a block of code or pre-prepared query that can be stored in your database. You can then invoke or call the stored procedure using the call command. There are a lot of benefits to be gained from using stored procedures. With stored procedures, your code is more consistent. Your code is also reusable. You no longer need to write the same SQL statements repeatedly. And your code is also easier to use and maintain. Next, let's explore the syntax to get a better understanding of how the stored procedure works. First, to create a basic stored procedure, write the create procedure command. This must be followed by the name of the procedure and a pair of parentheses, which hold a list of parameters. This parenthesis is required even if your stored procedure contains no parameters. Then write the rest of your procedure logic as required. For example, if your procedure must select all data from a table, then write a select command with an asterisk and the from keyword followed by the table name. When writing a stored procedure with one or more parameters, the syntax is much the same. The key difference is that you must include all required parameters within the parentheses. Then write the rest of your procedure logic. Once you've created the stored procedure, the next step is to invoke it. To invoke a procedure, you can use the call command followed by the procedure name. Make sure to include the parentheses. But what if you no longer required a stored procedure? How do you remove it from your database? To delete a stored procedure, you can use the drop procedure command followed by the procedure name. In this instance, you don't need to include any parentheses. As you learned earlier, Lucky Shrub make heavy use of the same queries in their database. For example, they often need to query the list of products in their database products table to find items for customers or check what's in stock in their store. However, they need to rewrite the same query each time they interact with the products table. It's a time-consuming process. Why don't you use your new knowledge of stored procedures to help them create a reusable query? Lucky Shrub need to create a stored procedure that can extract all data from their products table. The table holds data on all products in the store and is divided into 3 columns. The product ID column, the item column used to list all products by name, and price column, which lists all prices rounded to 2 decimal places. To create a stored procedure that returns all data from the table, you can write the following syntax. Begin with the create procedure command, followed by the procedure name. Since the goal of this procedure is to return details of all products, you can call it get products details. Then add parentheses. This stored procedure doesn't require any parameters, so you can leave the parentheses empty. Next, write a select command and an asterisk symbol to instruct MySQL to extract all data. Finally, write the from keyword and target the products table. Click Enter to run the query. The new procedure getProductsDetails has been created. Lucky Shrub can now call this query to extract data from the table instead of rewriting a new select statement each time. To demonstrate the stored procedure, just write the following call command. Call getProductsDetails and parentheses. Click Enter to run the procedure and extract a set of results that includes all product data. Lucky Shrub also frequently write queries to identify the lowest priced products in their database so that they can add these items to sales or promotions. You can create a stored procedure with one or more parameters for this query. Begin with the create procedure command. Then write the procedure name. You can call it get lowest priced products. In parentheses, you need to declare the parameters, lowest price and the integer value. These parameters return the lowest integer values in the form of a table column called lowest price. Next, write a select command and an asterisk symbol. Then write the from clause and target the products table. After the from clause, include a less than or equal to operator, followed by the lowest price parameter. Click Enter to execute the query. In this statement, you've declared a parameter with an integer data type that must pass an integer value into the stored procedure. However, don't forget that this query also includes parameters. So each time the query is called, you need to specify the value the stored procedure must process. As an example, let's return the data of products with a price of less than or equal to $50 by typing the call command, the get lowest price product stored procedure name, and placing the value of 50 in parentheses. Click Enter to execute the query. The query passes the value of 50 to the stored procedure through the parameter. The output appears on screen with a list of all products priced less than or equal to $50. Finally, Lucky Shrub have decided to remove the getProductsDetails stored procedure from their database. To drop the stored procedure from the database, type drop procedure command and the name of the procedure, getProductsDetails. Click Enter to execute the query. The stored procedure has now been dropped from the database. Lucky Shrub can now perform queries in their database much more efficiently thanks to the use of stored procedures. You should now be able to demonstrate an understanding of stored procedures in a MySQL database and create and drop simple stored procedures in MySQL. Well done. Congratulations! You've reached the end of the third module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you learned about functions in MySQL and should now be able to explain the concept of MySQL functions, differentiate between common types of MySQL functions, and make use of basic MySQL functions in a MySQL database. And you demonstrated your knowledge and skills with MySQL functions in the labs and quizzes. The MySQL functions that you encountered included numeric functions, which are used to aggregate data or perform mathematical operations, string functions, deployed on string values in a database, and date functions, which return time and date information. You also explored comparison functions and discovered how they can be used to compare values in a database. And finally, you learned how control flow functions are used to evaluate conditions and determine the execute path of a query. In the second lesson, you explored stored procedures and should now be able to explain the concept of stored procedures in a MySQL database and create and drop simple stored procedures in MySQL. You also demonstrated your skills in a lab environment. Having completed this module, you should now be able to make use of functions and MySQL stored procedures. Great work! In this course, you learned about database structures and management with MySQL. Let's take a few moments to recap the key topics that you learned about. In the opening lesson, you received an introduction to MySQL. During this introduction, you learned about databases, discovered how Meta makes use of MySQL databases on a day-to-day basis, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned how to filter data. In this lesson, you learned how to filter data using the and, or, not, in, between, and like logical operators. Combine conditions with the use of logical operators. You learned how to identify wildcard characters and explain how they're used to filter data. And you then demonstrated your knowledge of data filtering in a series of knowledge checks. In the next lesson, you explored the concepts of aliases and table joins. You can now explain the concept of an alias and demonstrate how they're used in a lab environment. Outline what a table join is and explain different types such as inner, left, right, and self joins. Demonstrate how to join tables, and make use of the union operator in a MySQL database, having completed the video and demonstrated your skills in a knowledge check. You then learned about grouping data. Use the MySQL group by clause to group rows and deploy it with aggregate functions. Demonstrate the use of the MySQL having clause to apply filter conditions. Make use of the any and all operators. And you demonstrated your ability to group data in a lab environment. Next, you began the second module, in which you explored different techniques for updating databases and working with views. In the first lesson of this module, you learned how to insert and update data. You can now update and insert data using the replace command. Identify the main types of constraints like key, domain, and referential, and explain how they function. Add, delete, and modify columns with the use of the alter table command, and make use of subqueries. You then learned about views in MySQL databases. You can now explain the concept of views, create, rename, and drop views in a MySQL database, identify the advantages of using views, and you demonstrated your knowledge and skills with views in a series of knowledge checks and ungraded labs. In the third module, you were introduced to functions and MySQL stored procedures. You can now explain what a function is and identify different types of functions. You can use numeric functions to aggregate data or perform mathematical operations. You can manipulate string values using string functions. Extract data on time and date values with the use of date functions. Compare values using comparison functions. And you can deploy control flow functions to evaluate conditions and determine their execution path. In the final lesson of this module, you explored the concept of stored procedures. You can now explain what stored procedures are in a MySQL database and create and drop simple stored procedures in MySQL. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. You've reached the end of this Meta Database Engineering course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your database journey, and you should now understand database structures and management with MySQL. You were able to demonstrate some of this learning along with your practical database skill set in the lab project. Following your completion of this course in Meta Database Engineering, you should now be able to filter, join, and group data, insert and update data in a database using constraints, subqueries, and views, and deploy functions and stored procedures in a MySQL database. The key skills measured in the graded assessment revealed your ability to demonstrate your knowledge of key MySQL topics like filtering, joins, and data grouping. Explain database concepts related to virtual tables, data integrity, and subqueries. And exhibit your experience with functions and stored procedures. So, what are the next steps? This Meta Database Engineering course has given you an initial introduction to several key areas. You probably realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for the next course? You'll continue to develop your skill set during each of the Meta Database Engineering courses. In the final lab, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of database systems. The lab consolidates your abilities with the practical application of your skills. And the lab also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses, you'll receive certification in Meta Database Engineering. The certification can also be used as a progression to other Meta role-based certifications. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. Meta certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.